Hello, everyone. Welcome back once again to our day two of React Day Bangalore. Um, I welcome you all once again. Hope you've had your coffees and you're all ready for our second day. We are really looking forward to all the talks lined up for today. Yesterday was just a roller coaster. We had so many great talks, learned so many things, and I hope that today we learn even more things. And really excited to be uh, coming and hosting this conference again. So I think before we get started, let me just again introduce my co-MC, Megha. Megha is a front-end developer who is a sucker for communities, and she helps run the product folks community. When she's not found coding, she's probably painting or playing games. So over to you, Megha.
Hello all. I'm really glad that all of you joined today as well. I also hope that you had a great day yesterday. I'll also start with introducing my co-MC Tanisha. Tanisha works as a software engineer at Gamescraft, and she's such a sucker for anything around communities, front-end ecosystem, React, Tech, Twitter. You just name it, you will find Tanisha there. This year she has upgraded herself from being a speaker to MC by my side, and I'm really glad she's doing a great job at it. So yeah, we look forward to even greater day tomorrow today. Just like tomorrow, just like yesterday, we have a line of great speaking sessions as well as one panel waiting for you. So just gear up and have a wonderful day with us. If you're joining today for the first time, let me give you a platform overview. It's just same as it was yesterday. If you are seeing this, you are probably on the stage area, which is also like the main area. Here, all the sessions would happen. Here, you can see the speakers talking and everything. And on side, you have a comment box where you can chat with the speakers. Apart from this, there is sessions tab where speakers will take questions after the sessions. So anything you want to discuss with them one on one, you can do that. And we have a expo session which is very happening. To be honest, I was scrolling through tweets yesterday, and there's a lot happening in the expo section. You can find our sponsors there, interact with their team, know how their engineering works and everything around it. So these are the main sections, and yeah, this is how you navigate.
So again, if you're joining for the first time today, don't forget that we have so many giveaways lined up for you. So make sure you're tweeting your learnings with hashtag React Day in 2022 and hashtag TIL. If you have any fun screenshots of us, the speakers, or any co-participants, make sure you tweet that as well with hashtag React Day in 2022 and hashtag fun. And mind you, the best entries will win a lot of goodies. As Megha mentioned, there's a lot of things that are happening in the expo with our sponsors, awesome discussions, plus bonus giveaways. So make sure you visit the expo as well. And tweet your React funds with hashtag React Day in 2022 and hashtag funny and get your funds featured in the conference. So make sure your hands are all on Twitter and we see you tweet. So, before we move on to our first talk, let's just thank our partners and all the people who were involved in helping us promote this event. If it were not for their efforts, we would not have had such a wonderful event. And alongside our partners, I would also like to thank our sponsors, which made this event possible. And again, these sponsors would be hanging around in their expo session, just go around, have a chat with their team, or participate in their giveaways and have an awesome day to day. With that, without wasting any time, just to give you a brief of the code of conduct. Be respectful to everyone. Do not ask irrelevant questions. Please stick to the point. And DM us at React Day India for any issues. So enjoy the second day with us. Without any further ado, let's get the talks rolling. Uh, Over to you, Megha. She will take you forward for the first half of the day.
Yeah. Thank you, Tanisha. So, yeah, let's get started. I hope all of you are awake. And I would like to welcome our first speaker. We have Kamal with us, and he will be talking about improving performance of uh, React and Electron apps. Kamal is a staff engineer at Postman, and he has been working around Electron apps for a while now. As we are progressing every day, we are making our apps faster. So, what's better than learning more around performance? My mind is currently flooding with a lot of Kamal puns that he will like do Kamal on the stage and everything, but I'll hold them and like let Kamal present his talk first. So the stage is yours, Kamal. Get up.
Hello everyone. Thanks for the introduction, Mega. I hope like you all had a great day one, and it's great to be like starting day two of this exciting conference. So I'm Kamal. I am a front-end developer. I like building web applications. I like building web applications using React, and I also have been working with Postman on their web and Electron applications. And I also lead a team at Postman focusing specifically on improving the performance of the desktop app. So I thought, why not like do the best of all three worlds and talk about improving performance of an Electron and a React application in this talk itself. So Electron is basically a cross-platform application that let you build like desktop apps by using your knowledge with JavaScript, HTML, and CSS. So Electron claims that if you can build a website, you can build a desktop app. So it got me thinking. So if you can take the learnings of building a web application and build a great desktop application with it, can you also take the learnings of improving the performance of web application and improve the performance of desktop apps using the same concepts and principles? And can you also learn new stuff by looking at Electron application specific constraints and extend them into the web app and improve your React app as a side effect as well? So in this talk, I'm going to be covering a few details about what are the tips and tricks that you can use to extend and improve the performance of your Electron and React applications. And even if you're not building an Electron app, some of these concepts might also extend into your normal React web app as well. So just to get started with like Electron, it is really easy to get started with a very basic Electron. So on the Electron app, on this screenshot, you see Electron Fiddle, which is a tool equivalent to Code Sandbox. It helps you put together quick demos with Electrons across with Electron app across multiple versions. So just to kind of show an idea of what this looks like, you just have an entry point file that you can call main.js, and then you can point Electron to that entry, which basically spins up a new app like this, which gives you the user interface for the Electron application. So all you need to do to get started with an Electron application is a very simple Node JavaScript file called main.js. And in this file is where you're going to be starting to open a new UI window. And in the UI window, you can point it to an index.html, which is going to be your React or web application using HTML, CSS, and JavaScript. So now let's talk about how you would normally approach performance on a web app. So you're probably thinking at this point, can I use the same core web vitals metrics? Can I use the same dev tools like performance dev tools, memory dev tools, or Lighthouse dev tools on Chrome that you're usually used to and like have a lot of advantages with? Can you use all of these into Electron apps as well? So the answer to that is yes, you can. Core Web Vitals also work within Electron apps, and all the Chrome dev tools by default are also available within Electron apps as well. So which you can use them to profile and improve the performance. But there's a slight difference in some of the areas on how Electron apps work and how web apps work. And that might be a surprise to you if you're not paying close attention to it. So let's start with some of these areas as well. So the first thing that the user is exposed to over your Electron app is how quickly can it start up, right? This is equivalent to how soon can your web page load inside a browser tab. So let's talk about what impacts the startup performance of an Electron app. The first thing to keep in mind is launch performance on Electron is slightly different from load performance of a normal website. And the reason for that is your application lifecycle actually starts much earlier than the user interface or the UI window. So you're responsible for starting your application right from the user clicks on the icon inside your shortcut of Windows or inside the launcher of your Mac or Linux operating system. So let's look into what happens actually before you even start opening the first UI window inside an Electron app. So on the right-hand side, you have a snippet of a very small Electron app, which basically has the code to spin up an empty UI window. But you also have this function that's pretty much just downloading catfix. And you have all the node modules that you need to power that function. This unsuspecting require statement to the request node module might actually have subtle impact on how fast can you open the UI window in an Electron app itself. So let's take a deeper look into what does this require statement actually mean in terms of the loading performance. So if we do a deeper performance profile on this particular statement, what we can see is that just importing that node module can block the main thread for about 300 milliseconds, which is essentially delaying the time it takes to open the first UI window by 300 milliseconds and subsequently delaying every other step in the startup performance, which actually means that you're going to be pushing the launch time about half a second or even more. Not to dunk on any particular module, but each module is written with a specific set of use cases and specific set of audience in mind. In this case, the request module is actually extremely powerful and capable with a lot of capabilities, even coming with its own entire database of all the possible MIME types of every single request type itself. But in this case, just to make a request to a URL, you might not need all of these capabilities. So a solution to this problem might be very careful in importing what modules you actually need and inspecting into the cost that they bring into your application lifecycle itself. So the solution is a slightly refactored version of this code where we are just using an alternate library. So you can use a lightweight library for Node like Axios to make requests instead of the request library, or you can also use the Node.js standard library, which I've kind of demonstrated here with HTTPS. I've also indicated another slight change. So instead of having all your required statements in the file at the top, which is essentially blocking every step of the app launch until all the modules are compiled and executed, this essentially defers all of these modules right until when you actually need them. So the user only pays the cost for these modules only when they enter the flow, making the critical launch path completely open to the important aspects at that time. So now we have talked about what happens before you open the first UI window, right? So let's talk about how do we get UI into the UI window. For an Electron app, there are two ways that you can do this. The first way is to point your Electron application into the URL of your web application, which is very, very close to how you would normally build a React or a web application itself. Just point a URL to your app and then load that into the UI window, and then you have an Electron app with your user interface. The alternate approach that you can do is also package all of your content, the index.html, the JavaScript, the CSS, and the font files together with your Electron app and just point them directly into the UI window as a local reference. Now, there are subtle differences in how these choices impact the launch performance, and that's what we'll go into in depth right now. So let's talk about what happens when you point a URL into the UI window of an Electron app itself. So it's very easy to kind of reuse some of the tech stack and the tooling and everything available to spin up and maintain a web app and extend the benefits of all of that into your Electron app as well. So immediately the advantage of that is going to be to improve and extend all the advantages of techniques like static site rendering, static generation, server-side rendering, or other techniques. But you also have to keep in mind that you're dictated by how soon can you deliver content over a network that is dependent on the user's current conditions. That is going to impact how fast can you launch your application. But this is also very similar to how your normal web app opens in a browser itself. So you can extend the same performance optimization techniques like code splitting, lazy loading, and all of those tips and tricks. Those will also work inside Electron app and giving you like a good enough boost itself. You can also prioritize the content closer to the location of the users by opting into CDN and caching the content on CDN. If you're using a framework like Remix or Next.js or any other typical React or web framework, you might actually be getting all of these advantages enabled by default. If you're not, then definitely look into turning them on in your current tech stack. The last point that I want to go a little deeper into is talk a little bit more about extending lifetimes of JavaScript assets in your Electron application. This will come in very handy when you are powering an Electron application that is frequently used. So one of the advantages of having an Electron app is you know exactly that your users are using Chromium technology, because that's what powers an Electron app. And you also know that it is going to be dictated by the unique behaviors of how V8 and Chrome work. You can use this to your advantage by tweaking your application to work really well and taking advantages of the V8 and Chrome optimization techniques. So the one thing that I want to go a little deeper into is how Chrome and V8 cache JavaScript assets. So let's look into what happens if we just provide a JavaScript URL into an application. The first time Chrome is trying to execute this JavaScript, it is going to download the file from network, and then it is going to cache the content of the file on disk and then pass it on to V8. So at this point, V8 tries to compile the JavaScript file and then execute the JavaScript file. The second run of this execution, Chrome does it slightly differently. Instead of downloading the content from network, it is actually going to reuse the cached version of the JavaScript on disk and pass that on to V8. And there's also another difference in the second step, which is V8 also now instructs Chrome to cache the compiled version of the JavaScript as well. This is a heuristic that Chrome and V8 use internally to specifically optimize repeated visits to web pages. And it comes in really handy when you're working with an Electron app, especially if the user has shown an intent to download their app on their machine, which means they're signaling to you that they are coming back to it again and again. This improvement comes in really handy when the user launches their app the third time or beyond, where Chrome can now take both the contents of the file from disk and the compiled output of that and pass it down to V8. This makes V8 very easy to completely skip the compilation altogether and directly go into execution. This can really improve the performance of JavaScript in the blocking steps of the app load lifecycle itself. Now, these techniques come in very handy for an Electron app that might be used multiple times, but it is also something that will work definitely on any web application as well. There are a few ways where you can increase the lifetime of your JavaScript to specifically take advantage of this particular optimization in V8. One of the things is to make sure you are splitting your code chunks between the parts of the app that change frequently and the parts of the app that change less frequently. You can do that with libraries like React or React DOM or your design system or any other node module that you rarely update within your app and extract them into separate chunks. You can also fingerprint those assets so your URL to that asset does not change unless the actual content of that asset changes. You can also cache these on CDN and set a really long lifetime for that on the cache control header over the CDN, which makes it a signal to the browser to use the local version and not go to the network every single time it tries to encounter that file. So now let's talk about the alternate approach of packaging all your content together with your Electron application. What might be the subtle impact of loading content from your users' local operating system and local disk as compared to downloading them over network? So the first factor that it differentiates is you're now restricted to fully doing compute on your user's device, which prevents you to do any other optimization, and you're completely restricted to doing client-side rendering inside an Electron app. However, loading files from the disk can actually be faster than downloading the assets over a network, which is very much dependent on the user's condition at that point in time. However, reading files still come with an IO and a compute cost. So you have to keep in mind that you don't include really large files because passing compilation and execution of these large scripts can still block the main thread and impact the launch performance of your app itself. So use the techniques like code splitting and lazy loading, even if you're packaging your content locally. The last caveat here is code compilation optimization of V8 does not really extend to files that you're packaging locally. So if this is really important to you, then you can explore an alternate technique like V8 snapshot, which helps you manually generate the cached output and then package them along with your app to get that advantage as well. So we've talked about how the app launches before the UI window and how you can render content into the UI window. So now this is where you are talking about the application's implementation. Since an Electron app does not really have a URL, by default, most of the Electron apps stick to restoring the session that the user had before they quit the app last time. This actually means that you're going to put the user back into some of the state that was in the user's session in the previous session of their app itself. For apps like VS Code or Chrome or like Postman, this might actually have a lot of multitasking capabilities. Like you might have a lot of files open in your VS Code. You might have a lot of requests open in your Postman, which means when restarting your app, you're also simultaneously restoring all of these content at once. So one of the techniques that you can do is to prioritize rendering the hot path or what is really important to the user in this flow, and defer the rendering of any UI element that are in the periphery or in the background. This technique will help you get the user unblocked with their critical workflow first, and then do a lot of the stuff in a deferred fashion until the user actually requests for them. So this pretty much covers what you would have to keep in mind to start the Electron app and what the startup performance of the Electron app actually entails. Now let's go into like what happens after you've launched the app, right? Because if you want a really good experience, it is not just about startup, but also about every single interaction needs to be buttery smooth throughout the entire session of your application itself. So we've all kind of like explored the impact of what happens on a browser if we really block the main thread. Let's just kind of look at that a little bit like once again here, right? So I have a very small code sandbox that is a small React application. So in this app, I just have a counter that is updating every 200 milliseconds. And I have a button that is basically going to simulate a long task on the main thread by just blocking the main thread for 3 seconds. I also have a GIF that to highlight like painting aspects of the web page itself. So now let's see what happens if I just start a long task on the main thread. So you can see the Chrome still continues to paint and composite the GIF, which makes the GIF responsive, but the counter just completely stops, right? This is because the main thread is completely blocking all the intervals, any JavaScript execution, or any layouting that might be happening at that point in time. So now this problem also applies to any Electron apps as well. So let's look into what can we do about that, right? So some of the times this actually might be a side effect of re-rendering large React components. So apply the techniques that you would normally use to split them up into smaller re-renders or even defer unneeded re-renders in some React components. If you also have background tasks on your UI window that are running long tasks on the main thread, split them up into smaller chunks or defer them into web workers that keeps the main thread idle. Let's look into what is different with an Electron app. So an Electron app has this new concept called a main process or a browser process, which acts as an entry point and an orchestrator for everything else that is happening inside your app. So it orchestrates opening a new window and coordinating between windows, and also like interfacing with operating systems and getting all of these workflows together. Now, what happens if we run a really long and blocking task on the main process of Electron? So let's look at a small demo of what this would look like on an Electron app. So I have a small Electron app, which is very much similar. There's a set timeout set interval updating a counter every 200 milliseconds. I have an input box to indicate like what happens for the user interface. And I also have a button simulating a long task, except this time it is running on the main process of Electron. So let's look at what happens if we run a long task on the main process of Electron. So you can see that the counter continues to run, the GIF continues to render, but the important aspect is that you saw the cursor completely get stuck. And let's look at what happens if we are typing into the input box. So you can see none of my characters appearing into the input box, and they appear only after I have finished my task. This is because the input is actually a native element, and the Electron app requires on the main process to communicate between the UI window and the operating system to get this workflow working. So running any long task on the main process is going to make the app sluggish and prevent these type of interactions to be buttery smooth in your app. So what can you do about them? You can also split up your tasks on the main process into smaller chunks. But most importantly, do not run complex or long tasks on the main process. You can fall back into web workers to run these long or complex tasks, or you can even spin up new node process or a completely hidden background window where you can defer some of these background activity into and keep both the main thread inside the UI window and the main process of Electron idle to have a really buttery smooth responsiveness inside your app. So far, we have covered like techniques for all the cases where you are in full control of your application, but there are some conditions that are beyond the control of the developer. Let's say the speed of the internet in which the user is accessing your systems, or the hardware devices through which they are downloading your app and using them, right? So you might also want to make sure that you have a slightly progressively degraded version or an equivalent of that working even if the user is completely offline or working from a slow network. If you are using a remote origin to render the content into your Electron app, you might be completely dead if the user opens the app when they are offline. To work around this problem, you can install a service worker, which will help you intercept the request even if the user is completely offline with no internet connection. And you can use that to either provide a partially degraded or a fully functional experience on the user's machine without any internet by taking advantage of persistent storage like IndexedDB or even like SQLite file system inside your Electron app itself. So we've covered in depth into a lot of topics into how we can improve the performance of the app, but this is not a one-time step, right? So if you've been looking at improving performance on your hobby project or your or the place where you work, you always know that performance work is not a one-time task, and it's a continuous, rigorous cycle of dedicated efforts going into it. So I wanted to close this talk by covering a little bit more into how you can have a really effective and a functional loop to repeat this process over and over again to have a really great experience over a longer periods of time. So in my opinion, this process kind of starts with making sure you have a very clear idea of what performance means in your use case. Understand what your product does and measure exactly what flows you want to focus into. Investigate those workflows using the tools that are available to you and find out what the biggest bottlenecks are. Apply some of these techniques that we have covered today to improve the performance of those bottlenecks, and add regression proofing systems to make sure you never encounter the same problem again in the future. And now you go through this loop again, and doing this over and over again will help the users continue to get the benefits of performance over a longer period of time. So now I want to close this talk by sharing some of my insights into doing this loop so far. So the first thing is to look at what are you focusing on as a key metric that you want to focus on for performance work, right? Core Web Vitals are really good, but they are a very generalized version that is intended to work for all websites and all web pages. But you know your app the best and you know your users the best. So the first starting point is to understand what is the most important thing for your users. What is the golden workflow that is the most critical part for your application? So when talking about performance, VS Code maintainers mention that the most important thing that you really need to get to in a VS Code IDE is to launch the app and have a blinking cursor as soon as possible so you can start working with your files. In terms of Postman, it could actually be launching the app and getting to a point where you can send a request as quickly as possible. Use this technique to find out what is most important for your app, instrument that, and focus your efforts into improving that workflow. Let me also cover a little bit into differences between lab and synthetic metrics versus real user metrics and field data. Some of the tools like Lighthouse and PageSpeed Insights help you get understanding of like where the problems are and dive a little deeper into what is causing some of these side effects. But they give you a single metric which kind of gamifies the whole system, right? But it doesn't give you a complete picture because you're looking at one sliver or one particular variant of the whole possible combinations in your app. The important thing to look at is what is your real user metric look like? Right? What is the field data of the actual user experience for all of your applications? Tools like Lighthouse have now started to surface this information a lot more prominently these days, but they are again limited to only core web vitals. Use this technique to find out what the business metric for your app is and collect that with the actual usages over time. Now it will start to show like interesting insights to you, and you will immediately notice that performance no longer becomes a single number, but a distribution over different spaces. So in this case, you'll notice that like you have a really a high peak for average users, but you also have a long tail of users who are using your app under varying conditions, getting severely degraded experiences over time. The other caveat to know and understand is know and be aware of where your blind spots are. This is a graph that depicts the load times of Postman application across different platforms. And you can see a really fast experience for a large number of users who are using Apple Silicon hardware as compared to like Intel Mac or a normal Windows machine. So now if you are a developer and you are interacting with your app and you're interacting with your team who are primarily only using a really high powered hardware, you might be finding it hard to empathize with the users who are facing a degraded experience on low-end hardware or low-end network conditions in the extreme cases of the app usage. So understand where your users are from and try to simulate your lab environment to be as close to what your user environments are. Invest in tooling and hardware to help you get to that as much as possible. If you're not able to invest in hardware to get closer to that, use tooling like Chrome DevTools for network throttling and CPU throttling to help you simulate as much as possible to where your actual users are using your application. Finally, after all of these improvements, what you really want to make sure is not to ever face the same problems again. So simplest ways to do that is to set up like bundle size regression tests, which is very easy to set up and also very helpful in a lot of cases. But again, this only covers like one portion of the launch experience. You can also orchestrate end-to-end workflows for the key business workflow that you have identified using tools like Lighthouse CI or Web Page Test or Neuralink Synthetics. And I'm pretty sure there's a lot more like out there. This will help you cover tests for web applications. You can also use tools like Selenium or WebDriver to test parts of Electron that you cannot test with these technologies or tooling. So that's everything that I wanted to share that will help you kind of take some of the learnings of improving performance on web and extend them to Electron and also like vice versa. And if you feel this topic interests you, I've also linked to a few resources where you can dive a little deeper into it. And if you also want to reach out to me, feel free to reach out to me on Twitter if this topic interests you. So that's me. Thank you.
Great talk, Kamal. First of all, apologies that I called you Kamal instead of Kamal. I have a friend with same initials. Really like the part where you shared about like performance of like offline apps. Never really thought around those lines before. So really, really great talk. If you any of you have any questions to ask to Kamal, you can go to the sessions tab and you can like interact with him there. Um, let's move on to our next talk. I am pretty sure a lot of you are waiting for this one. So next up we have Shivam with us. Shivam is a software engineer at Invact, and he's gonna share with us how to crack a web-based metaverse experience using WebRTC. I am personally looking forward to this talk a lot because of my personal interest in theory. So yeah, I'm gonna like leave the stage now and quietly listen to this talk. So the stage is yours, Shivam. Go ahead.
Yeah, thank you, Mega, for such good introduction. So, hello everyone. Very good morning to all of you. And we'll today's my talk is about cracking a web-based metaverse experience with WebRTC, featuring 100 ms. Just a heads up, not a sponsored talk. Just a shout out to something I liked about 100 ms. So yeah, we'll start. Okay. So cracking a web-based metaverse experience with WebRTC. So before that, a little bit about myself. So I'm a software engineer previously at Invac, and I work primarily with JavaScript and TypeScript. And this is my tech knowledge. So while at Invac, I was given the chance to work on the metaverse, which I was lucky enough to crack. And yeah, I was responsible for creating the real-time multiplayer and the challenges which we faced around that. We'll look into that. So enough about me. Let's get started. So what will this talk will be covering? So we'll be not going too deep into hands-on implementation of WebRTC server and the client side. We'll look onto the concepts which are responsible for making WebRTC possible and the protocols behind WebRTC as well as the browser APIs. Then we'll look into like should you write your own implementation of WebRTC or not. Then we'll touch upon the basics which you need to know for creating your web-based metaverse experience and relaying how to relay data using WebRTC for a real-time multiplayer effect and the performance issues which come with it and what is interpolation and how will we achieve it and optimizing the client to reduce re-renders. Cool. So let's get started. So what is WebRTC? So WebRTC, for those of you who are not aware, stands for Web Real-Time Communication. It is responsible for creating the audio-video based apps which run peer-to-peer and make real-time communication possible without requiring any extra plugins or intermediary software. It is an open source project backed by the big giants Apple, Google, Microsoft, Mozilla. And if you want to know real life examples, so the Google Meet, Discord, these are pretty good examples of WebRTC. And if you attended Amir's talk yesterday, which was amazing on real-time collaboration, you connect WebRTC and CRDT together, and you have something like Google Docs in place, which is amazing in the remote world right now, right? So protocols behind WebRTC which make WebRTC possible. So these are the network side of things which are pretty important to know before deep diving into WebRTC. So there are these five protocols which I'd say there is NAT, there is Turn, there is ICE, and there is SDP. So what is NAT? So NAT stands for Network Address Translation, right? So why do you need NAT? So before IPv6 came into picture, so there was this problem of limited IP addresses. So we would run out of IP addresses very soon. So NAT came into picture for that, and the second reason was firewalls. So you cannot expose your public IP address to the real world so easily. So NAT lets you get that protection layer as well. So how does NAT work? So suppose this is your client, this is your IP address, and you want to interact with the APIs or any. See, this is your server address, which is another computer basically. So what you can do is you put a GET request key. I want a GET request at this IP address and this port number, right? So it goes to your router. So router says, "Let me take care of it. I won't expose your mm, IP address." So what router does is, okay, I will send this request on your behalf. There is a NAT table created inside the router, and it stores your IP address as well as port number and sends it to the destination IP address and port number. And while it goes there, when the request reaches there, it's the IP address of the router which is exposed, which is 5.5.5.5, and the port number, not yours. So it gets there and it comes back. So when the request comes back, uh, it looks up into the net table. Okay, the request has come back. Now where should I send it back? So it says, okay, this was coming from 10.0.0.2, so let me send it back. So this is basically how net works. So yeah, there are four types of net in picture in the current world. There is one-to-one net, there is address restricted net, there is port restricted net, and there is symmetric net. So what is one-to-one net? So one-to-one net does not have any restriction. Any request which was done via the router and the response came back, it lets it go pass through and go to the private IP without any checks. So all the request just goes through similarly. So for restrictions, there is address restricted net. So what happens in address restricted net is, so the request responses which are coming from the request, it checks in the existing net table if this address exists in the net table or not. So if so basically if I have interacted with this address before, so then I will let it go through to the private facing IP. Otherwise, I'll stop it right here and not let it go through. So that's address restricted net. And other is port restricted net. So port restricted net adds one more level of security. So it checks if this response which is coming from this server, so it checks if I have interacted with this IP address as well as the port combination before. So it checks if there is a 4.4.4 port number 80, okay, I have interacted with this before, let it pass. 3.3.3 8080, I have interacted with this before, let it pass. And the same address but not the same port number, if I have not interacted with it, I'll not let it pass. So this is port restricted net. Now the most secure comes the symmetric net. So what symmetric net does is, symmetric net check the full pair key. Okay, so this was the destination, this should be the destination, and this port number which I've interacted with before, but also this should be my the source which was there, it should be my IP address and this port number only. So it checks full pair and then only it lets it pass through. So that is symmetric net. It's the most secure one among all the nets. So how to overcome this problem of net if we want to do a peer-to-peer based network? So there are two concepts which lets us bypass this net problems. So there is, first one is stern. Stands for session traversal utilities for net. So what it does is, stern is a separate kind of server where you send a request and you get the public facing IP address as a response. It works in the case of full cone, symmetric, full cone address and port restricted net, and fails in the case of symmetric net. So how does stern work? So see, there is this stern server. You send a normal request to a stern server. The router or your internet service provider, just as normal net do, it just attaches its public IP address and passes to the stern server. What stern server does is, it gets your public facing IP address from the network packet and wraps it in the response and sends it back to the router and then to you. So now in the response, you know, okay, this is my public IP address, and then you can establish a peer-to-peer connection. So this is how it's done. So behind a full cone net, say, or an address or port restricted net, you send your request to stern, get your public IP. This also does, and now both of them can interact. Okay, hey, I'm this, do you want to connect? Sure. So this is the shortest way of connect peer to peer. And then there is stern. When does it fail? So in the case of symmetric net, it will fail because symmetric net says, I don't know you, I haven't interacted with you before. So symmetric net is the good child, it doesn't talk to strangers. So to overcome the symmetric net, we have a turn which is traversal using relays around net. So it is also a server which relays packets to the client, and all the clients which are behind the symmetric net uh, interact via the turn server only. And it is an expensive server to maintain and run, which needs to be pointed out. And yeah, how does turn work? So turn says, okay, send hello to this IP address. Okay, it sends okay, and then it says, okay, I said hi. So the response comes back via the turn, and both of them are sitting behind a symmetric net and following their protocols as well. So this was to overcome the net based problems. The other protocol which you need to know about is an ICE. So what is ICE? ICE is a protocol established by the Internet Security Organizations, which is Interactive Connectivity Establishment. It basically collects all your public IP address or private IP address and the turn server addresses and the turn server addresses and wraps it, and this all wrapped together are known as ICE candidates. These ICE candidates are sent to the remote peer via an SDP. So what is SDP? So SDP is session description protocol. It's not a protocol, basically a format which wraps around the media codecs, your port numbers, network options, as well as the security option and the ICE candidates which we look right now. It wraps all of them and creates a format which is basically a session description protocol. And this SDP is generated by the user and sent to the remote peers somehow. This somehow we'll look into. So how do you send it? So you need a signaling server. So SDP signaling is important because the remote peers need to know that this is the SDP generated by the user, as well as you need to know that this was the SDP generated by the remote peers, right? So you need, once the SDP is generated, this needs to be transmitted to all the peers. Once it is transmitted, then the peer-to-peer is established. Before that, you need a signaling server. It can be your HTTP request based server or Firebase or WebSockets. It's up to you, right? So this was all the concepts which are required to create your own WebRTC server sites, right? So these are some Stern servers. Some are free, provided by Google. And if you need to spin up your own Stern and Turn servers, this is the open source GitHub project Coturn. You can look into that. And for the client side, there are browser API which we have. First is the RTC peer connection. So you initialize the object via the RTC peer connection constructor, and on that you uh, call this method create offer, which creates your SDP. You set it in your local description. So this is my local SDP. Then send it to the signaling server, say Firebase. Firebase stores it in and sends to the remote peer, and the remote peer receives the SDP, sets in its remote description, and then create an answer, sends it to the first user. First user sets the SDP its remote description, and then they exchange ICE candidates, and ICE candidates have the information about stern and turn. And yeah, after that the peer-to-peer connection is established. Apart from that, there is this RTC ICE candidate which gives you information about your ICE candidates, session description, and data channel to establish the flow of the data between the peer-to-peer. To access the webcam and the microphone, you can use the good old media stream dot get user media APIs. We'll not do hands-on coding. I'll give you the link to the very good blog where you can read more about it. So next question is, should you write your own implementation? So if you want to, you can. There's nobody stopping you, but some consideration, some factors which you should consider is, you need to be ready to deal with all the challenges that come with maintaining the servers, yes, plural, because you need to maintain the signaling server, your turn server, and for the edge cases you need to maintain a turn server as well. And if you are writing your own implementation, there is, apart from that, there is media servers also involved, which we haven't touched upon. So this all you need to maintain. Then there is the scaling issues which come with it, and the cost, time, and the dev power, as well as the DevOps power which will be needed. So if you can check all of these boxes true, you can go ahead. But uh, at Invact, we didn't. We were in a very fast-paced environment, and these all boxes were a big no for us. So this was not ideal, and you need to do this in a not so ideal world. In an ideal world, there exists 100 ms. So 100 ms was the hero. So all your turn, audio, video, scaling, signaling, all the issues can submit in front of 100 ms. That's me as well. So yeah, 100 ms to take care of all your worries of related to WebRTC and peer-to-peer. You don't just you hand over 100 ms to your front-end developers, and you will have a WebRTC app in place within minutes, and 100 ms claims it, and that is true. So my love for 100 ms, it started in February when I came in contact with 100 ms team, as well as their docs. The developer experience, the SDK is so good ki you will fall in love with it. So give it a try if you are into WebRTC and going for some WebRTC application. And so now touching upon the metaverse. So if you need to know about the basics of web-based metaverse, there was this awesome talk yesterday by Shiram Balaji. You should, you cannot miss that if you are going for 3D on web. I will not go deep into the basics, and we'll just know what is minimum required for creating a minimum web-based metaverse. So you need to know good old JavaScript, and some basics of 3D and coordinate geometry. So yeah, if you want to go with the vanilla JavaScript, there is this library called 3JS, which is maintained by Mr. Dube and the community. It is you will write the code in imperative way. There is class-based constructors and all. And if you like declarative way of writing and React, basically all of us here love React. So you can go with React 3 Fiber. These are the docs there. This is maintained by an awesome group, Poimandres, which Shiram mentioned yesterday. So this is the group which gave us the stand and React Spring and another awesome libraries. So you can look into that as well. So if you missed the talk, some basics which I hope you should know is, and we'll look into that, is in 3D world, everything is basically a mesh. And what is mesh? Mesh constitutes of two major things, which is one is geometry and another is material. So geometry, think of geometry is like a skeleton and you wrap the material around it and you have a mesh, and these meshes are the building blocks of 3D world. Apart from that, you need to know, okay, there are three axes involved in 3D. One is your X for left and right, Y for up and down, and Z for front and back. This is the all you need to know, and we'll deep dive into the code. So how will we use the WebRTC to power the metaverse? So for real-time multiplayer, so take an example of Google Maps. For a 2D map, we have two coordinates, X and Y, latitude, longitude, right? So your real-time location, you can plot based on these two coordinates. So for a 3D map, we'll need three coordinates, which we looked into, right? So you need X, Y, and Z. So let's say a local player, which is your machine, you press W and your player moves forward. So now the coordinates have changed. So we send this coordinate to all the remote players which are connected via WebRTC. Say two more players, players B and C. This is received by all the remote players, and in their map, player A is re-rendered and its position changes. So CubeVerse. So CubeVerse is the and some basic metaverse which I have created using 3D. Will look into the code. So you can see we have HMS imported here, and so a keyboard component which I created. So keyboard component basically uh, does the take care of the WASD. So for all the four keys or the arrow keys, and it just updates the position based on the player slice, which, and we have used the stand here for the state update. As soon as you press WAS or D, your state changes and the key event is registered and you move accordingly. And apart from that, everything happens in 3D inside a canvas, and you wrap everything in HMS context. And you have a sky which is provided by Dre. There is lighting, there is orbit controls. This is our player cube player, and we have remote players basically. So what happens inside your local player is just a second, I'm on the wrong button. Cool. So what happens inside the remote player is you, as soon as the key is pressed, you there is use frame basically runs every frame, which is around 60 fps on average on an average client machine. So on every frame, if it checks if the forward, backward, left or right is true, we use hms action dot change metadata. Metadata is basically the string which gets related to every peer and it's attached to every user id. So we stringify the json object, and yeah, we just pass the information around it, so which is received by the remote players. So there is this peers data which comes from the hms store. It's a Zustand store under the hood. So you check for if the player is not local, you filter out the local players and you map through them and you render them. So as soon as you get new positions, it just basically re-renders, as we looked into the slide. So we'll look into the practical now. So yeah, we this is the welcome screen. We enter the name, we select a color, and we enter. Well, basically the cube verse is, everyone is here is a cube. So yeah. So here we have xyz. You can see as soon as the player is moving here, let me zoom out. Yeah, as soon as the player is moving here, we have a real-time multiplayer in picture now. So yep, there needs to move so for the color to relay for now. So this was basically bare minimum metaverse which I created for this example. I'll send the GitHub repo link as well. So So this is working, right? So what is happening, which that we looked into. Now looking at the performance issues which comes. So inside the use frame, I have put checks so that idle data does not go forward. So even if we update the console log here and if we look, so now just take a look at the consoles and the number of times. So whenever the console is printing, update is going to the server, and at the same time, it's received by the window on the right, and it's re-rendering there. So this is too much, right? So take that into consideration. Let me open one more window, and this one will say www, and the yellow block it just moved. So yeah, wait, we go to remote players. We comment this out and go to remote players, and what we'll do is we get the name as well, and we say how many times the remote player is being re-rendered. So let me clear the console and let me move. So there is now there are three players. One is yellow, pink, one is blue. So we will just move the blue one and just take a look at the console in the right one. Let me see if I can do something and see at the amount of re-renders which is happening. Just one player is moving on the left and the amount of re-renders which is happening, right? So this was the amount of re-renders. So now one thing which we need to look into is why is say if ABC is moving, so why is another the triple W which is re-rendering? ABC only should re-render, right? So both of these performance issues which we'll look into and solve. So what is the performance issues which come with the so use frame runs every frame. So the average frame rate is 60 FPS. So the position update is done inside the use frame for smooth position relay. Why we did it inside use frame? So imagine a flip book. So if you flip it from the end to the first, so you see a object which you have drawn. It should be very much near to each other so that you can see it moving gradually and smoothly, right? If you at the last page your object is here, and on the next page you leave some space and draw it here, so you will have a sudden jittery movement. For a smooth movement, it needs to be gradually increasing. So that's why we used the use frame. So it sends the position like 1.1, 1.2, and it gradually moves smoothly, which we seen. So but the problem with this is if a player is moving for 10 seconds, there will be 600 updates going through the server to all the players. So this causes serious performance issues on both the ends, server as well as the client side, right? So this was me. We and this is 100 ms servers. After writing this code, I almost tried to burn them down. But 100 ms team was very nice about it. We sat and we came up with solutions. And the solution was we tried interpolation. So interpolation, it works by taking two old positions and moving the character between them. How does this work? So we instead of sending at a constant interval inside the use frame, we send it at a gap of some interval and basically throttling the update function. And now since the remote player used to re-render based on the continuous position, it can the problem which arises is it can teleport just like the flipbook which we talked about. It can teleport from one point to another, and there will be a jittery movement and teleporting issue. So to avoid this, what we'll do on the remote player side is we'll lure the player based on the two positions. So what is lure? So lure basically stands for linear interpolation. So what is linear interpolation? It is provided out of the box via 3JS, but we'll break it down into the front end terms which we know. So we take the current position of player as one point and the new received position as another point and lurk between these two. So think of it like CSS keyframe animation. So what we do we define a keyframe animation, and you give at left initially at 0% left should be 10%, and at 100% left should be 50%, and you give some time limit and a timing function, say ease in or a cubic bezier, and you when you run the animation it just goes it smoothly, right? So you just give it two positions, and it the remaining position which was skipped, it just animated out of it. So that's basically what interpolation is. Now we'll look into interpolation via code example. Let me just okay, cool. We'll shift the branch to interpolation. Cool. So here. So what we've done is we set a set interval at an interval of 200 millisecond, and every time at a interval, instead of 60 times in a second, now it's going at 5 time in a second. So basically 1000 millisecond is your 1 second. So divide it by 200 and you have reduced it to 112. And when you reduce it to 112, it is a serious performance improvement on both the server side and the client side, right? So yeah, this was basically done. And on the remote player, what we did was we checked the position. If current position is not to the previous position, and basically we set the interpolating position, and this was the function which I was talking about. You pass in a lerp factor and the interpolating position, and we'll look the example right now. Okay, everything good. So again, let me just say this is ABC, red color, enter. Okay, this is XYZ, blue color, enter. Cool. So again, 100 ms has done its magic, and we have now you can see there will be slight lag, which is basically unnoticeable if you say 200 millisecond lag, but it's smoothly animating, and we have reduced performance by 112. Not reduced, improved performance by 112. My apologies. So yeah, we have reached the server calls and the re-renders here. So this was basically what interpolation did. And the second performance issue which was there, even if blue cube was moving, the yellow one was also getting re-rendered, right? So to overcome that, what we will do is we'll use React memo. So the why we so dealing with any WebRTC, what you need to take into account is if any action is happening, you cannot write a diffing algorithm between peer to peer key. Say only this one has moved and we'll send that update. Same problem was there. So if you peer's data is highly reactive coming out from the Zustand store, any component subscribed to it will highly re-render like a ticking bomb. So what we did was we wrapped the remote players inside React memo. What React memo does is you can look into the docs as well. If the previous props and the new props are basically the same, it will not re-render and take the last rendered result and work with it, right? So React memo checks for uh, props, and then we can optimize the re-render based on that. So just a second, we'll shift to the re-render optimize branch, and yeah, you can see here we have wrapped it inside a react.memo. I'll remove the console log comment again, and we'll see. Okay, there is some error. Keywords. Yeah, okay, wait. Name is string. This was working. Good. So just pass it through this TypeScript. Some we'll look into that later. So we again do ABC blue color and enter. We need to re-render this to change the color. We have then XYZ of red color and enter. We just change the angle, and we'll have now another tab open. Into TypeScript. We'll have www here of pink color. Cool. So now we have 3 cubes in position. So, but what you can, let me clear the console here, and clear the console here as well. So if now one place moving, not you can see the infinite re-renders which was happening earlier, and now we have optimized the client side re-renders to just the player which is moving, only that will re-render, and if red and pink are not moving, that re-render is not happening. So we again optimize the client side as well, and basically 3D takes a heavy toll on your client side for the performance, and you need to optimize as much as possible for a smooth immersive experience. So that was all from my side. That's all. And credits. So I learned about WebRTC in depth from this Hussein Nasser YouTube channel. Amazing crash course you should see. If you want to have a basic implementation of your WebRTC, you can hit up Fireship, and you will have a good. There is a good blog also attached with the video, and you can implement your WebRTC. Then there is MDN Docs. Apart from that, credit goes to good friend and senior Shiram Balaji, who's helped me a lot during the entire process. Team at 100 ms and my team at Invest, which were both of them were good support system. And the images and memes which they have used, and if they are now converted to an NFT, credit goes to them, the respective owner as well. So yeah, let's have a chat if you want to know more about 3D on the web or WebRTCs in general. Collaborative work on web using WebRTC and CRDT. If you want to know, hit me up. I'm making a side project based, and b- anything about software engineering in general, I'm happy to chat about. And yeah, these are my GitHub and LinkedIn username as well as Twitter username. You can connect with me there. And thank you everyone for coming to my talk. And yeah, it was nice sharing this knowledge with you. Thank React India for React the Bangalore for accepting my talk. Thank you very much. Yeah, that's all.
That was one great talk, Shivam. Really liked that you shared about Cubers. I'm definitely gonna check it out. If you have any one-on-one questions to ask to Shivam, you can go to his session and talk to him, or you can just simply drop by and tell him that how great his talk was. Up next, we have one more talk around metaverse only. So I guess I think you would be excited for that too. We have Suprabha with us. She's a self-taught front-end developer and currently works at Golecha. She's gonna walk us through a development workflow of a shopping experience. So I hope you all are ready for it. So stage is yours, Suprabha.
Hey everyone, thank you so much for joining me here. Today I'm going to present a topic on creating experience in Metaverse. Let me introduce myself first. I'm Suprabha and currently I'm working in GoCheck as a front-end engineer. I also love to share web-related dev tips from like Web 2 or Web 3 onto Twitter and Instagram as well. Also like I really love to play games. That's what like actually more excite me about the metaverse world. Let me tell you like what is metaverse in a very brief idea. It is actually combination of both AR and VR, like augmented reality plus virtual reality, right? So if you see, right, what does it mean like when we combine both? So if you take your example, so you will be part of the virtual space, you will be there inside the virtual space and you can actually walk, interact with the other users, even you can play the games, do the gyms over there, do the dance, listen to the music, watch Netflix together. So those other stuffs which you are doing right now in the physical world, those things still you can be able to do the in metaverse world. It's the one thing you don't have to like go out from your home. You can be still there in the right now in your home, and you can actually still enjoy that those kind of moments, right? This
So
if
you
you let's
can
see this
see like
example.
what I am actually seeing in the Oculus right now. I'm just moving my right. Here's the options I have which I can do. There are apps also which you can select, play games, or there's like settings and all you can see. You can watch Netflix also, and this is the best. I love it actually. First step, you can dance like with them.
Cool. So this was the my first experience when I was actually using the Oculus Quest 2. That's what I thought to share the experience. But definitely like having the metaverse world, it has like few pro and cons as well. If we are going to see the advantages here, it has the better social interaction online, definitely. I mean, in the metaverse world, uh, social interaction is really different and it's really amazing over there. Improvement to gaming and the online learning as well, definitely it is there. If we see in terms of online learning as well, if we have actually seen like due to the COVID situation, all the schools were closed, students were like learning from home. But now what if we say students can actually enjoy the classroom moment and the environment while staying in the home also, right? That's what metaverse actually gives you the experience. Even though if you stay in home, you can experience the world whatever like you wanted to like go and enjoy. You can be in a home and actually enjoy the virtual reality over there. If I talk about the disadvantages as well, yeah, cybercrime definitely, because uh, decentralized aspect is there, right? For the metaverse, like because everything has comes around the web3 concept, right? And where the decentralization concept comes, government doesn't have actually much power to fight or make control over the cybercrime, right? So that's the reason, like that's the counter actually comes when we talk about the disadvantages regarding the metaverse. The second thing is like the losing connection with the physical world. I would say like it's really important. We have to like make sure, like, because once you go into the metaverse world, it's really hard to track the time. You will actually totally forget about the like what is happening. You might miss lots of things which is actually happening in the physical world. That's the reason we when you actually go into the metaverse world and when you actually play games or do stuffs, make sure you don't actually invest a lot of time over there as well. Future of metaverse is here. If you see, as Mark Zuckerberg also said, right, mankind will migrate into the metaverse in the future. So yes, it is ongoing. It's definitely like it will take time, but if you see like this website, right, you'll get the picture what I'm trying to say here. How the interaction and everything has been made, right? You'll get the picture in very very better way. Let's jump into the like the topic which I was really interested, which actually I interacted with and created some scene and entity over there and used it. Let me play a small demo.
This is a 2D world. This is I'm using here Firefox Reality in the Oculus Quest 2. These are two my controllers. So this is my left hand, this is my right hand, and let's see if I'm correct. Like it's yes, Firefox Reality I'm using here down, and I have built this in A-frame right now, and so I can move it. Definitely, I cannot use my these controllers. Like you can see A, B, X, Y, and even the mouse move and like the stuff, right? I cannot able to track it because we are not in the VR world right now. So let's jump into the VR. Cool. As we can see, our controller also has been changed. Instead of the controller like which we're using, it's now our hands, which looks more real, like when you actually go and grab something over there, right? So cool. I'm just moving my head so that you can see the scene here. We can call it as a scene right now, so that I'll get the picture. Definitely, I'll let you know like what is a scene and what are the A entities and all. So just bear with me right now. These are the A entity, like whichever the object which you can see here, right? The mugs or the wine glasses, even the teddy bears, right? These are the A entity which I have created using Blender, the objects over there, and then I have imported it to the A-frame and started using it. Now let's go and grab some, teddy bear and put it into the cart now. Cool. Let's reach out to that. Cool. Okay. Now let's see. It's in the cart. So now let's go get some wine glass also. I know it's a bit hard, definitely, because as we know, like alcohol is quite dangerous for our health. But still, let's see. Yeah. Cool. Cool. So if we can see, it's here. Fine. Fine. Cool. So the same way, like we can grab the things over there and put it into the cart over here, and I'll just walk you through the camera and the stuffs over here, like how I have created this small stuff.
Cool. So as we see, right, all the picture regarding it. So now let's jump into the things which we discussed here into the demo. A scene, right, where I said like we'll be gonna discuss a scene. If you see the React fragment, right, it's almost same. We have to, it's a kind of a wrapper where we have to move all the objects or entity inside it. If you move outside the scene, it will not re-render. It will not render, I would say. Sorry, not re-render. Not. It's like if you put out things outside, like the object or maybe entity, it will not render over there. So we have to make sure like things should be wrapped under the e scene. Let's move to the entity here. So as you can see, right now in entity, I have a camera and this is the controller. there are two controllers. I mean, as you can see, they are in normal world, in 2D world, we have one mouse, but if you see in the 3D world, right, we have two controller, two mouse over there, two connections, right? So I am showing only one here. There are one like another. There is very little changes over there into the another right controller. So if you say about the entity, right, it's nothing actually. It's same as a div, as you know, like a div tag inside the HTML, how it used to be called. So we can put anything. So we can see, right, the semantic HTML is there, like header footer. But if we wanted to create the header footer behavior, we can use the div over there. The same way, a entity is like to wrap your anything over there, wrapping the whole content, or maybe creating or pushing any objects, which is you are, you know, like taking from any other worlds. Now, if we see, I'm just wrapping this camera and entity inside a one a entity, because wherever I move, right, or wherever my controller will move, I wanted to move my controller and plus my camera as well. So that's why I wrapped here inside the a entity. That's the like major reason. In terms of a camera, it is like the again positioning about the how the camera will be moving towards the controller side, and a entity, this is for the left hand. And the same way, like if you have to create for another, we can simply copy this a entity and paste it another one and make these changes for the laser control and the hand control as well. Hand control is nothing actually. If you see in terms of when we are using it, right, over there, in the 2D world, we were able to see the controller design. But when we move to the um, 3D world, like in the metaverse, the VR world, you can see that those becomes hand, right? So that's where the like hand control. Oculus thumb string is like controlling and giving the action to move backward, you know, like left, right, those things. Now, these are the like tools, I would say, like this quick create roadmap, which I followed to create this small project. I have used Blender to create the objects. Uh, just make sure when you use Blender, you have to you know, like export your object into two-way, like gltf or glb. I have used A-frame to create the virtual reality experience, used S3 for again uploading my content over there, and I have used my Oculus Quest 2.
Thank you so much for the talk, Suprabha. It was great learning about the your insights on the metaverse. Really like the demo clips you added in between. Now we'll go on a short break. It would be a 20 minutes break. You can go to expos, or you can like have your breakfast if you're uh, uh, if you have like just woken up. And yeah, we'll see you after the break. And we have amazing talks lined up for you after the break as well. So you might wanna come back on time. So yeah, see ya.
Hello, everyone. Welcome back. I hope you've had a quick break, had your coffees, and you're back energized. Because, mind you, you need to brace yourself for the next talk that's coming up. Because this one is highly opinionated, and I'm bracing myself for all the tweet storm that will be coming forward after this talk. But we have Saurabh, front-end engineer at Razorpay, an amazing front-end dev who is building his own static site generator, Abel, and he will be talking to all of us about what an ideal React would look like. And I'm personally very excited for this talk. So over to Saurabh for his talk titled "The Front-End Framework of Our Dreams." All the best.
So just 1 second. Yep. Hey, hi everyone. I'm Saurabh. I work as a senior front-end engineer at Razorpay. I'm also working on this tiny side project called Able. But we're not going to talk about Able today. If You can also reach out to me on Saurabh Daware with an extra E on Twitter. So yeah, let's build a front-end framework. We're basically going to do that. We're going to build a front-end framework. Maybe not literally, but we'll just idealize and ideate a few things about what features we would like in a front-end framework. Um, so let's say we were about to build a front-end framework, or let's say you're building anything. You first need a problem statement. So what would be a problem statement for a front-end framework? In my opinion, it would be something like this to make it easy for you to build a better user experience. That's what front-end frameworks do. They make it easy for you to build complicated user experiences, which otherwise would have been very difficult in a vanilla setup. So I'll talk about this statement. We'll break it down. Let's talk about so to make it easy for you to build a better user experience. Let's talk about the better user experience part first. What do we mean by a better user experience? Um, in my opinion, it will be first thing will be how smooth the site feels. It's a very vague term, but generally when you visit mobile apps or any application and you go through navigation, so you click buttons and it interacts, and it just overall adds up. It just overall improves your user experience. So my first point would be how smooth the site feels. Again, we'll talk about this in details. Next point would be how fast it shows useful information. If I'm clicking a button and then have to wait a really long time for some useful information to show up, then it's a bad user experience for me. So how fast my initial page loads and how fast my subsequent navigations work. This is also something that adds up to better user experience. Another thing is accessibility and internationalization. If the site is not accessible to some people, or maybe s- uh, let's say if someone wants to understand an image and it doesn't have alt tag, or just things like that that are related to accessibility, that also comes as a part of user experience. Internationalization, again, if you're reading a documentation site and it is not in a language that you understand, then you're not really going to understand anything from the documentation site. So depending on use case by case basis, internationalization is again something that adds up to better user experience. Then there are some features, some product features like a search bar. Let's say you're in a documentation site and there's a search bar on top where you can just go and search what you need, and then it takes you to that page. That's a better user experience. That's a product feature that adds a better user experience. Or showing appropriate errors. If something goes wrong, then the website telling you that this is where it went wrong and this is what you can do to fix it. Things like that. Um, like I said, the talk is about front-end frameworks. We're going to talk about in context of front-end frameworks. There are a few things like product features, for example, search or showing appropriate errors. These things they lie on consumer ends, where it depends on how the person using the front-end framework is adding it. Also, things like accessibility or internationalization. Accessibility, in particular, can be part of front-end framework in terms of routing. For example, if I'm changing the routes, then I have to announce it to users that the route is changed. But again, the eventual final accessibility of application lies on the consumer's end. So what we're going to talk about in details today is these two things: how fast it shows useful information and how smooth the site feels. Basically around performance and but not just loading performance, but just overall interaction performance. Now, what do we mean by how fast site is useful information? So we have Web Vitals, which gives us things like first contentful paint or largest contentful paint, and that it gives you score. But I really want to talk more in terms of user experience rather than in terms of numbers today. So in this context, I'm not really talking about LCP or FCP here, but just how what is useful for your site. For example, this is razorpay.com. This is how it looks on desktop and mobile. If you ask me what is the most useful information on this page, I would say all of it. If I just load this particular part, this text and this image, but delay loading the nav bar, that's still a bad user experience. If I just load nav bar and don't load this part, that's again still a bad user experience, because all of this collectively conveys the information that the site is going to give. For example, the navbar gives tells you that there's a payments view, then there's a banking products, there's resources partners, and you can just check out pricing, or there's a login sign up CTAs. Then again, there's a text that informs you what the site is about, what the recipe is about, and there's an informative image. So all of it is useful information. Um, Now let's talk about this in terms of tech. What do we mean by showing useful information in terms of tech? It means how fast you get the HTML and CSS. If you see both of these examples, it's just HTML, CSS. We're not talking about JavaScript here. We're not talking about interaction yet. We're just talking about the showing the information, and that has to be HTML and CSS because that's what renders on your screen. So we want to get the HTML and CSS as quick as possible, which takes us to our first topic, rendering patterns. I'm just going to pause here for a second because I worked really hard on this pun. So yeah, I hope you get it. Um, so first, we'll go into client-side rendering. This is usually the default type of rendering that you get when you use front-end frameworks. Um, so this is basically what you get when you do create React app. Um, well, now the problems here is first we get the index.html, which is going to be empty and not going to have any content, which will have a link to JavaScript. So that will load the JavaScript. After downloading JavaScript, it will execute the JavaScript, and basically this JavaScript will inject your HTML into your actual HTML, and that eventually shows the page. This is again a simplified version. I didn't add CSS here. This is just under assumption that CSS is critical CSS and images load pretty fast. Just to simplify things for client-side rendering. But yeah, this is essentially the problem that if I let's say if this JavaScript size is bigger, then it just takes more and more time to show the first useful information. This becomes even bigger problem if you have code splitting and multiple routes. For example, if I have multiple routes on my page on client side and I code split the home page, that means my first page it isn't going to know what chunk to load, and that it will only get to know after first main.js is loaded. So you just end up with this waterfall, and the first useful information just keeps on getting delayed. We have some solutions to it. One is server-side rendering. Server-side rendering essentially means just rendering that HTML, building that HTML on the server, and sending that HTML in the first request itself. So when we get the first index of HTML hit, it has all the information about the HTML. Basically, it will have all the information about this power, your finance, your business titles, or it will have the navbar information as well. If you notice here, in client-side rendering, the site was showing useful information after the last JavaScript load. But in server-side rendering, it can start showing useful information just after the first index of HTML. So even if my JavaScript grows large, or if I add multiple JavaScript files, that still doesn't delay my first initial useful information. Um, This is great, but this can be optimized. So what we have here is, what we have to solve is we can make this index.html load faster. Let's say the user is in India and your server is just around the globe. Now, if you request something from if this user requests something, the request has to travel around the globe to get the HTML and then return back to user, which is why this index.html can grow large. One more thing is, let's say you're using React and you load multiple components, then the render to string itself can take some time to execute and create the HTML. This problem can be solved using CDNs. CDNs are these edge locations that you have closer to user. So if my user is in India, the CDN is going to be pretty close to the user as well. What we can do is, we can cache on CDN. What that means is the first request goes to server, the server returns HTML, and then I just cache that HTML on CDN, and then the user can request the subsequent request can go to CDN and just return from CDN without really traveling across the globe. This comes with a trade-off that your site can't be fully dynamic, or it can have some limitations in terms of how much dynamic your site can be. But like talking in terms of user experience of loading the first useful information, it can reduce your first HTML load if it is possible for your use case. So server-side rendering and caching is something that works pretty well. One more thing I want to talk about is static site generation. Static site generation is similar as well, where a server will probably just be some bucket where you can just put your static contents, and CDN can infinitely cache the static contents and just serve all the requests will get served from CDN itself. So it's again similar. I didn't add slide for it because the overall like water flow will be similar. So what we know now is, if we want to get the useful information on screen as fast as possible, um, our framework has to support server-side rendering, static site generation, or rendering on edge. Rendering on edge is again something similar, where CDNs are basically edge locations. They can have some computational power, and if you can render your sites on edge itself without really going to CDN, again comes with certain trade-offs. We won't really go too much into details of rendering patterns here, but yeah, what we know is it has to support these three things. Let's call it HTML frameworks or HTML first frameworks. This is usually a term that is used when there are frameworks that are primarily generating HTML. For example, Astro is one of them which generates HTML. It's a static site generator. It generates HTML, but again lets you do a lot of interactive things on top of it. QuickDev is again something that is an HTML framework. We'll talk about it in next slides. So yeah, what we need is an HTML framework. Next, just going back to the problem statement to make it easy for you to build better user experience. The next point was how smooth the site feels. Um, so how smooth the site feels, kind of like, okay, yeah, there's a animations warning. There's a lot of animations here, but smooth smoothness basically depends on these two things: interaction speed and animations. Interaction speed is, for example, time between you clicking the button and modal popping up. So time between you performing some action and you getting some output on screen for that, plus animations. For example, even in this example, if I just show navbar without animations, it won't feel smooth. But if this navbar also takes too long to load, it won't feel smooth either. So we have to solve for this smoothness, um, which takes us to our next point, which is hydration. Um, so we'll talk about hydration in details. This is the point that I want to cover the most because it's still a very open discussion and we don't quite have a proper solution to it. But yeah, we'll see what all proposed solutions are there for hydration problem. I want to explain what hydration is through examples. So let's see the example first. I have this basic setup here. Um, what it does is it's just a render function and returns HTML, and it prints that HTML on screen. This is a server-side rendered application. You can see there's a server.js. I'll just show. We don't have to go through this code properly, but what it is doing is it is taking the output of render, and it is setting that HTML as a response. It's an Express server. So yeah, I can change something and it will change that. Let's try this out in React. So first I'll set up server-side rendering in React. I already have React installed here. So I'll just do import React and import React on server. Some of these APIs have changed with React 18. So yeah. And I also have this counter example here, which is just a simple counter. It's counter set count, and on button click it just does the count plus. So I'll import this counter component as well. And what I'm going to do is call React DOM server render to string. And yeah, we have this counter here. What render to string does is it takes the React component and it gives you an HTML output. So it basically returns this particular HTML. So this works fine, but the problem here is we have counter, right? It has to increase on button click. We have written code for that, but if you see, it doesn't work because this is a static HTML. We are not doing anything to add event listeners to this button to plus this counter. Making so basically we haven't made this interactive yet. Hydration is the process of making this interactive. So in React, what we do is, let's say if I render something inside this div ID app, I can just hydrate over the same app with the same counter example, and it just makes it work. So we have interactive, we have added interactivity here. If I also go and see the source code of this page, you can see this hello count plus is actually in the DOM in the first response itself. So it didn't really add the empty app that you would usually get with client-side rendering because it's a server-side render. So this was already in the HTML. All right, we have added interactivity here. So you can see there's a hydrate root method in React DOM client, which we can call and make things interactive. So that's hydration. It's just adding interactivity to your application. One more example I have is Rescript.com. If I go to Rescript.com, this is also server-side rendered application with hydration. What I can do is there is a runtime bundle to Rescript.com. I can just go and block this runtime bundle request. This essentially means I'm blocking the entire React. So the React is not going to load in Razorpay.com now. Now, if you see, the site still loads. The entire site loads. In fact, a lot of CTAs are usable. For example, I can just click sign up and even the sign up opens. So the overall site is loading. It's just that it is not interactive. For example, if I hover over this nav bar, it's not really giving me, it's not opening the navigation bar because it's based on React and it needs hydration to open. So yeah, that's basically hydration. We'll talk about more examples in next slides. Yeah, anyway, so the next point is SSR with hydration, server-side rendering with hydration. What we saw here, what is happening here, for example, is first we are returning the HTML. So we get the initial load without being dependent on JavaScript. but then the interactivity is something that still depends on JavaScript. So if you see here, the index.html loaded, the website showed the useful information, then the JavaScript loaded, then the homepage loaded, and then the site became interactive. Um, this can again become a problem if we have large bundles and more JavaScript, because the larger code base you have, the longer it is going to take to make things interactive. One more gotcha about hydration is we can only hydrate everything in one go. So the entire DOM has to hydrate at once in usual React setup. So we can just render to string this app once, and then we can hydrate over the entire app. But that basically means if I have footer.js, which isn't really important, but I still have to wait for that JavaScript until the site becomes interactive. This is a problem. So the solution to that is, I'm not sure why this is not working. Solution to that is partial hydration. Partial hydration is a term coined by Jason. There's an article linked to this slide. I'll share the slides later. But what it basically means is you can hydrate the pieces on your site chunk by chunk. For example, I can hydrate in lazypay.com, for example. Let me just delete this. The navigation bar is the important part that needs hydration. The rest of the part is pretty much static content that can load without hydration. So what with partial hydration, I can just load the navigation bar's JavaScript and hydrate that JavaScript itself. So my navbar becomes interactive just after loading the navbar.js, and I don't have to wait for the rest of the application to rest of JavaScript to load to become interactive. This basically means if um, my footer is something that is going to come at the lower fold, so it's not going to be that important to me. So it doesn't matter to me if I don't load my footer, if I don't hydrate my footer in the first go. It is still going to be visible because it's server rendered, but it I don't have to make it interactive in the first fold. So I can just delay the rest of the JavaScript and focus on what is the topmost priority that I have, and just load that first, and then I can just hydrate rest of the things later. In terms of code, what that essentially means is here I just have app, right? I can just have different things like maybe navbar, and it can just be a similar call to this, and it can be some navbar component. So now I still have to follow the hydration rules where my content from the render to string has to match the content from hydrate root, but I can just have different roots in itself which hydrate separately. So yeah, that's partial hydration. That's one of the solutions that we have to the hydration problem. Um, Next up, we have React Server components. These are not on production yet, but just something that React is planning to add in future, and they have released one video about it, just talking about how it's going to work. What they're going to add is they'll have this convention where you can add .server.js or .client.js next to files, and that decides how the component is going to behave or where the component is going to run. For example, if I just say footer.server.jsx, that means my footer is only going to run on server and it won't have any JavaScript bundle. What it is also means is footer won't be interact. It won't have much of the interactive things, so it will be like a static content. So if your footer doesn't need hydration, then the JavaScript itself won't go into the production code. Or you can have navbar.js, for example. Navbar.js would be something that you probably have to run on server and client both, so you can just render on server and hydrate on client the way you do it right now. Or you can have tooltip.client.jsx, which only shows up on client and not on server. So this is one of the solutions. What we will do is think of this example. There's a lot of JavaScript here, main.js, homepage.js, navbar.js, footer.js. And the problem with current hydration bundles is it if I have a footer that is not interactive, that is not really doing anything apart from giving a static content, my JSX or my create element calls are still going to land up on bundle. So this footer.js is still going to exist. But with footer.server.js, something like footer.server.js, we can just mark footer as only HTML or only server, and it will just end up being part of the initial HTML, and it won't have any script that it won't have any bundle that you need for hydration. So it will essentially decrease the bundle size and bring the hydration closer. So that's another solution. One more solution is resumability. Um, Now, so what we talked about here, everything we talked about is kind of a problem with hydration, because what we have to do is first we serve HTML with render to string, and the next hydration, for example, in this example, um, the counter, for example, I'm here using counter here. I have to use the same counter function here and render it, hydrate it over the same component in order for React to work. If I don't follow this, the hydration just breaks, and we don't the hydration doesn't work. That's a rule of React hydration. But what quick what quick is trying to solve is, what they're saying is, the essentially we need the first client render and server render to be same, because it allows frameworks to add event listeners to them. What quick tells you is, you can just have your HTML, just plain HTML, without just render it straight up, and then you can have JavaScript, which just script that is added in the HTML itself, that tells you what is the app state. So it tells you that these are the things that are already rendered on server and don't really need any hydration on client because they are completely static. So Quick just takes that information and uses that information to um, hydrate further or add interactivity further without really the kind of hydration that React adds. So it's um, it's sort of more like you're rendering on server, and then you're picking that state of server, and then you're resuming from that exact state on client. So you don't really end up bundling something like footer.js twice if you don't need a hydration for it. This will essentially mean that your everything is HTML by default, and you choose what is JavaScript. So, for example, I can just have navbar.js, which is the only interactive part, and only that is the part that I need to load for in order to make the navbar interactive. So these are the three solutions we have. Um, there is one more solution. It's not a solution, but it's sort of a hack that we did on Razorpay.com. It's a magic. I won't recommend people to follow this, but yeah, I just wanted to show it. It's really cool. What I'm going to do is again go back to network call. I'll go block this runtime bundle. So it's blocked now. Like I said, the React is blocked now. So the site is not supposed to be interactive. Um, it it should only work with this anchor tags. But here's a magic. If I click this navigation bar, it actually works. That's because we do this one weird hacky thing on Razorpay.com, where what we do is we just add an inline JavaScript that adds class name, and then depending on that class name, um, we just display the navbar. It still doesn't work. The rest of the parts still don't work because it has to wait for hydration, and the navbar is a pretty complicated piece here, so we need React to handle the state management for this. But it essentially solves the problem that the navbar, the first opening of the navbar, is independent of React and can happen before React. I think I might be able to show it. I don't remember what it is called. Yep, this particular script. So it is injected on server side when we return the server HTML, and that just helps us hydrate Uh, it's basically just adding the class name navopen, and depending on the navopen, I can just do CSS animations to open the navbar and close the navbar. If I close this, so yeah, after the hydration, the entire thing still continues and works. So it's a hacky solution. I won't really recommend this to anyone, but it's just something we had to do because we don't have any other solution yet, and the navbar is the only thing that is that we have to make interactive. Just a summary. We talked about user experience mostly. This was the major part. We talked about to load useful information fast and the rendering patterns, and to make site interactive fast, it's more related to hydration. Um, Going back to this problem statement, to make it easy, this is the problem statement that we initially talked about, to make it easy for you to build a better user experience. There is this to make it easy part. Everything we talked about in this, all of that can be done without using front-end framework as well. I can just use the vanilla HTML, CSS, and build a really fast interactive website. I can even just use a plain Express.js server that returns string and does the server-side rendering. But what frameworks essentially do is everything that I talked about. The frameworks are supposed to make it easy for you to do these things. Which takes us to one tiny topic called developer experience. It's very important. It's sort of a direct goal of frameworks. So it's more like frameworks improve developer experience so that developers can improve user experience. So this is something that I want to talk about, but I won't go too much into details of this because there's too many subjective things when it comes to developer experience. Syntax, for example, one of them is a square counter, one another is a React counter. Uh, I love both of them, but yeah, you can have a choice. You can say that you like sweat counter more than React counter, or you can say that React counter more than sweat counter. Or counter might be a really small example. In general, talking about the larger websites, you can have different opinions about different syntaxes. You can also have different opinions about directory structures. For example, one of them is an Angular directory structure and the other is a Vue directory structure. Angular was my first framework that I worked on when I started with development, and I really liked this directory structure more, where I could just define .css and .html because I wasn't very comfortable with JavaScript, so I could just completely ignore the JavaScript part and just do my HTML, CSS things in there, and JavaScript could just be something that I got from boilerplate and just some very minimal code. So I like this directory structure. Or Vue has a single file component where you can just have .view component and it will have all the HTML, CSS, JavaScript. Or React has a different directory structure. Again, it's something very subjective, which I won't go into detail and I won't really necessarily make any choice here. It's up to you which one you like. But there are non-subjective things. For example, core principles. Remix, for example, has a core principle that they focus on web standards. Take this form from Remix. Form method post. This just looks like an HTML form, but it's not. It it gives you a better user experience and just overall better control. And they have kept the API very similar to HTML, and I think that's a really cool core principle to have in a framework. Um, a tiny plug, Abyss, the static site generator that I'm working on, is again one example where something that I'm very proud of, where I try to stay close to HTML. For example, in Abyss, you can just have two files, index.abel, about.abel, which look very similar to HTML with some tiny differences. And I can just go and run npx abel serve, and this just works. You don't really need much of a setup. These are non-subjective things. Another is API decisions. It can be subjective and non-subjective as well. I put it in non-subjective because these are really cool inspirations to have. So let's talk about partial hydration and Astro. Astro supports these client directives where I can just say client load, which by default partially hydrates by button and it loads it in the first go. It also has client idle, which means it's still partially hydrated, but it can delay its loading, it uses request idle callback to load that component, so it can load it later when main thread is free. Another API decision that I really like is server-only components in SvelteKit. In SvelteKit, you can just define export cons hydrate false, and that disables the hydration that makes Svelte components just server only. It also has router faults, which also removes the JavaScript that is needed for client-side routing, and it just turns back to the default routing behavior. So if I do both of this, my component bundles zero JavaScript and Svelte. So I think this is a really cool API decision to have. Another is intuitiveness. This is again, I'm going back to a bit of subjective, but I feel it's a really cool inspiration again. Um, in Svelte, this is a counter in Solid. In Solid, if I log console log high in a component, it just only runs once, and I think I really feel this is more understandable behavior to me, a more expected behavior to me. If someone had not introduced me to React, and if this is the code I had seen first, I would have said that this works exactly the way I expect it to work. So I think this is a really cool thing in Solid. Aditya is going to talk about Solid after me. So yeah, I think he'll cover more in details. But yeah, intuitiveness. Conclusion. Essentially the talk was about front-end frameworks and what is the ideal React, or what is the ideal framework. I'm just going to drop it depends form. It depends. It depends on the use case. It depends on what you're building. For example, even I talked about SSR or SSR with CDN caching. They come with their own challenges. SSDs come with their own limitations. You can't do much dynamic things. So a lot of it kind of lands up on what you're building. um, what I definitely feel that is going to happen is we'll always have multiple frameworks, and there will be multiple use cases for them. So one framework would be better for one use case, and the other would be better for the other use case. Um, but I definitely have some opinions about what is nice trade-off. This is a lot of things. Like, for example, this is something that I would really like to see: ecosystem of React with the intuitiveness of Solid, the abstractions of Svelte, and the HTML first output like Quick or Astro, where they don't really add JavaScript by default, and the core principles of Remix, where they try to stay closer to web fundamentals, or just the overall API design of Remix. There's also a lot of other things as well that I like from other frameworks, but these are the top ones that I could think of. And finally, to conclude, new frameworks come with new ideas. And I think what is more important than new frameworks is these new ideas. They compete with each other and make each other better. So even the entire hydration talk has been improving the overall hydration solutions that we have. And it's really nice to see more and more frameworks coming up. Uh, it's it's a controversial thing to say, but I would really love to see more frameworks. I know we have a lot of them, but yeah, I would just love to see more and more ideas coming forward. Um, the purpose of this talk was to just explain hydration, rendering, or the developer experience, or what the ideation of front-end frameworks look like. So yeah, there is no ideal front-end framework as such. These are just some of the references that I took. So yeah, you can go through them. I'll share my slides somewhere. So yeah, you can go through them. A lot of them were very useful for me. That's it. Thank you so much. You can, if you have any questions, you can tweet them up to me on Saurabh Daware on Twitter, or you can also check out my site project ability.js. Didn't talk about this in details today, but yeah, I might be talking about it in the future. And yeah, saurabhdaware.in has all the other links that you would need. Yeah, that's it.
Thanks, Saurabh. That was one unique talk, and it opened up a lot of perspective. But I must say, 100 and 100 on the talk, but 200 on 100 on the memes or the puns that you had. So thanks again. So next up, we have Aditya Agarwal, a senior front-end engineer at Razorpay, with his talk, "If you know React, you'll love Solid." I guess Solid has already created a lot of noise in the front-end community, and I guess now is the time to learn it firsthand from an amazing dev, Aditya. And I'm really looking forward to this one. I hope you are too. So over to you, Aditya. All the best.
WebRTC work on which lets you build VS Code like command palettes on any website or dev tool. And I also created MSW Storybook add-on, which is like so that you can mock APIs in your storybook. So yeah, my talk is if you like React, you will love Solid. So pretty bold claim. Let's see. So this is created by Ryan Carniato, who currently has been now is coming to Netlify as a principal engineer to work on Solid full time. And yeah, so with Solid, you can forget about rules of hooks. You can forget about passing dependencies manually in your effects and memos. You don't have to care that much about referential equality of objects. You don't have to worry about stale closures. You don't have to manually go and memorize expensive components. And you don't have to write these complicated selectors for getting partial state and making sure that it is referentially equal and all that. So, how is that possible? So, the key is fine grained reactivity. Now, bunch of buzzwords, what they are. So I'll just talk about pure JS for a second and tell how reactivity adds some magic to it. So here, let's say there's a variable count and it is initialized to 0. We console log it, so of course it will log 0, but then we increment count to 1 by 1. So this since JavaScript goes line by line, it logged the count and then it incremented. So there is no way to tell JS right in this file that you have to rerun the count again when the count is incremented. So but wouldn't it be nice if we could somehow tell JavaScript, hey, that this part reacts to should react when count changes. So let's augment that. Solid lets us do that using signal and effects. So now I call create signal. I pass it a 0 value, and it gives me a count and a set count. And I put that console log inside a create effect expression, and then I call set count and increment it by 1. Now what will happen is that since in the create effect I have called console log count, and that's a function call. Create effect now knows that whenever count changes, I have to do something. I have to run this function again. So it will first log 0 and then next time it will log 1. So this is pretty cool. But what practical purpose is there for logs? Well, if we can do any side effect, we can also update the DOM. DOM update is also a side effect. So here, let's suppose we had a heading reference. We could create and we wanted that whatever the count is, we want to show that count in the heading. Well, we could create an effect and pass heading.text content equals to count. And the key here is that count, we are calling it. Count is not a value. Calling count gives the value. So when we do this, again, whenever count changes, effect will synchronize that count value to the heading text content. But writing this kind of imperative DOM update is not what we expect from a modern framework. And personally, I like JSX very much for templating, and Solid likes that too. So here's how we could do the similar like a counter in Solid. And so we have a create signal count and we have an increment function. And then there's some JSX where in a heading we can pass count. And again, notice the count is being called, not count is not a value. And then there's a button which on click we pass increment. So this is pretty standard JSX. And one thing you might worry is like JSX is like for React. How is Solid working with it? Well, JSX is just a specification. It's up to individual frameworks how they want to compile it. So React compiles it to React.create element. Solid does a little different. So this is what a simplified compiler output of Solid. I have renamed some variables to better explain things and simplified some of the abstractions. But this is essentially what is happening. So first of all, whatever the static markup was there, that has been put into this string, the template string, and this becomes our one variable. And then we clone that node, and so that gives us the DOM reference for everything. That becomes the real DOM. And now Solid notes that for the heading, it needs to update the text content when count changes. So it automatically creates the effect and puts this text content line there. And it also notes that for the button, it has to bind a handle click. And since there is some delegation that it needs to do, there is some different thing going on here. And then it returns the root element. So the key thing here is that all this are real DOM operations, and there is no virtual DOM happening here. This is when we call create clone node, it creates an actual DOM, and the performance bit happens because the effect is only updating the heading. It doesn't have to recreate the entire DOM tree. It knows, like it's like a surgical operation where it knows exactly what point it needs to update, and it's doing that. So we saw all this thing, but we didn't talk about components. Like we had a signal, we had effects, but nothing on components. So whereas in React, everything starts with a component. Well, the reason is that Solid is more about fine-grained reactivity and effects and all that, and component is like a syntax sugar, so that we can easily write our web apps. So and components are sort of set of functions, so that we have a dedicated way to organize our JSX and signals. So here's what it looks like. So suppose we had a function app, and we can put our count and set count there. We have our increment function, and we have our same div h1. And now instead of button, we have a btn, just like in React, and we can have a button component, and it is returning JSX. Now the key thing here is that all these runs only once. So this looks like React, but it isn't. First, components only run once. So it's not like button is there, so it will rerun whenever count changes. No, nothing will rerun again. Only since the h1 has a count, so only that h1 will update. Nothing will rerun, just like a normal function. Unless we call the function again, it doesn't rerun again. It's not like internally if you're calling some set state kind of thing, then the function reruns. That is like React adds some magic to it, but that's not what you expect from regular JS. So that is there. And we have the granular effect, so instead of having an effect on the entire div and the h1 and the button, the effect is only on the h1. And similarly, suppose the h1 had a class name, so which so if you show or hide, then it needs to add a class name. So then it would have another effect which just updates the class name. So any property that you are changing, that becomes reactive, and the effect is made for that property itself. So that way it is very granular. And JSX represents real DOM nodes, and these are real, and all the click and all that are real events, just that delegated. There is it doesn't have synthetic events. So now demo time. So here's a real world app I've tried to build, and in Solid and in React both. So first, what will happen is that when I click on the Solid demo button, it will navigate me to a second route, and it fetches some data. Now, since the data loading will take time, it's better that we show the screen and show a loader here, and when the data is ready, then only transition there. And React has concurrent mode which supports this, and Solid does too. So here's it in action. I click Solid demo, it shows the loading, and then it navigates it to me. So it's for user, it's like they don't have to waste time seeing a loader. So now this page is there. If I click on the user, I see the details. I can click add friend, and I can see here, and this is synchronized. So if I click unfriend, it updates here as well. If I click just friends, it applies a filter. And notice everything is in URL, is synchronized in URL. So when I unfriend, it goes away, and I can also search. So here, if I search essay, it shows this, and there's a search history here. So this is the app. Let's see how the reason I want to show the code now, so you get a practical idea of how Solid code looks. So so this app is built with Solid and Solid App Router, and it has nested routing. So this part of the DOM is in the people shell, uh, and so we want a people list, and then we want to loop over that list and render a person avatar here. So now how do we get this people list? This is, and people shell is the component. Well, instead of writing all that logic here, like create signal, all that logic, instead of that, we can abstract it further. So we can have a create people list. Just like in hooks, we can have custom hooks, we can have this custom primitives. So here's create people list, and now it needs to get the data and it needs to filter on those. So now to get the friends filter, whether like to get a mapping of who the friends are, we have a use friends tool and we get the friends signal from that. We have a use search store to get the search query, and use people route data gives us the route data. Now notice that route data, since we are using suspense and nested routing, solid app router also gives us loader pattern, which is common in React Router 3 and Remix. So when this create people list is called, the data is already available to us. So we just call this use route data hook, and it gives us the route data. It is not like a async operation, it gives us data immediately. So now we have the data as well, and we want the search param so that we know whether just friends is on or off. So yeah, create people list. So here we have a create memo. I'll explain in a bit. What we want to do first is that we want to filter on the search. So in the fetched people list, we find the person's name and we see whether that name includes the query. If it does, we keep it in the list, and finally we are returning this list, and that becomes a search people list. Now why do we wrap it in the create memo? Well, the benefit is that search people is also like when we have to access search people, we have to call it, right? uh, because component only runs once. If I search people, if I put the filter directly here, then create people list will be called once, and whatever route data is there, it will compute it once. But when the query changes, when the route data changes, this will not rerun again. So then I could have made it into a function and then called the function in my render or some reactive context. But again, that means every time count changes, sorry, every time the route data changes, it has to call again. So better thing here is that we memorize it, and so that way, anytime search people is accessed, if the inputs have not changed, like the query is same and the route data is same, it just returns the cached value. It doesn't have to compute it again. But important thing here is we don't have to pass any dependency array. Solid is smart enough to figure out the dependencies itself. When the memo is called first time, it noticed that we are accessing the query, we are accessing the route data, and just these two. So it puts a subscription on these two, and then caches it. So this is pretty cool. Now let's apply the friends filter. So for that we have another memo. So people list, and here I am checking if the friends filter is active, and I am taking the people from the search people. Now if filter friends is not active, I just return the people immediately. So what this means is that at this moment of time, it has only subscribed to the search params and the search people, and it has not subscribed to the status map yet. So at this moment, if status map changes even thousand times, Solid doesn't really care because this code never runs. Only this part of the block runs. So dependencies are conditional as well. So this happens when the filter friends become active. Then Solid runs this again, and Solid realizes that hey, I need to access they are accessing status map as well. So let me subscribe to the status map. And now when the status map updates, and status map updates when we click the friend button. So when the status map updates, this filter will run again, and we will have a new people list. And because the people list is changing, our for loop will run again, and the person avatar will re-render. And important thing again, sorry, person avatar will not re-render. Only the relevant person, only that person avatars will re-render. The rest will stay same. That bit is handled by the for component. So here the last thing I want to cover is the stores. So we had the friend store and we had the search store. So in solid, yes, we can it provides a store from itself, and we can have multiple stores. So it's not like Redux where we only have one store. So we can have multiple stores and multiple components can subscribe to that at a granular level. So yeah, friend store is there. We create a store, we make some methods, and these methods can update the store using immer-like pattern where the code looks mutable, but internally it gets converted into immutable code. So add friend, remove friend is there, and then we share the store using context provider, and this is the hook to access the context. Use friend store, and that is what we were using here. Use friend store. Similarly, you have a search store. So that concludes the demo. Hope you got a practical idea of how Solid looks. Now, uh, enough suspense. Tell us how it obliterates React, because that's how generally these introductions go. Like this is 1,000 times better, and whatever you were using is not good. Well, that's the neat part. I won't. What I've done is that I've made this demo in Solid and in React. All the code is open source. All the demos are hosted. The links are active here. So you can go to these places, analyze things for yourself, and you can see the bundle size, how the code looks, how readable it is. Up to you, because what we have realized even in yesterday's talk, like what matters to Coinbase doesn't matter to Flipkart. Maybe priorities are different, so it's up to your team to decide what you like better, and you have to do the ecosystem evaluation. The libraries you care about, are they there or not? So here are the things that I really like. So one thing is one-way data flow, because this is the key thing I loved in React. That there, even when the app scales, there is a way to figure to trace the things how it is how the updates are happening from top to bottom, and we know it becomes scalable and maintainable. And Solid has the same concept. You can start from the app and you can break down in the trees your components and you can trace things. The primitives are composable, so you can have a signal, and on top of that you can have an intersection observer primitive, and on top of that you can have a carousel primitive. It's up to you, and it doesn't have to be component. It can just be a wrapper on signal and effects. Up to you, just like with custom hooks. I really like that there is a immutable shared store feature already provided by Solid, which is of course tree shakeable. So that way, I don't have to go to every project and figure out which update store updater they are using, like Mobex, Redux, or whatever. So that, and this their one is really powerful. Like I generally like Mobex, and their one is very similar to that. I really like that it is very modern with concurrent rendering that React is taking care of. That is there in Suspense also. Sorry, that is there in Solid also. Now, in terms of performance, uh, Solid is really great at SSR and runtime performance. The reason it is very performant in SSR is because there is no virtual DOM. So whatever template is, and it doesn't have to create effects also, right? Everything is just rendered once. So literally all the component code that you write, all the JSX you write, it becomes a string, and that is returned. So the runtime, so the SSR performance is really great. It is not like it has to first create objects and then convert that object into string. So that part is really great. And this conversion happens at compile time. So, and the runtime performance is really great because of these granular reactive primitives. uh, Also, like there is a benchmark place where all framework authors have their benchmarks, and Solid is really at the top level of there, and all that in 7 KB gzip. And many of these Solid features are tree shakeable. So it may happen that your bundle size from the vendor bundle, it is not even 7 KB. Of course, when you add router and all that, it will increase. And here are all the other things that Solid provides. Some are from their ecosystem, like nested routing. So if you're interested in Solid, you want an intro video, here are three options based on how much interested you are and want to spend time on. So one is a 100-second video, the second is a 10-minute video from their channel, and third is a recent video by Ryan Caniato, the author of Solid, which is an hour of it. It's still an introduction video, but it's like he nails down all his mental model and how he arrived at this. So yeah, that's my talk. Over to you, Tanisha.
That was an amazing talk, Aditya. Or should I say, like, it was a solid talk. Apologies for all these solid ones. If you have any one-on-one questions to ask to Aditya, you can find him in his session. And yeah, let's move on. And I think like after solid, like it would be great to have a talk on TypeScript. Like it just fits when we are talking about good experiences, developer experiences, and everything in general. Next up, we have Gaurav Gupta. TypeScript lovers, I should assure you that you don't want to miss this talk. Gaurav Gupta is a lead software engineer at Smallcase and will be speaking about React conditional props with TypeScript. Gaurav is one person who has always known so much about design system, front end system, design accessibility, and web security. So we can't wait to hear this talk. So the stage is yours, Gaurav. Just enlighten us with your talk.
Hey Gaurav, you are on mute. Gaurav, you are on mute.
Sorry for that. Yeah, hopefully you guys can see my screen. I'll quickly start the slideshow and I'll try to finish my talk within the 10 minutes. I'll quickly go through the agenda and everything. So, hi, I am Gaurav. I've been working with Smallcase for about 2.5 years now, and today I'm going to talk about conditional props in React component and how TypeScript helps with the developer experience around it. Quick things about me: I live with my family in Bangalore. I've been working at Smallcase. You can find my social handles on the right hand side to ask me any questions after the talk. Quickly moving to the agenda, this is what we would try to cover in today's talk. I'll try to define the problem in the most relatable way possible because I want this talk to be beginner friendly. So I'll try to define the problem with some real examples from small case code base. Then I'll just discuss the solution skeleton and then hopefully we'll see the solution working in code sandbox. Then we'll also look at some of the problems that still exist with the current solution, and then I'll try to define names for the things that we are using as part of the solution, because like I don't want to discuss those names within during the talk. That might be slightly advanced for people. Then the expected outcomes out of the session, I am definitely not expecting you to understand this pattern just by going through this talk. I'm expecting you to know that these kind of things are possible with TypeScript, and I'll give you some pointers about what these patterns are called so that you can do your further research. uh, Quickly trying to define the problem. This is one of the examples that I'll use. So if you can see, this is a CTA component as we call it internally, and this can be rendered as a button, this can be rendered as a link, or this can be rendered as a general div without any operation. In the first example, you can see for login, it actually just opens up a modal on the same page. For discover small cases, it opens up a new link within the same small case website. And in the third example, which generally we use on mobile where the tap area is really less and we want people to make sure that tapping anywhere near the CTA actually does the trick for them, we make sure the container is clickable but the CTA itself is non-interactive. Going to another quick example, we have this placard component which can have multiple variants. One of the variants is a no-op variant where we just show some static text which is not interactive. Another variant is this internal link variant where we have this create small case button which takes you internally to the create small case page, and it uses a React router link to render this internal link component. Then there is the CTA placard which uses a button which on click opens up a model on the same page. And then there is this download app CTA which takes you outside of the small case ecosystem, in which case we use the anchor tag for this component, right? So just coming back to what the problem is, you would have components which have multiple variants which would take multiple props, but not all the combinations of those props would be valid. So how do you make sure that your developers, while using the component or at runtime, do not end up passing invalid props or invalid prop combinations, and rather they get to know this information much earlier, right? So in our example, when you want to use the link CTA, you would want to make sure that the consumer passes the href prop. But when you're using the button CTA or the no-op CTA, you want to make sure that the prop is not possible to pass at all. Like there should be some check that the href prop is not going to be applicable with button or no-op.
a few things that are outside of the scope of current discussion, because I know some of you might have these questions. One is, you might think that this component is trying to do too much, and it is better to actually make individual components for button CTA, link CTA, and no-op CTA. Again, we can discuss this separately. Button versus link debate for things like why do your links look like button. I think this is again outside of the scope of this talk. We can definitely discuss it separately with respect to accessibility and semantics. Now, coming to the solution skeleton, what do we want as a solution, right? So as I said, we would want to make sure that the developers do not mistakenly end up passing invalid combination of props. So somehow we need to stop it at the development level itself, right? And what would help with it, if your IDE can provide some kind of intelligence and auto completion around which props are valid, what is the valid value of those props, and which props are not valid, and if you try to pass in that prop, the IDE would show you a warning on an error. That would definitely be great. But the major thing that we anyway need to ensure is, even if invalid combination of props is passed, the component does not break at runtime, right? So this is something that we need to definitely ensure. The third part, which is not breaking at runtime, this is something that you can make sure by following certain patterns in your code base using regular JavaScript as well. But the first two things, TypeScript can definitely help us with that. So we'll quickly see how TypeScript can help us with that. Going to the solution, first thing first, we'll try to create the markup and the styles. So these are some screenshots for the markup for anchor, markup for button, markup for div. Notice that we are actually using the semantic components for link and button and div, and not using a div for everything. Then you might also notice something called rest or spread props here, which is something that we'll ignore for now, but we'll discuss that either in the example or after the talk. The second thing is, we need to have some way to define when to render each of these individual markups. So in this case, I am just taking a kind prop, where if the consumer passes kind equal to button, we just render the button. If the consumer passes kind equal to link, we just render the link. And if if the consumer does not pass a kind or passes it undefined, we just render the div. Now this is completely in JavaScript till now, and we have this problem that if someone passes kind equal to button but also passes href alongside it, there is no way for us to tell them that this is invalid. Like, we can definitely it is not easy to do that using prop types. It is not easy to do that at compile time or build time using JavaScript. Definitely we can do that at runtime, but then that is probably too late. So the next thing that we would want to do is to start adding types to it, right? So one quick way of adding types to this, which would be incorrect, which wouldn't solve our problem, is you will create a single interface called CTA props, where you will add all the props that are possible, and you'll just make sure that any props which are not applicable for all of these different variants are marked as optional. For example, the href prop, since it is not applicable for button, it is only applicable for link, you pass it as optional. But this does not solve the problem, because when someone is trying to use the component, even if they pass kind equal to button, and if they start typing href, the IDE is still going to show them the intelligence that href is something which is possible. It will not tell them that if you are using kind equal to button, you shouldn't pass href, right? So how do we solve that? We solve that using something like this. Like, just go through this pattern. We'll discuss this in slight more details, but like, some of the things you can ignore for now for the context of this talk. So we define a common interface for all the common props that all of these different variants should have. So in this case, text is the only common prop. Then we define a button CTA prop, we define a link CTA props, we define a non-semantic CTA props, each of which have a hard-coded kind mentioned there, right? This information is important. The kind thing has to be part of each of this definition, because that is what helps TypeScript with narrowing down what you are trying to pass. And then you can see that the href prop is only defined for link CTA props and not for anything else. You may also notice that there is something called react.component props without ref, which we are using to make sure that this component allows any props which can be used by HTML button, which is like in accordance with the REST pattern that we saw earlier. But yeah, that is not really important for understanding what we are trying to achieve here. We are trying to achieve that href prop should not be allowed to be passed from button CTA or from non-semantic CTA, and href prop should be mandatory when you are passing the link CTA, when you are using the link CTA, right? And this is how our component looks like now. It is mostly similar. We still use the props.kind equal to button, props.kind equal to link, but the only thing that we have changed is that now we are restructuring the props much later instead of destructuring them earlier. This is required because that is how TypeScript narrowing works. So this is like just one thing that you'll notice has changed, but nothing else has changed. As such, we have just defined the props to be of CTA props type. I'll quickly try to give you a walkthrough so that like you can actually see how these things are working, or how these would lead to problems. Yeah, hopefully you can see my code sandbox screen. So here I have defined all three of them. There is a button, there is a link, there is a CTA which is no op, right? So where I've defined kind equal to button, if I try to pass in href, you'll see that there is no auto completion for href, and if I try to pass in, it will actually mention that href does not exist on this type. But at the same time, if I try to pass in href to the link, it actually gives me auto completion that this attribute exists on link ctaprops.href. There is another attribute which link accepts, which is at hreflang. And in case I do not pass href, you see that it is actually giving me an error that href is required to be passed, right? So I'll just pass some href for now. Similarly, on the no op CTA also, if I try to pass href, it will not give me a auto completion. Like the auto completion that you see here is just string auto completion, because I've used href multiple times as a string, but it is not giving me any prop auto completion, right? So this actually solves the purpose that we were initially heading out to solve. A few other things, because of this setup that we have where we extend from a particular component, you'll see that since we are using kind equal to link, it should only accept props which a link component should have. So if I try to pass it a disabled prop, it will not give me auto completion. But if I try to pass the disabled prop to the button, it will actually give me auto completion, because disabled prop exists on the button types in HTML, right? So this is something extra that we were able to achieve using this setup. So quickly going back to the slides, I'll quickly discuss why this works. So there is something called type narrowing in TypeScript, based on which it can determine, once it has narrowed down the types, that what would be the rest of the types be, right? So we are achieving type narrowing in this case using something called discriminated unions. I'll come back to that quickly. But yeah, this is what the solution achieves. Quickly going through some of the issues that you would see with the current solution, which can definitely be improved. One is we need to destruct the props much later instead of much earlier, as some of you might have a habit of destructuring the props earlier. And another thing is, you cannot ignore or cannot omit the kind prop on the div. You have to actually pass it as kind equal to null, so that TypeScript can correctly identify it and narrow it down, right? So this kind of concludes the solution. I'll just conclude my talk with some of the related concepts which you can explore around this, and what are these patterns called, so that you can have some further research around it. The first thing that this uses is type narrowing using discriminated unions. There is a good documentation about both of these things in TypeScript official docs. You can go through that. Another thing that we have discussed is conditional props, in which your React component might accept multiple combination of props, some of which might be conditional in case you want to pass some combinations together, and some combinations should never be possible. Those are called conditional props. We have also slightly touched upon a concept for polymorphic components. So you saw that these examples, they render as different HTML elements based on the kind prop, so button or link or div. So these are one variant for polymorphic components, where you render a different markup based on certain prop, and the component is polymorphic. It can render as any type of component, or any two or three type of components. Then the other pattern we saw was rest or spread props pattern, which we use to make sure that the consumer can actually pass all of the props which are which should be accessible to a button by default, and we do not need to explicitly expose them to the consumer. For example, disabled is something that we did not expose to the consumer, but since we were using this rest props method pattern, we were able to make sure that the consumer can still pass the disabled prop to the button. Then for polymorphic components, I think again, this is not the only pattern that you can use. You can solve the same problems using generics or generic components as well, which is slightly advanced, but yeah, that is definitely an option apart from discriminated union. Then another concept that you may see in the while is omitting the keys that you are already defining but extending. So in this case, if you saw, we are already defining type equal to button, which means that when we are extending from the button type, we should actually not extend the but type key, because we do not want the consumer to be able to pass the type key, because we have already hard coded it, in which case you would omit it. I have added this to my code sandbox. You can check it out there. Another thing that generally happens with conditional props is that you use never for keys that you do not want to allow in a prop combination. Never is again a concept which exists in TypeScript, which makes sure that if you try to pass in a value, you are not allowed to which will you will definitely face while you are working with conditional props. And then, yeah, I think already discussed intersection types or generics for extending component instead of or alongside the discriminant union, right? So these are some of the concepts that you can explore to understand more about these patterns. This concludes my talk. Hopefully you got this awareness that these kind of things are possible with TypeScript and how they can help with your development or developer experience. Thank you everyone. Please reach out to me on Twitter or elsewhere for any further questions that you have. Back to Tanisha or Megha.
That was one hell of a lightning talk, Gaurav. I can't imagine how much you told us in such few minutes. I guess like a lot of you would have liked this talk and would have want to discuss more with Gaurav. You can take more of his time by moving on to the sessions tab and ask him questions if you have any, or simply tell him how great his talk was. Next, let's move forward. Now we have Prateek with us. Prateek is a tech lead at Porter and he's gonna talk about how Rescript changed the way we think about front-end code. Rescript has been the talk of the town, so I guess a lot of us would be interested in this talk. He has been working very closely with Rescript for past few time and genuinely wanted to share his experiences and insights around it. So let's hear it from Prateek.
Hi. Hi, my name is Prateek. I work as a technology lead at Porter. I have been at Porter for last 4 years now, and the journey has been phenomenal in terms of what I have learned and unlearned, and you'll see a part of that in the talk today. Outside work, I do like traveling, learning new languages, a bit of dancing, cooking, and taking care of my health. A bit about Porter before I start. Porter is the largest intracity marketplace for logistics. We connect businesses to our 4 lakh plus network of driver partners to solve their last mile delivery needs. We also solve use cases for you and me, like hyperlocal delivery and packers and movers, and with solutions of that order. Cool. Let's jump into the talk. So how Rescript changed the way we think, and I should say write code. So before that, what is Rescript? So Rescript is a language quite similar to JS, uh, but it has a robust type system of its own. And this type system is inspired and is from a battle-tested OCaml, which is a very quite old language and has been in the ecosystem for a long time. The second thing is it has a lean toolchain that does not waste your time. So by toolchain, I mean a network of a compiler and a network of libraries in the ecosystem. So you can see a project containing around 1 lakh lines of code takes approximately 41 seconds for the initial compile, and that reduces when you start like editing on top of it in the watch mode. Along with Rescript, obviously we have something called as Rescript React, which is like React only with bindings to the JS React. So on my left hand side of the screen, if you see, we have written a component in Rescript React, that is React using Rescript. And on the right hand side, the component is compiled to the JS. So the code, if you see on the right, is very similar to what the JS we write. So this is just to prove my point that Rescript is for the JS developers. Before I move forward, Rescript is designed to be for the JS developers and to create front end for the JS folks. So now, how has Rescript revolutionized front end at Porter and changed the way we think and write code? So right now we have 8 products in production on Rescript with around 5 lakh lines of code. And the way I would want to discuss this change is in under 3 heads. The first one is Rescript enables us to think in terms of functional paradigm. What does that mean? So functional programming is all about seeing things or solving problems in terms of data and behavior. So if you see the component, which is a functional React component, and by that what I mean is if you give it the same data, it will render the same thing. So it's a pure function with no side effects. So if our code base is built out of these small components, or I should say composed of these small components which are pure in nature, overall you end up having a very robust and scalable code which is easy to debug, easy to extend, right? And let's understand it with a very quite a practical example. So imagine you are creating a geographically agnostic code base, which means a code base, for example, you are writing a front end, creating a front end for India, but you want to scale outside India. So what would be your the line of thinking? So generally, currency and timestamps are two things, or timestamp or date are two things that would come to my mind, and I would want them to model and work perfectly, right? So this is a timestamp module which we have written in Rescript, if you see. And on the left hand side, you have the, sorry, I think this is on the left hand side, you have the module, and the right hand side, I think there is some issue with the file. So that is interface. So that is my bad. So just you focus on the left hand side, what you'll see is a type T, which is float, and then it has certain functions or the helper functions associated with it, and this whole makes up a module. So now you don't have to worry about my timestamp is in float. Now how do I convert it to this format, or how do I obey certain time zones? This module does everything for you. So if you say ki my order entity may whatever, say if you have an order entity and it has a timestamp you have defined of type timestamp.t, so you don't have to worry about any further. You'll just say timestamp.set time zone, timestamp.toString, toFloat, toJSDate. So if you see the way we model or think about our entities, if that is correct, if that is working perfectly, then you don't need to worry about how it works in the system. Same way we have a currency module and things of that order. So that was number one, functional programming. Second thing is it has boosted our developer efficiency, and the reason for that is there are 3 bullet points. One is that statically typed language, which means compiler is your co-pilot. When you write code, we know that it is going to work. If the code is compiling perfectly in your system, then you just need to ship it, bundle it, ship it to the client, and I can say with 99.9% guarantee that it will work unless my APIs are not giving me what I want. If the APIs are giving me the right data, my code is going to work. So if I get a screen like this on my local, this is like a perfectly compiled code, it means it's going to work. Second is better time estimates. So for all us developers, time estimation is something we struggle with. And this is a side effect of us using Rescript and the associated philosophy. So if you see this is a typical time estimation for a project we did at Porter. And the way we do time estimation is we divide the way we see our code, the same way we do the time estimation. So API models, entities, repos, domains, state mapper, view models. So we know these are the individual blocks of our code, the layers of our front-end application, and we estimate the time for it. And if you see the actual, then we do some retro and see what actual time it is taking, and it's been helping us, and over the period of time we have improved our accuracy. So yes, so gone are the days when you say I need 20 days. At the end of 20 days, you say I need another 20 days. Okay. And the last thing is documentation is in the code. So I was talking about modeling entities, right? So if you see, this is a pricing dashboard campaign. It's a pricing dashboard which we have created on our end. And if you read this code, you will understand, even if you have very little context of the business or the language, you will understand what this code is doing or what is this modeled as. So here you see I have a type campaign which is of 4 types. It has certain attributes. And so imagine if you have a whole code written like this, whole code base written like this, it becomes so easy for the new developers, existing developers to read and understand what the code is doing. And the third thing is fast resolution of technical debts. So as we code, technical debts are a side effect, and they will come, you cannot avoid them. But what we can do is we can quickly identify them, and we all are good at identifying also. The problem comes when we have to resolve them. So if you see below, we did a code refactor and around 808 files changed. This is one of the code refactoring which we did. We created a in-house Catalyst repo out of our we got some common code base out, and we just made it live in production with just one developer sanity and a small QA sanity, with no zero production bugs. So that is how easy it is to do code refactorings and get rid of technical debts. Cool. So this is and the end. So this is how we see our front-end application: view models, entity, API models, network requests is what we see from outside. And when you see things like this, then you model them accordingly, and it just never disappoints you. So in the end, if you think about your problem right way, and then think about your mental models, basically, if your mental models are how you will write your code, if they are solid, then I can guarantee you that your code base is not gonna disappoint you. Cool. So I'm grateful to this wonderful book, Domain Modeling Made Functional by Scott Mashin. Amazing book. Blush and Unraw, they always help me. ReasonML, the Rescript was earlier ReasonML, now it's Rescript. The folks who have created it, and they support us, and the amazing team of Porter, without which I cannot imagine. Twitter at Porter's booth, you can connect with me there. And yep, back to Tanisha and Megha.
Thank you. Thank you, Prateek, for that wonderful talk. Just to remind everyone, all the speakers would be hanging around in the sessions in your expo, sessions in your Hoppins platform. Please ask Prateek your questions on this wonderful talk that he had to share with us. And don't forget to visit the expo booth where all the sponsors, including Porter, will be hanging around. I guess without wasting any more time, let's just head to the next one. Next up, we have Jasbir. Uh, Jasbir is a SD3 at Swiggy, and today he'll be sharing his thoughts on how we integrated React Native in the existing apps. So over to you, Jasbir. All the best.
Hey, hi. Thank you, Tanisha. So, thank you for having me here. The topic for my talk today is how we integrated React Native into existing native Swiggy apps. So, Swiggy has its existing Android and iOS apps live on App Store and Play Store. So this is about last year when we started experimenting with React Native, and we wanted to see if we could power some small content in the native Swiggy apps through React Native. So, okay, I'll start by introducing myself. My name is Jasbir. I'm working as a software engineer in Swiggy in the Diners team. So, Diners is a new business line that is coming up inside Swiggy. So, we have a lot of different business lines like Instamart, Genie, stores. These are different business lines that we have. Diners is one of the newer offerings of Swiggy where you get sort of perks and discounts when you're dining out at a restaurant. Yeah, and these are my LinkedIn and GitHub handles. You could reach out to me and we can talk. Okay, so I'll start by talking about why we chose React Native to build a new business line within Swiggy. So the new business line that I'm talking about is Diners, which I was talking about earlier, which is the team that I'm from. Okay, so the first reason why we chose React Native is native interaction and capability. So when it comes to native, the performance that you see of a native app is always much better compared to, let's say, a WebView or any other cross-platform solution. So there are actually very sound reasons for it. Basically, a native app is built differently. It is built to interact directly with the OS and the hardware of the system. So let's talk about WebViews. So in case of WebViews, you don't get all the capabilities that a native app has. For example, if you had to interact with Bluetooth or let's say Wi-Fi hotspot or even camera of the device. So these are places where native apps have an edge, and we wanted to leverage that edge, obviously. And the second reason why we chose React Native is speed of development. So we wanted to have this business line out as fast as possible. And we wanted it out for both the platforms, Android and iOS. So React Native lets you do that. Lets you write common code. 99% of the code that we wrote is common, except for that 1%, which was some conditional platform specific code. And regarding speed of development, like there's one more issue that I faced while working with native apps. So when you're working on Android Studio or Xcode, so especially if your project is large, right? So even if you change a small string in your project, you would have to rerun the project, and it will take anywhere between 10 to 15, 20 minutes, depending on the size of a project. So this is a problem when it comes to coding, and React Native comes with, as we all know, hot reloading or live reloading. So that helps you speed up the developer experience greatly. And finally, the ability to be able to send on-fly updates. So native apps go through their own tedious process of releases on App Store and Play Store. They get reviewed, and then finally they are released. And again, it's up to the user whether they want to update it or not. So with React Native, using code push, you can achieve a lot of different sort of update methods in which you can have the newer bundle downloaded in the background, and then once the user opens it again, you'll be able to see the newer bundle. Or you can have the user choose whether they want to update the bundle or not. So all those capabilities are there while still being able to send updates on fly. So you don't need to rely on App Store or Play Store updates. So I'll first talk about what we were trying to accomplish with this. So we have an existing native Android app, which is written in Java and Kotlin. And then we have an existing iOS app, which is written in Swift and Ruby. And what we wanted to do is to have some React Native powered content, which would work on both these platforms. This is standard, like this is what React Native does essentially. So the only difference here is that we had existing projects, Android and iOS projects. Okay, so in order to solve this, we came up with our first initial sort of naive approach, where we had a parent React Native project, and Android and iOS were sort of sub projects or sub folders within this parent project. So the folder structure would look something like this. You have a React Native project, you have an index.js, you have SRC where most of your code lies. And then you will see in green and blue these Android and iOS projects, which are sort of subfolders within the parent project. And then there's this package.json. Package.json will generate node modules, and everything, all the packages, sort of React itself lies inside this node modules. So basically React is a lot of things. And one of those things is that it's a native library in itself, which helps you render native content using a JavaScript bundle. That is what React is in a nutshell, sort of. So in order to get those React dependencies, which are Gradle dependencies or pod dependencies, you need to specify a path where it needs to look for those dependencies, which is node module. So inside your settings.gradle or your pod file, you will find something like a // node modules, which will sort of reach out to the parent level node modules and pick up dependencies from there. So I'm not sure if you are able to see it, but we started with this approach and we faced a lot of challenges with this approach, which I'll cover here. So the first challenge we faced was close coupling between React Native and native, of course, because native projects, Android and iOS, are subfolders within the React Native project. So we did not want this. We wanted to have a decoupled system where native doesn't need to care about what React Native is doing, and React Native doesn't have to care about what native is doing. And another problem that we had is the build time would increase. We already had native existing apps and they already had large build times. So we do not want to add on to this build time. So this build time is essentially the time that it would take for the React Native CLI to generate basically the bundles, Android and iOS bundles. So depending on your project size, this adds around 2 to 3 minutes to your existing build script, which was a lot for us. We actually wanted to cut it down, not increase it. And finally, it gets difficult to maintain. There is this large project, and it gets difficult when you're trying to manage releases. Like, let's say you want to send a pure native release, or you want to send just an Android release, or just an iOS release, or probably just a React Native release. So managing those releases inside this single large repository, and like moreover, there was no solid reason for us to combine all these projects into one project, because these are already independently functioning projects. We did not see any reason why we should be combining them. And yeah, finally, this is sort of the biggest reason why we did not like this method, because it would impact our existing native teams. Like, they would have to change how they work. Instead of cloning the native Android or iOS repo, they now would have to clone sort of the parent React Native folder and then work on top of it. And they might also require some knowledge, like people who are working with React Native, they'll know that there are some linking issues or library issues, which the native team doesn't frankly need to care about. So these were sort of the reasons why we did not like the initial approach. So once having identified what was wrong with our initial approach, we wanted to identify what we exactly want out of this current setup that we are talking about. So one is that we wanted to be decoupled from native, that is for sure. Like, Android and iOS projects should not be subfolders, definitely. And it should be easy to send updates. It shouldn't be a painful process. Then it should not impact the build time. Like, the build time should remain intact. And finally, it does not impact the existing native teams who are actually working on it already. So before jumping to the solution that we came up with, I'd like to slightly talk about how React Native integrates with native Android and what goes on sort of behind the scenes. So there are in total 4 major steps, like when you're trying to set up React Native inside an existing Android project. So firstly is the setup. You need to add React Native Gradle dependency inside your settings.gradle and app/build.gradle, and that will make your com.facebook.react, which is basically the React Native Android library, accessible within your project. So this will now be able to power content using React Native. Next is auto linking. Like, we have a lot of different native packages, like React Native Camera, React Native WebView. All these are sort of have native dependencies. So these, when I'm talking about native dependencies, these are basically Objective-C or Swift or Java or Kotlin files, which are present inside Node modules. So these are essentially just files right now, which are present inside Node. They need to be linked inside the Android project so that it is usable by Android or iOS. So that is what auto linking does in React Native. There is a script inside the React Native community package, which I'll be talking about in detail next. So this is native modules.gradle, which automatically links all those packages and lets you sort of use those packages. And next is the build step, where in the Gradle, there's a script which would trigger your React Native CLI to generate the Android bundle, which is the index.android bundle, which has all the JavaScript code. And then finally, this generated bundle needs to be copied into the project. So it is getting bundled with the APK file when it is going to the Play Store. So in this case, what happens is that there's this React root view, which actually comes from the React Native package. And this React Native root view will be able to sort of run the generated bundle and render native views using this bundle. So this is sort of in a nutshell how React Native works inside Android. It's very similar to how it works in iOS. So in the setup, again, like, there's this pod dependency that you need to add. Using that, like, the React pod will now be accessible. And for auto linking, there's again a counterpart, which is native modules.ruby script, which is again present in the React Native community package. This takes care of the auto linking like it does for Android. And again, you need to generate the bundle, but it's a separate bundle. It's an iOS bundle. So it's index.ios.js, which is generated using bundle iOS command. So this is again triggered automatically by React Native. And finally is the copying of this bundle, which gets sort of bundled with the IPA file. And finally, RCT root view will be able to run React Native using this bundle. Okay, so I was talking about auto linking earlier. So wanted to discuss how auto linking essentially works. So uh, I talked about it little briefly earlier. So basically, what auto linking does is all these Java or Kotlin or Swift files, which are essentially packages, get copied and then linked into your current target of the app, so that they are sort of usable Gradle and pod dependencies. So native app can sort of use them. You can read more about it here, like I've put up link here. So the script that I was talking about earlier. So if you go inside the source code of React Native, right? So inside React Native community, you will find this script. This is essentially the script that takes care of the auto linking part of it. So I wouldn't like get into the code of how this works, but you can go through it. I will just explain what it does in a nutshell. It will loop through all the dependencies that you have defined, pick up the ones that are defined as iOS or macOS dependencies, and then it will sort of copy them and attach them to your current target. That's it. It's not very fancy. There are a lot of other things going on. You can check out the file, but in a nutshell, this is what is happening. So this, like, you don't need to link packages manually. This is a very recent update in React Native which helps you do that. So this is a very useful feature. And similarly, there's this counterpart Gradle script, which is present again inside React Native community package. You can find it inside the CLI platform Android folder. So why I'm talking about all of this is that when we were coming up with our implementation, we actually went through all of this and we wanted to understand how actually React Native renders native content, and how all of these things that we sort of just use, how do they work actually. So yeah, this is the script which takes care of it in Android. And finally, like, I'll come to our architecture, what we did. So instead of having this parent React Native project and having sub modules inside it, we built a standalone React Native project. And from inside that, we deleted the Android and iOS folders. And what we did is, like, whenever there is a merge that happens to the sort of master branch, there's a CI job, like continuous integration pipeline, that gets triggered. And it does a couple of things. Like, the first thing it does is it runs checks and runs the test cases, make sure everything is fine. And once it does that, it will finally generate the bundles itself on a remote job. So these will be the Android and iOS bundles, which it has now, and it will finally publish them as a separate NPM package. So this is a private package that we will use later. So the contents of the package you can check out here, like the third image. So basically, there's this package. It has a build folder. Inside it, you will find Android and iOS folders, and both will have the bundles and also the assets. Assets are essentially the icons or images, MP3 files, whatever you might have used. The interesting thing here is the package.json, which you see in the end. So this package.json is a package.json separate from the package.json of the React Native project. So this package.json will contain only the native dependencies which are required by native. So it won't contain any of the JavaScript dependencies. For example, Apollo client doesn't end up here, but React Native video will end up here because it has native dependency. So by the end of it, we have a published NPM package, and there's no extra build step required because the bundles are already built. So the next step that we do is we now go into the native projects. We create a package.json there, and this package.json is just essentially has just one. I might have, yeah, it would look something like this, like just one entry into the package.json, which is our custom RN. This is a private package on NPM that we have published. So we have this package.json that would generate the node modules. So what the node modules will contain is essentially what I was talking about in this slide. It will have the bundles already present. And from the package.json, all the React Native sort of library dependencies are already downloaded. So there's just one extra step that we needed to do, which was copying this bundle and linking it to the current app. And after that, like, everything is sort of done. The existing app can have go through the existing build pipelines, and whatever steps were there, it can continue. The bundle is already linked, so you don't need to care about anything. So we already had existing native apps, and the reason we are integrating React Native into it is sort of we wanted to reuse some of the features that native already has. So, for example, the first thing would be fonts. Like we do not want to add fonts. Obviously, in our own project, we did not want to add on to the size of the app. So that's why we reused existing fonts. And then screens also we reused. Like for example, payments was entirely reused because that's an existing feature that Swiggy already has. So all we did is we wrote some bridge functions that would just navigate to those pages, and those pages already have whatever functionality is required. So you could sort of seamlessly transition between native to React Native and then React Native again to native, and nobody would get to know sort of which part of it is native and which part of it is React Native, except for us, of course. Like we know which parts are native. And finally, the headers, like uh, we have some network clients and network interceptors, some security features which are already built into the native app. So we did not want to sort of reinvent the wheel. We reused all these three components. There were some more, like broadly these three components which we reused from the native app. Okay, so let's jump back to our checklist that I was discussing earlier and see how our current solution implements all these three things. So the first problem that we had was close coupling between native and React Native. So we have sort of destroyed that because we now have a standalone React Native project. It doesn't need to care about what native is doing. Native doesn't need to care about what React Native is doing. So it's totally decoupled. There's just a package that is published, and native repo is going to use that package. There is no impact on build times. Why? Because the bundles are already built. So the native app, during the build step, it just needs to, the bundles are already present inside node modules. It just needs to sort of pick up those bundles and then attach it to the current app. That's it. And there is no impact on existing native teams because they will work as usual. We have just added one package.json and some integration code that we've added into the native repo. So for them, it's just a small PR that went into their project, and they will continue to work how they were doing earlier. And finally, it is very easy to send updates now. Like every time we need to send an update, all we need to do is publish that package and then update that package version inside the native package.json. That's it. And the next app release, whenever it goes out, it will have our latest published bundle. So like this, we have accomplished almost everything that we were looking for. However, that does not mean that it is the perfect solution. There are two future scopes that we have identified, which are sort of what we are looking to do in the future. So one of them is we have created a package.json inside native Android and iOS projects, and we also create node modules. So this doesn't necessarily have to work that way. So all we need is sort of native library files and then the bundles. So they could be all bundled together and published as a jar file or as a separate podspec project for iOS. And that could go as one single line of dependency inside your settings.gradle or your pod file. So that would clean up our current setup greatly. So this is something that we are looking to do. And the uh, next scope that we are looking to solve is slightly more complicated, where as like you all must be aware, React Native doesn't support chunking of bundles as the web does. So we want to support multiple business lines in Swiggy, which will be powered by React Native. So let's say there's a business line A and then there's a business line B. So both A and B could be using some common parts of code, but essentially right now both A and B are present in the same bundle. So every time A or B is opened, the whole bundle gets downloaded. So what we are looking for is implementing sort of a custom code push solution where there could be a bundle for A, there could be a bundle for B, and then there could be a common bundle. So whenever user opens a business line, the bundle that is downloaded is A and then the common, and we sort of do a plus common by ourselves. So this would like greatly improve the performance of the app and also the developer experience. Yeah, and that sort of wraps up everything that I had. I hope this was informative. I'll be happy to take questions. I wrapped it up quickly. I did not want to eat into the lunchtime. Thank you.
Thanks, Jasbir. That was really wonderful. All our speakers, including Jasbir, will be hanging around in the sessions tab. So please go ahead if you have any questions and just get your questions answered. Uh, we a little bit ran into the lunchtime, so let's just quickly head to the break, energize ourselves, have some food, and be back. So we'll be back at 1:50. So we have around 30 minutes, and then we'll proceed with the rest of the talks. So see you soon. Have a lunch, and we'll be back. Bye bye.
Welcome back, everyone. I hope you had a good break and now back from it because now we have another set of uh, talks for you. So let's move ahead and see who we have next. Um, Up next, I would like to invite Manohar. He is a senior software developer at Latitude Pay Asia. He's gonna talk about a very interesting topic, uh, handling dynamic links when the app is active offline and when it is not installed in both Android and iOS. So seems pretty interesting to me personally. So without wasting any further time, let's get Manohar on stage.
Okay. Oh, okay. What's wrong with my video? Okay. So let's go ahead. Uh, so today, hi everyone. So today's my topic is handling. So I'm Manohar. I'm senior software engineer at Latitude Pay. So and I've been working on React Native since 0.58, and yeah, and today's my topic is handling dynamic links in React Native. Yeah. So let's get into it. Yeah. So yeah. So what are dynamic links? So this is the Firebase definition of the dynamic links. So dynamic links are the deep links into an app that work whether or not user have installed the app yet, and the user opens a dynamic link in an app that is not installed. It will take them to the Apple App Store page or Play Store page, from where user can install his app directly. And from after he clicks open, from after installation process is done, he clicks open to the app, and the content won't be lost, so the content will be there, so user can still see this content, the entire data that is in the link, so user can access it after he opens the app. So Play Store installation, and don't make it lost. So if you look at the uh, chart on the right side, this is how you debug normally deep dynamic links. So if you just add a d equal to 1 at the end of the dynamic links, so you can see the chart like this. Any dynamic link, you can see chart like this, so you can debug like how the dynamic links act or behave at the different platforms. Yeah. Mm. So yeah, let's see some use cases to better understand dynamic links. Yeah. So uh, if you so you can link your users to their favorite songs, and link them to their like any favorite movies of them, to directly without any going through the process or anything. So you can link your user to the movies and stuff. So you can link your users to their payments. Yeah. Okay. So linking to the payments is not working, I guess. Yeah. So because the UPI links are not dynamic links, they are deep links. So the problem with deep links is that they're different. They have different URL schemes. They need different URL schemes for work on different devices, and they don't work if the app is not installed yet in the app. So this is how a normal deep link will look like, or any UPI link will look like. So it will contain your UPI ID and name and other details. Yeah. So let's try to convert this to a dynamic link. So yeah, so yeah, if you notice, I added all the parameters that are after UPI. I just added to my UPI.com. Uh, so yeah, so it doesn't work directly. So not because I don't know my UPI.com, just because I have to do some configuration for this link to work. Yeah. So what are the configurations? So first you have to do some configuration on Firebase side. Then you have to do some configuration on your app side for for your app to accept dynamic links. And there are some other changes you have to do. So first you have to configure domain. So if you go to Firebase console and click on dynamic links at the bottom in the nav bar and click get started, you can add your domain there. And then uh, you can configure a prefix, path prefix. So it is optional. If you don't give a prefix, so every link of your app will go to every link of your domain will go to app directly if it is in that platform. So if you want to like filter from some links to go to app, some links should work fine on web, so then you can configure that here, and it will give you some keys that you have to give to the DNS provider and add it on your domain will work. Yeah, since as I mentioned I don't own my upa.com, I'll proceed with page.link. Yeah, so this is page.link is something that is provided by Firebase, so it's free to use. Yeah, so that is done. Let's create dynamic link. So how do we go about it? So you can just you so if you click on like proceed create a new dynamic link button on the dynamic links uh, tab, so you can do that here. Like you can configure your like url, and then you can add your url that dynamic link will expand to here and some name to it, and you can configure how it should behave like in different platforms. For example, in Apple, we want a dynamic link to open an Apple app directly. So you can do that here. For it to work, you have to add your App Store ID and Team ID, and then same with the Android as well. So you can add your deep link to work on Android. Like do that, and you can choose like if the app is not there, if the app is not installed, take him to the Play Store page of the link or any custom URL you have for the install. You can add it here. Yeah, and then some optional campaigning stuff, and the dynamic link is ready. And there are other ways to create. You can create a dynamic link from backend, which is the most normal use case. So you can use any Python or Node libraries for that. Like this is one of the Python libraries, dynamic links, Firebase dynamic links. So you can use, and the code will look somewhat like this. Yeah, and now the app setup, and you can create dynamic links from the app also directly, but it is not the normal case. Like people don't do that usually. Yeah, uh, and the now the app setup. So you can run these commands yarn install Firebase and dynamic links Firebase and libraries, and then you have to do pod install obviously. And now the iOS configuration. This is a long process. Yeah, so you have to go to developers.apple.com, you choose your account and go to ID that you are configuring, and you have to give it the associated domain capabilities. So you can do that here. So once you add any capabilities, right, you have to recreate your provisional profiles. So if you have already a match configured, fastland match, you can run the command and create all provisional profiles again. If not, it's a laborious process that you have to create all them again manually. So now you have to do some configuration in Xcode. So since you have to add associate domain capabilities in Xcode as well, and you add your link here as like this. And you have to do some Android configuration. You have to add this intent filter in manifest.xml file here, and some JS. Yeah, so until now you haven't wrote a single line of JS. Now finally, so this is the only thing. This is the thing that is like entire talk says like handle dynamic links, and there's only one slide for it. Yeah, uh, so this is straightforward. So you can add this function in your initialization function app.js and call this function there, and if the app is initialized by a dynamic link, you will get that link from here, and you can do the corresponding process. If the link is like a UPI link, as I mentioned, UPI dynamic link, you can take the user to directly the payment screen. Otherwise, take them to the home screen directly. Yeah, so if you notice, there are condition like if the app is in foreground or background. So you have to have two different functions here. So on link is the foreground state. So for example, if the user will have the app open and he clicked on a dynamic link from some other sites or WhatsApp or somewhere, and it took him to the user, it took him to the app. So didn't call start, it just open. So on link will give you the link. Another case where the app is called started from the dynamic link, it will give you the link using get initial link. So you can differentiate foreground and background states using, if you have the function called in app.js, you can consider it as background state. Otherwise, if the function can call from the app state listener, then you can consider that as a background state, foreground state. And some other changes that I mentioned. So this is App Store ID, team ID you have to add. the Firebase, and you have to add a SHA-256 fingerprint to the Firebase Android. Yeah, that's it. We are done. Okay, so just to verify your dynamic links are working, you can go to this Apple Appset Association and Asset Link JSON pages to see whether they are working fine or not. If you get this JSON similar to this like objects, that means like they are configured well both in Android and iOS. So yeah, now how do you pay users dynamic links, and user will now be confused to scan which QR for which app. Yeah, that's it. So these are the resources and documentation. If you have any clarification needed, contact me at Manohar. I'm everywhere. Yeah, that's it.
That one was a great and as well as very real problem oriented talk. I would say we do have this issue with links a lot of times. So that was pretty insightful, Manohar. If you have any questions for Manohar, you can go to his session and ask him like directly on one-on-one. Next up, we have Aditya with us. Aditya is all might know Aditya because like he talks a lot around React Native over Twitter. So, but I would introduce him for anyone who is seeing him for the first time. Aditya is a software developer at Grow and loves to talk about things around React Native, cross-platform development, and how things work under the hood. Today, he's gonna talk around React Native, as we can all expect, and he's gonna help us understand the new architecture of React Native with JSI. So, without any further ado, I would like to give the stage to Aditya so that he can start his talk.
Hello, folks. I am Aditya Pahilwani. I love to talk about React Native cross-platform development and how things work under the hood. I work at Grow as a software development engineer, and I make your financial journey more easy. Apart from tech, I really love to play video games. One of my favorite video game is Red Dead Redemption 2. Absolutely amazing game. I highly recommend it to you to play it. I have a common social handle which goes by Aditya Pahilwani on these platforms: Twitter, GitHub, PList, and LinkedIn. Do follow me for more on mobile development and React Native, basically everything around mobile. So today we are going to try to understand about the new architecture of React Native with JSI. So what we are going to talk about, we are going to talk about how React Native works today, what are the problems with the current architecture, how JSI solves it, and a small demo of JSI. So how React Native works today. So we have a host platform here. The host platform can be Android, iOS, or Windows. We have a JavaScript thread where JavaScript and React lives. They communicate via a thing called bridge. They send each other messages. Let's just suppose you want to create a button. So if you want to create a button, the JavaScript thread will send some messages to the host platform, and they will receive that message and will create a button. Okay. So as you can see, they don't know about each other's existence here. They are talking from a bridge here, right? The communication between these two realms is happening via bridge, and it is totally asynchronous in nature, which means the messages which I talked to you about are basically some JSON payloads which are sent from native to JS and vice versa, and it's totally asynchronous in nature. So what are the problems with this current architecture? First, if there are too many operations over the bridge, it ends up choking it, which results in delayed event responses. So consider a scenario where you have some UI state here, and the bridge between the host platform and JS thread is choked with too many actions and too many messages. And at that point of time, there is a tap of button. When there's a tap of button, the host platform wants to send a message to JavaScript so it can execute the method, right? But as the bridge is choked here, there's a delay to receive the event which is sent by host platform, because of which uh, it created a bad user experience, because when the user tapped on the button, they expected a feedback there itself. But as the bridge was choked and because of the delay of the event, it created a very bad user experience. The same goes with things like scroll, touch, or any UI state event. Second is there's a slow startup time in React Native because all native modules are initialized at the start time itself. We might not even need all of them at startup. We need only few of them. You can see a pictorial diagram here. There is many things which goes around during the startup, but we are talking about just about the pain points. Next is the new architecture with JSI and CPP will completely solve it. There will be a layer of JSI and CPP and it's solved. Don't worry, it's just a joke. Before going to JSI and C++, let's try to get our basics right. So, have you ever thought about how the JavaScript runtime is created in the host platform? Because without JavaScript runtime, we can't execute the JavaScript code, right? Interestingly, I found a class in Java which was loading a C++ library. When I went to the source code, I actually saw C++, and just like you, I don't understand it, which means this all is gibberish to me. But I saw one thing here, which was JSC make JSC runtime. JSC runtime. Okay, basically JSC is a runtime engine which execute the JavaScript code. We have Hermes runtime too. So that with this, we are clear that the C++ has created the JavaScript runtime, correct? Which means the host platform talked with C++ and C++ created the JavaScript runtime, and the runtime lives in the C++ world where basically our JavaScript code is getting executed. It lives under C++, which also means C++ can get some properties, like not some properties, can get accessed directly to the runtime and do some changes around it and can access some properties of it because it lives under it. Next, like, have you ever thought about how native modules are invoked? So let's try to see the flow of native module from JS. First, native modules need some unique way to identify the native method because they aren't aware what's there on the native side. As I told you, they don't know about each other existence. They talk via messages, right? So they want some unique identifier to identify the native method. Next, they also need to be aware what type of method you have written in native, which is Java, Kotlin, or anything, whether it is synchronous or asynchronous, because they need to handle on JavaScript side too, right? Third, native modules invokes the native method via bridge because everything goes via the bridge. Bridge does some magic to call the native method, correct? So the native module specs are registered from native side via hack. So we register a method name, a gen module, to the global namespace. As I told you, the JavaScript runtime lives under C++, correct? So the C++ can get access to this global property, which is __fp gen native module, correct? Next, the native, which is like the host platform, which is Java, talks to C++ gets the reference of this method, which was registered in the global namespace, and calls it. So actually, this gen module function is getting called by native, and it sends you all the information like the unique module ID, the method ID, and whether it is synchronous or not. Then there's an interesting thing here, which is gen method. It is calling a method in gen method. Let's try to see what gen method is doing here. So it looks whether the type of the method is synchronous or not. If it is, it calls batchbridge.call native sync hook with some arguments. If it is async, it does the asynchronous way, which is enqueuing the call. Let's try to understand the synchronous part because it is easy. So let's see what this call native sync hook of batch bridge is actually doing. It is doing something here. It is firing a thing called global not native call sync hook, but we don't have anything as native call sync hook in global namespace, right? We don't have anything. So how does this method came into the place and how it is getting called? Interestingly, actually, this method is registered to JavaScript runtime from C++. And you can see something here. It is all gibberish, but you can get some part of it, which is runtime global set property with the name of native call sync hook, and it calls a C++ method. So it was in the end actually calling a C++ method, which means JavaScript code, JavaScript is capable of running a C++ code from a long time. Also, the bridge instance which we made is registered in the global namespace, so the native can access it. Just like the method which we talked about, the gen method, the bridge is also defined on the global namespace, so the native can access to it via C++. So, time to connect the dots. The C++ already lives here. In fact, C++ creates the JavaScript runtime. The bridge we talked about from so long actually goes from C++. That means C++ already exists, right? And there, JavaScript is able to call C++ methods, right? That's pretty confirmed. Next, what if instead of queuing our messages from bridge and sending JSON payloads, we have direct reference of the native methods via C++? Because as we just saw, JavaScript was always capable of running C++ code via the registered methods, right? So what if we have direct reference of native functions? That's where JSI helps us. So what's the role of JSI? JSI provides an interface where you can register C++ methods to the JavaScript runtime. It provides some helper method to handle JavaScript values inside C++. Why? Because C++, JavaScript, and the host platform language, which could be Java and Kotlin, these three languages treat all values in a different way. Strings, objects, array are treated differently there. So it provides some helper methods to handle those JS values inside the C++ sandbox. So how the new architecture exactly looks. So the C++ layer would have bindings, a sort of proxy methods, which in turn will call the native method written in Java or Kotlin. The JSI layer will help us to register these C++ methods directly to the JavaScript runtime, which we can access via the global namespace, as we saw earlier. Third, there is a part named as JNI, which is used in Android. JNI provides an interface to communicate between Java and C++. It's time for an example. We will create a method which returns UUID from native to JS. This method would be synchronous in nature. This method would be exposed to JavaScript from the global namespace with the help of JSI. What's the steps? We will create a simple Java method which will generate a UUID. That's straightforward. Next, we will create a C++ method which will call our Java method. We will register this C++ method to the JavaScript runtime, which we will access from the global namespace. Fourth, we will invoke the registered C++ method in JavaScript. Sounds straightforward, right? So the execution part. So this is a small code of Java where we are creating a UUID and returning it. The C++ method signature to call the Java method. I am using plain JavaScript language for easy explanation because we don't understand C++ that much. We have something named as create from host function provided by JSI. It creates a function which, when invoked, executes the C++ code which is passed in the callback. And if there are any exceptions, a JavaScript error is created and thrown. Host function expects some parameters, which is the runtime, the function name, the total parameters the function would expect, and the callback. And as you can see, it is calling the callback by passing some arguments to it, which is again the runtime, the this variable of the function, the arguments which are passed, the length of the arguments. Next, we will create a function which is calling create from host function, and we are passing these parameters, which is JavaScript runtime, and we are passing the method name, which is get JSI random UUID, and we are saying there should be no arguments to it. There's a callback method. This callback method does the main job here. So to execute a Java method, we need a JVM, because without a virtual machine, we can't execute the language code, correct? So we attach the JVM thread to execute the Java method. Then we use JNI to get reference of Java method and also execute it. We use JSI to create a string value which can be accessed via JS. As I talked earlier, as there are 3 languages in place, they treat values differently. So we need a value which can be accessed and understood by JS. This is where JSI helps us. It gives us help methods to create a value which can be understood by JS. This is the real implementation which we talked about in C++. Don't worry, because the main purpose was to understand the intent of code. And if you see here, we are doing the exact same thing. We are using create from host function of JSI, passing the necessary arguments, attaching a thread, getting a reference of it, calling the method, calling the Java method, converting it to a JSI value, and returning it. Third, we are registering the C++ method in the JavaScript runtime, as you can see here, like global.setProperty, the name, and the function which it will execute. Next, we are invoking the registered C++ method from the JavaScript runtime via the global namespace, which would be the global.getJSI random UUID, because this was the name which we registered in the C++ layer. Time to connect the dots. Let's go to some code here. As there were too many codes here, let me show you something. We are loading our C++ library here, correct? We have a simple method which returns a UUID, correct? We initialize our class, the C++ module and pass a parameter of the parameter of the JavaScript runtime. Inside the C++ layer, if you see, we are doing nothing special here, correct? We are just we call this function install JSTile with the runtime which we got from Java. We come here and we do all the thing here. We use create from host function. We do this and we register the method. It's already explained, right? If you see it from a close point, it's doing nothing special. It's just a proxy method, correct? This is just a proxy method, correct? Doing nothing special here. And if I go to JavaScript now, and now I can directly get access to this function via the global namespace global.get random uuid, and if you see it here, I am having I am calling the native method written in Java, completely synchronous from JavaScript with the help of JSI. Now, coming back to the dots, as I showed you, the method was doing absolutely nothing. The C++ method was doing absolutely nothing. It was just a proxy method, correct? So, when we hear about turbo modules, it's just a new way of creating native modules. If you know what is the schema of your method is the parameter it would expect and the return type of it, this whole C++ proxy method could be code chained. And this is what turbo module actually do. They will code chain all of your C++ proxy methods and will return you the method from the global namespace. That means everything you can directly call a method, native method from JavaScript, totally seamless in nature, which is quite amazing. The another part is now sorry. So sorry, I was talking about now native modules doesn't need to be initialized at the startup time. With the help of JSI, they can be lazily initialized, which can improve the startup time. Second, the event responses problem which you talked about. Now, as everything would be seamless in nature, there would be no bridge there, which means no problems of choking and everything, which means delightful user experience. And the second part is Fabric, correct? We also have heard about Fabric. So with Fabric, we will have direct access of UI manager to the JavaScript runtime via JSI, which means we can synchronously create views from JavaScript itself. Totally game changer, right? So I think by this, all of the things which we have been hearing from quite time, which is JSI, turbo modules, and Fabric, would make more sense to you. And the filling gap is filled, which was where the hell the C++ came into the picture and how this uh, bridge was working previously, what is going to happen next. The dots are connected now, and I hope you can whenever you hear about turbo modules or Fabric or GSI next, you are not afraid. It's quite simple, right? So these are the resources which I followed. Not quite, very useful resources. I learned a lot from it, and I would highly recommend it to you. Thank you for staying with me for so long. You can connect to me on Twitter or LinkedIn or wherever you want. I will be available to take your questions in the virtual booth.
Great talk, Aditya. Really liked the comprehensive explanation you gave us around JSI. Next up, we have Shirsh with us, and he would be also talking around React Native only. because like it's a React Native day altogether. So he's gonna talk about offline workflow in React Native with WatermelonDB. She's a senior software developer at Anor. So yeah, I think like please like personally I don't have much context around React Native, so like I am like so waiting for getting enlightened about this talk. So yeah, Sheesh, you can come on the stage.
Thanks for the intro, Mega. And I hope I can add some more info on the React Native, especially for you. So let's begin. Right. Just one moment. Yeah. Hello, React Bangalore. My name is Shirsh Zibbu, and I'm here to talk about offline work in React Native with WatermelonDB. So a little about myself. I'm working at Anurag Tech right now as a senior software developer. You can see on the screen social links for my profiles and our company's profile as well. We are hiring right now, so if you're interested after the talk, maybe give us a call, send us a message. You know how it goes. Okay, so let's begin with WatermelonDB. What exactly is WatermelonDB? WatermelonDB is a JavaScript wrapper library over SQLite, and it's meant to be cross-platform. So the main thing about being cross-platform is it is based on SQLite DB itself on React Native only. When you try to load it in the browser, it works on Loki.js, which is an in-memory database specifically designed for browsers. On React Native, it runs the query on separate native thread, which means our main thread is free from all the database activities and specially used for UI only. It uses observable data bindings. That means we can easily connect it with React for state management, state updates, and re-rendering. It has lazy loading. So the biggest problem with Redux Persist, and all of those JavaScript object-based data libraries is that the entire data is loaded in memory at one go. But the problem is we don't actually need all the data in one go. So wouldn't it be better if we load the data as and when we need it? That is the entire philosophy of WatermelonDB, and that's why it's better for React Native than any JS memory-based data management library. Also, it focuses on speed. Now, the speed word here is ambiguous. Definitely, the library wants to be fast in the processing of internal data, but also it wants to provide a speedy interaction for the user. What I mean by that is, when I run a SQL query, I don't want the query to load all the data and for all the results, but only bring the smallest set of results that we need to show on the screen and that can actually fit on the screen. So if we talk about the SQL clauses, we would have things like limit and offset. These are implemented in WatermelonDB as well, but in slightly different names. They're called take, skip by, and so on and so forth. You can learn more about the library itself on Noseby WatermelonDB website. All the links in the website are on the presentation are interactive, so you can open whichever you want. Let's go to how to set up WatermelonDB itself. So one of the first things we need to do is install WatermelonDB. Now, since it is a database library, it's not as trivial as just adding the package itself. What we need to do is definitely add the package, but that's only the beginning. Next, we need to add Babel plugin for decorators. That's because WatermelonDB relies heavily on decorator usage to define models and connect it with the schema file that is stored on the device. After installing these packages, we need to enable them in a Babel config file and enable the decorators feature in TypeScript config if we are using TypeScript. Second, for Android, we need to enable a new property called Kotlin version. The entire library of WatermelonDB Android site is written in Kotlin, so we need the new version to make it work properly. For iOS setup, I'll be honest with you guys, I haven't worked on iOS, so I wouldn't know exactly what is going on here, but this is the bare minimum setup that we need. Next up is the connect phase. Once you install the entire DB libraries, what we need to do is define a schema for our data that is used to store the data in SQLite DB itself. Next, create a model. The difference between the model and schema is whatever data is stored in the SQLite DB, it might not be usable directly in JavaScript or vice versa. So we need this class to load the data from SQLite and make it usable in JavaScript land. Once we do that for all our schemas and models, we can connect them to our adapter, pass the adapter to a database class, and then we have our database connected. Next is setting up with React. So far, the database has been React agnostic. You can create it and use it for any library, But since this is a React conference, let's see how we can use it with React. So in similar fashion to Redux, we have a provider. We pass in our database to it. And then in any component, we can connect it and load the data and observe it. So the keyword here is observe it. What this means is whenever the data changes in the DB, my React UI will also update automatically. I don't have to manage state myself. This is similar to how Connect works in Redux. But the special thing about this is if I'm observing 3 different records, so let's say I'm working in a library kind of application, I have multiple posts and each post has some comments. If I observe 3 posts, anytime any of those posts updates on the screen, my database will also track the updates. And if the data updates in the database itself, my screen will update in reaction. Second thing we can do is observe the entire table or collections if you prefer that. And that means whenever I create or delete any entity in a table, the entire list will be updated, but not the individual items. To observe the individual items, we have to observe them separately. This is how we would create any entity. So what we do is get the collection from the database, call the write method on it, and then pass a create function. The create function accepts another callback, which is passed in a record. So the post entity in the callback over here is a dirty entity. We can do whatever we want. No immutability is here. Assign any properties like you would in any other JavaScript variable. The entire library is async. So we need to add await all the places. And once we do that, we're done. So one thing we'd look at here is maybe it's not a good idea to always pass in the database directly and then call the collections and the write functions. We can add different helper methods on different model classes. So in this example, you can see on a post, if I want to add a comment, I can simply have another function called add comment. That will handle all the things related to database. Okay, now that we're done with the basics, we'll get started with the sync. In offline databases, syncing data with the server is the biggest challenge. And that's because the data can be large in volumes. There can be network issues, application issues on the server side. There can be problems with the data consistency. And we'll see exactly what I mean by that. Okay, first thing is sync with change sets. This is the default operation mode of WatermelonDB. What this means is whenever I want to sync data on the server, I don't actually provide the data, but I segregate the data in tables. In each table, I need to maintain a set of changes, and those changes have to be accepted by the database itself. Let's look at what the changes. So here we have a type ID, which is a string. That's because WatermelonDB follows string IDs. A type raw, which denotes a raw record. I've only written ID because different records will have different fields like title, name, age, date of birth, updated at, created at, all those things. The next thing is the interesting part, and that is the table change set. What this means is for any table, if I want to sync it on the database, I need to provide a list of things. If I've created or updated a record, give me the record itself. If I'm deleting it, just give me the ID. Then I need to aggregate all these things for the entire database, for all the tables, upload them to the server, and then server has to return in the same shape. This brings us to our mental model of the sync operation that Watermelon follows. We have to pull the changes from server, resolve any conflicts, and then push the updated data back to the server. In resolution strategy, it is similar to how Git would do it with the strategy called hours, which means local changes always win. And the keyword here is changes. So it might happen that I have the same data on server and client. That means there are no merge conflicts. It might happen that on a single object, let's say a post object, the title has changed on server, but it hasn't changed on the client yet. That means that we'll copy the server title. In case, let's say the title has changed on both the server and client. Now that is a merge conflict. And that is where we observe that WatermelonDB picks the local changes, which is great because we don't have to work on the merge conflict resolution itself. Here's the bare minimum implementation of a synchronization call. So the main thing here is we are importing a synchronized function from WatermelonDB sync. This entire function handles everything related to diff sync, partial updates, patch updates, and anything that you would expect in a manual solution. The only thing we need to provide is a function called pull changes that connects with the server, another called push changes that connects to the server for pushing the data and pulling the data. And this is it. So this seems like a pretty sweet solution if you ask me. But there's a problem. Actually, there are a few problems. First of the problem is the entire database is synced at once. And that means if I have a lot of collections in my offline database, let's say I was working offline for the past week, I need to update the entire thing in one go. If it fails in between, I don't exactly know what state my app might end in. Second is the changes are synced in bulk. So different and similar to the previous one, but let's see what the difference is. If I have a single entity, let's say I'm creating a meeting on Google Meet, I create the meeting, add some people, remove some people, change the time, add a link, and do all these changes. I would prefer if Google would show me the entire history of my actions. But in bulk changes, that's not possible. Bulk changes only track the initial and final state. That means I'm losing the granular activity that has performed on the entities. Another problem is API must be watermelon aware. Like I said just a few minutes ago, we have to provide a change set to the server, and server has to provide another change set back to us. That means if we have an existing system where a sync implementation has already been made, we have to rewrite the whole thing to suit watermelon needs. And that is not a good idea. But there's one more problem, and that is lack of customization and flexibility. So if I go back a few slides, yeah. As you can see, there is a lot of whole change to how we can override the merge config resolution, how we can perform granular changes on a record basis or on a table basis. What if we want to control that if one action fails, do something to inform the user, and if some other action fails, unroll the entire transaction in the local DB. These things are impossible in WatermelonDB because of its bare bones implementation. So what we need is a custom solution. For that custom solution at Analog Tech, we have created our own synchronization tool. I would like to call it a package, but it's not even close to a package. So it is a tool. What we do is, for every action that the user takes on our application, we add it to a queue of actions. A queue because it ensures that sequential processing of actions is happening on the sync protocol. We upload individual actions on the server, and the server applies the individual actions on the server database to recreate the data that we have on the client, hopefully. In case that doesn't happen, we'll see what happens next. So let's say this is the post and the comment that I've been talking about. And these are some models I'm using on my sales application. Now, there are few actions that can happen on my device, such as a create post, delete post, and create comment. Notice that this is not a generic action. So there is no update, delete CRUD or other CRUD actions. I'm very hyper-focused on things that my application is supposed to do. So in my application, once I have my action types defined, I will say for each action that I want to do, action type has to be one of these things. There will be a comment ID, post ID, and any other entity ID that I have. People who have experience in Rails might notice that this is a good place for polymorphic relations, but there's a problem with WatermelonDB in polymorphism, and we'll see how it goes. Next up. Yeah, so this is how I would create a post now. Instead of just creating a post and adding it to the database, I also have to create an action denoting that the user has created a post with so-and-so title and whatever the body is. I need a new sync function that handles each case individually, calls the APIs with the entire payload or in ID or both, and then returns whatever response has been processed. One of the new problems that we now face is ID matching. So what this means is, whenever I'm creating an entity on my app, we have to create the same entity on the server, but the IDs might not be the same. So how will my app keep a track of what entity was created on server? This is not a new problem. This has been existing in all kinds of offline systems that are synced with an online or remote location. And so there are a few solutions at our disposal, one of which is ID matching with global IDs. What this means is anything that is created on the app will have a globally unique ID, and we can use that single ID on our database as well. But it doesn't always work. Let's see. Okay, I'm missing a few slides here. Okay, So it doesn't always work because there are some databases that only work with integer IDs, MySQL, Postgres, and many other databases. And another problem that we generally face is UUID generation on the client might not be unique on the client itself. If an app resets and we're using some secret to generate the IDs, it might not work again. So the next solution is ID matching with ID pairs. What are ID pairs? Well, we maintain two separate IDs for each record, one for the client and one for the server. On the server, we call them client ID and ID. And on the app, we call them app ID and ID. This sounds a bit pretty confusing, but the overall idea is very simple. These pair of IDs will be unique for every record, and that is the keyword here. The pair is unique. So what this means is every time when I'm creating something on the app ID will remain fixed, and once it's created on the server ID will be generated on the server, but the server will also track what client ID was created. In response, I will get both pair of IDs, and I can easily match. For a client ID ABC, server ID has to be 123, and I'll update the records accordingly. The problem on this kind of system is it's not always trivial to add new fields on each table in multiple databases across different servers. So it might work for a small organization with a few distributed systems, but as the technological complexity grows, this might not span out well. This brings us to our final solution, and that is ID Cascade. Now, the problem with ID Cascade is the complexity goes through the roof. What I mean by that is we need to maintain two IDs on our app, but only one on the server. App ID is a string, again, that is generated by WatermelonDB. It will always exist on the app, and we can use it to stitch together our data on the app side, use for our UI navigations, and any other activity that we want to perform on app. That should always work. Server ID is the ID that's created by the server database, and only when the API is successful. That means once I create a post on server, I'll get the server ID, and I can use it for any subsequent API calls as well. So here's an example of an action model. This is a model that we'll use for synchronizing our offline database with the server. As you can see, there is a table called actions, an associations block that tells that the action belongs to post and belongs to commits. There are the two fields, type and payload, which denote what kind of action it is and what is the payload associated with the action. And then two relations called post and commit. These are relations tell me that this particular action belongs to some post and some commit. Now, again, as I was talking about polymorphic relations, it might again look like it's better to have a single field called entity type and another field called entity ID that can be used in conjunction to denote what post or what comment was used here. But there are a few challenges in WatermelonDB in tracking polymorphic relations, and we'll see next what the problems are. So after creating the app model, we have to update our schemas. We need to add the server ID to our schema and add the same field to our model. We also need to add the association, saying that the model has multiple actions. Once we do that, we have to write this whole code. Now, this is the code that we use for synchronizing our data. Let's see it piece by piece what's going on here. So this is the same function, but I've collapsed the switch block so we can see around the block. First, we get our entities that were tagged on the action. We create an updates list, which is supposed to be an array of models. And something happens in the switch block we don't really know right now. But at the end of the block, we will add another action that says prepare the current action for destruction. So if my action is synced on the server properly, I would like to delete it. Once all my updates are ready, I can simply pass them to database for processing. Let's see what happens inside the switch block on a case-by-case basis. The first case is a create post. When I want to create a post, I just need the payload. There is no ID present for the server. Pass it to the server. Server will return me some entity. That entity can be used to update our local records. So it might look like, again, this is overkill. Why can't we just replace the IDs that were returned by the server? That's because WatermelonDB works on assumption that a record's ID will never change. Why that is beyond the scope of this talk, but you have to trust me on this. Record IDs are immutable in WatermelonDB. We have to do something similar for create comment. In this case, we are using post.server ID. This server ID is coming from the post that we plugged at the top of the switch block, and that was assigned inside the create post callback. Now, what we do is run the API, get the response, and update the comment fields so that our comment is also synced on server. In case you want to delete something, we have another step that was not seen previously. Fetch all the children for the model that we want to delete, prepare each child for deletion, and then delete the record itself. That way, we have a clean deletion in case of foreign key cascades. And that was about it. Thanks for joining.
Great talk, Shirsh. It really woke me up. I was feeling sleepy after lunch. Pretty insightful. Uh, let's and yeah, I think I don't want to repeat it again. That if you have any questions, you can like move to Shirsh session and like ask him. Now we have one more talk before we go for our tea break. Next up, I would like to invite Palash. He will be talking about developing native iOS, Android, and Flutter SDKs in React Native. Palash is a co-founder at Diet, and they have been doing some hacky approach around putting their SDKs in major mobile apps at Diet. So Palash would like to share his experience and what all things they like learned during their, while they were creating hacky solutions. So let's hear it from Palash.
Am I audible? Yeah. So the talk is titled. It's hacky, but at the same time, it works. It's pretty interesting. I will get into what exactly multi-platform means here, but it's not just multi-platform, but how we wrote SDKs for multiple platforms and multiple frameworks in React Native. To give you like some background info, just a second. Yeah. My name is Palash. I'm the co-founder of Diet, and I also have been leading the front-end division of it, writing SDKs. I've previously worked in Android security at CloudSec. In this talk, like this particular SDK was also developed by Rohit Bhatia. He doesn't work at Diet anymore. He's working on his own startup, but I had to mention him as well. So to continue further, I first have to talk about the backstory of Diet because you need to have some context to understand why we made the decisions we made. So Diet, initially in November 2020, we started building a Zoom competitor. We got into Y Combinator and we were building a consumer app. Midway through Y Combinator, we realized that we could switch to the video SDK domain. And basically in March, we pivoted to developing video SDKs. To give you more context, basically we were competing against Agora, Twilio, and allowing people to embed real-time live audio video in their own apps. So March is when we pivoted, and in May we released our first web SDKs, and this is how our web SDKs looked. It's basically a one React component. You import that component and you get this entire meeting UI, a Zoom-like meeting UI. And of course, it's in your own app. It's a React component. You can customize it to look like your own app, to match your own use case, everything from like colors to like branding and theme. You can also customize it further using like the JS API. So we provided a JS API to like basically get all the meeting data, take actions on it. If I want to like mute myself, unmute. So we provided a JS API to take all these actions programmatically, listen for changes on data. So that is what we were till June 21. And of course, our pivot to SDK was showing to be successful. And so we wanted to now develop mobile SDKs. The only problem was that our total engineering team size was about 7 at that time. And while 7 might not sound like a too low a number, but in context of a WebRTC company, you have obviously the front-end SDKs, you have the actual WebRTC media layer, you have your SRE DevOps, and you have your backend. So, and us being an SDK, we could not provide a video SDK that only works in one platform or in one framework. So we had to support React Native, Flutter, Android, like native Android, iOS, because our customer's app might be written in those frameworks or platforms. So with a limited engineering size, limited engineering team, and us wanting to develop these SDKs, it wasn't plausible to like make 4 different SDKs. So we went with a very radical and a very different approach. What we thought, what if we could have one common code base that is powering our React Native SDK, Android, iOS, and even Flutter SDKs. More on this later. I know this could be confusing, but I can guarantee it's very interesting on how I'll walk you through how we developed each of those SDKs and the problems that we face developing each of these SDKs, but all of them are written in React Native. So step one was porting the React code to React Native. We already had a React-based web SDK. Now we wanted to port it to React Native SDK. So couple of challenges here. First, I'll talk about native modules. I know Aditya's talked like an hour ago, dealt with this subject, but I'll basically talk about native modules from another perspective. So when you are developing a React Native application, you are using the JS API and the APIs that are provided by the React Native system. But sometimes you need to do stuff that is not provided by these API, and so you have to write actual native code. So the native modules in React Native allow you to do specifically that. And talking about that, why do we need native code? We need native code to handle audio playback, like if you have a Bluetooth connected, switching to that, handling permissions, and etc. This is just a couple of examples that I'm giving you. But to build an audio video SDK, you'd need a lot of native code. So the problems, first I'll just explain how they work. To give you an example, we want to keep like the mobile screen awake. If you are in a meeting, if you are in a video call, you don't want your screen timeout to shut down your display. You want your screen to be open all the time. So how do you do it? You basically make a native module. And how do you make a native module? This is just an Android example. I'll also talk about iOS. But you make a module class, and that basically extends React context-based Java module. And in that class, you define your methods. So here, as you can see, I'm defining a method called activate screen wake, and I'm annotating it with React method. What basically all this magic gives you is that now from JS, I can call this function, helper.activate screen wake, and this will actually call the native part of it. So I can write all the native functionality I want and call them from the JS API. So this is how I write them, but how does the third part actually work? How does the React Native, how does it discovers my packages? While you're making a React app, the main application that you would have on Android would be an instance of like a React application. You'll link a React package to it, and this React package may contain different modules, and these modules will have React methods that you actually call. So this is how the linking is working. Like your application links to a React package, which links to modules. Now I understand that while most of you would not have developed these native modules on your own, you would have like installed third-party dependencies that would allow you to that would made you do npm run link. And so when you do that, that basically means that this particular dependency has a native code to it that you now need to link. So this is the Android side. On iOS side, you don't do any of this stuff. Like if you write a native module and if it's compiled into the code, it's discovered at runtime automatically. So now this is how linking is, how you would write your own modules. But now, for example, if I install a third-party dependency, how does the native module from that third-party dependency gets linked to my code? How does the React Native auto-linking work? So basically, the React Native, when you install a project and you link it, you run npm run link, if it's an Android project, there are basically two Gradle plugins that will go to your node modules, see your dependencies, see the node modules, and basically link those Android projects to your main project. And another Gradle plugin will now link the React package from that third-party dependency to your main application, to your React application. So on Android, these two Gradle plugins basically help you discover third-party native code. I'll tell you why I'm talking about this in detail, because while you're developing an SDK, while you're developing a native module, you need to worry about a couple of things. On iOS, there's a similar script based, which basically, again, because you don't need to do the linking on iOS, discovery is automatically discovered at runtime. All you need to do is make sure that these modules, they are built when you build your own app. So there's a script which basically includes it in your build scripts to also compile those native modules. The problem is these two scripts, these Gradle plugins and these scripts, they will only link, auto link native code that is in your dependencies. But if we have some dependencies ourselves, the auto linker won't link those dependencies. Okay, so now when a client who installs your SDK, the auto linker will only link the native code that is existing in the Dite SDK package, but not link the native code that is there in our dependencies. So how do you solve this? There's no straightforward solution. You write as much native code in your own SDK. And second, for stuff that you can't write, you basically ask the clients to install them on their own base app. So for us specifically, we use React Native WebRTC, React Native WebView, vector icons. So we ask clients to install them on their base app. So these are linked, auto-linked in their app building. So how does our SDK actually look? Basically, if you want to integrate a Dite SDK in your React Native app today, all you have to do is import this Dite module and basically this component, render this component. That's it. And you get the entire meeting UI and all the native code, etc. Everything else is handled by in its own. So now second part is now that we have a React Native SDK, our customers might also be using plain Java Kotlin apps or iOS Swift Objective-C apps. How do we give out our SDKs? How do we give out this React Native SDK to clients not using React Native? So our goal, we have three goals here. Our SDK, our Android SDK or iOS SDK needs to return a view which will contain the entire UI. It needs to give out methods to control the meeting, like disable camera, enable camera. It needs to listen for changes. And basically, third thing is client need not be exposed to a lot of installation steps. It needs to be as seamless as if it were an actual native SDK. So for these three goals, for like goal one, where we want to return a React meeting UI, what we do is if you have installed React Native, if you have bootstrapped your React, there are basically two ways to initialize React Native if you go on their official docs. One is for a fresh project, and the second approach is for a existing app, how to integrate React Native in your existing app. So using that pattern of initializing React Native, you can basically get a view that contains the entire React Native like meeting UI and return it back to the user. Now the second goal is how do you have clients call method on the Android iOS side and basically execute those events on the React Native side. So the way this works is you call a method, we emit a native event, which is listened by the React Native SDK. if there are any data changes, if there are any other events, React Native SDK will call a React method, the same React method from native modules. And when this is called, we basically do a local broadcast, and these classes, the died meeting, died self, died participant, these classes listen to these events. So you call a method, it sends a native event, is listened by the React Native SDK. Any changes in the React Native SDK, it lets the native side know by using React method and a local broadcast. On iOS side, we do almost the same thing. It's just instead of a local broadcast, we update a shared instance. So now what we have achieved so far is we are able to give clients a view back that contains the entire UI, and we are able to expose methods and data members to see what is happening in the meeting and take actions on it. So like this is how it looks. This is how the entire packaging looks. The third part is, of course, how to package everything seamlessly so that the fact that it's running React Native is not even evident to the client. Client is only exposed to the outer surface. So basically what you have to do is, of course, you have to package your bundle. You have to package React Native Engine, JSC core. You also have to package the native code required by other dependencies. React Native WebRTC, React Native Vector Icons, WebView. And you need to package all of this seamlessly. On iOS side, you don't need to like package JSC core, it's already there. But the point that I'm trying to make is that this whole packaging needs to be very, very seamless, that the client is, it's a single line installation at the client's end. So the way we basically, most of it is straightforward, except the second part, where how do you package React Native WebView in your Android project. So what we do is we basically, for all these projects, we build AARs. And once these are built, we basically include them in our Maven dependency. Now, because these are not these projects, they are only installed through NPM or yarn. So they're not there, they don't exist on any Maven or any central repository. So we basically package all of these, and we also put them on the like a public Maven. And when we publish our SDK, we basically include all of them as dependencies, Maven dependencies. So how does it look? How does it look to the actual client? So for a client who's just using Java Kotlin and wants to integrate our SDK, you basically put our package name in the dependencies. And if you see how it's actually used, you set, again, a couple of parameters that are required by our SDK, and you call dietmeeting.init with like the width and height, and you get like an Android view back that contains the entire React Native UI. So as you could see from this packaging, it's very seamless. One line installation, couple of lines of installation, and we are basically able to package all of this very seamlessly. Of course, during like this talk is I can't cover in depth on how we did this packaging, but there was a lot of gluing required here and there. As you would understand, this is not like a very straightforward approach. So at the end, but we get a very seamless experience for our clients. Same for iOS. You put a pod and you get if you could see the usage example, it's a view controller, and you can use our view controller and initialize the meeting there. Again, very simple, very Android iOS like. You wouldn't even know if it's an React Native SDK. So step 2 is complete, and we have our Android and iOS SDKs. We also have React Native SDK. Now the third step is very interesting. our clients might be using Flutter apps. And so how do we ship a SDK that was built in React Native to someone using Flutter? And we basically do a wrapper on a wrapper. So the inner box is our Android and iOS wrappers. And so if you are aware of how Flutter, like if people here understand how Flutter works, Flutter also gives you two primitives. One is a platform view and method channels. So platform views, what they do is platform views in Flutter, they allow you to integrate native views in your own application. And method channels let you communicate with native code. It's the same thing as native modules, how in React Native world, they let you communicate with the native code. Similarly, in Flutter's world, method channels let you communicate with. So every time there's an event that originates in the React Native SDK, we call a React method, send it to the outer layer. This basically updates a shared instance or causes like a local broadcast, and then using method channels sends it to the Flutter side. Again, I know what you're thinking. Yeah, for why do this? Why do this at all? At the same time, this is also like very cool. How do you manage to do this? Couple of memes here. So how does it look to an end user who's installing our Flutter SDK? You put a diet widget and you call the room name or token, and that's it. The client, it's so seamlessly packaged that you get like a very Flutter-like experience integrating a React Native SDK. Again, I would like to reiterate the constraints that I originally said in the beginning of the talk as to why did we do this. We had like an engineering team of 7 people, could not manage to build 4 different SDKs. So yeah, here it is how we've developed 4 different SDKs and used just one common code base. So what were our learnings from this? Why would I not do this again if I was asked to? First of all, being a audio video SDK provider, we had a very coupled UI because of course your clients are using it in Flutter, and while your UI is written in React Native, of course there is going to be no customization. So no customization. And second, performance issues. So while there were no performance issues in like the iOS and the Android wrappers, of course there was some, like how React Native performance versus native performance, that's another debate. But because our meeting UI specifically, there was not a lot of movement or interactivity. It's just that you get video streams and you speak and you listen to audio. So not a lot of, no, in fact, not even not a lot of, but no significant performance impact in our core audio video experience using the Android iOS wrappers. In Flutter specifically, there was some performance impact, especially like less than Android 10. If I'm just like quoting a doc from the official Flutter docs, quoting a. So if you could read this, while a platform view is rendered with hybrid composition, the Flutter UI is composed on the platform thread. So you're basically, it doesn't run on the same thread and slows down the entire UI. It's not actually bad, but some performance degradation is visible. The third thing is, of course, the SDK size. And because now you're technically including React native code, like the native libraries. And those libraries are written in, basically they are compiled per architecture. So you'll have 4 sets of libraries. So every time we give out a Flutter SDK, it basically adds a 56 MB to client's production build. And most of it is React Native. So React Native, as far as I remember, takes like about 8 MB per architecture. So and the rest of it is the actual WebRTC builds. So libWebRTC, the client, the client library handling the WebRTC part of it, which is used by like every single video calling application, adds another 5-6 MB. But which even if you had a native SDK, you would have. But here you are including those native React Native and JSC core libraries, uh, and that is increasing the production size. But because these are per architecture, the customer actually just sees a 15 MB increase on Play Store, which, while if you want to reduce, is not the worst thing in the world. But because all of these are per architecture, the client sees a 50-60 MB build, and basically it's not a pretty sight seeing installing an SDK and it increasing 60 MB to your client's app. So yeah, would not do this again. But at the same time, the whole experience made us understand React Native, Flutter, from depth to depths like we would not usually be exposed to. So from a learning point of view, it was good. And again, reiterating the constraints we had, this was the best possible way. So how are we with the problems that I mentioned? We basically, in like the later stages of a rewrite, we are releasing 100% native SDKs next month, and these SDKs, at least the non-UI part of it, is written in Kotlin multi-platform. Another very interesting technology. So yeah, and of course now we want UI customization as well. So we are releasing UI kit for React Native, Flutter, Android, and iOS. Releasing next month. Reach out us for a beta, and yeah. Also, we are hiring across all positions, specifically React Native. You'll not work on this monstrosity. You'll work on the newer SDKs. So please apply if you're interested. Questions? We'll take it in another time.
Palash will take the questions in sessions tab. I think he forgot that it won't happen on chat. Anyways, like really great talk, Palash. I think like this was a good example that like constraints bring creativity. You had the constraint of less team members, and like you came up with such good solutions. Now we'll go on a short tea break. So I encourage you all that you can just go and like stretch a bit, grab your tea, coffee, or whatever you drink. And meanwhile, you can like also visit expos, and we'll meet back in 20 minutes. So yeah, looking forward to the next half of the conference.
Hello, everyone. Welcome back. We are almost nearing towards the end of our conference. So, this is probably the last section of our conference. Uh, both bittersweet feeling, don't want to let it go, but still want to give it an end. So, let's get started. I hope you had your share of tea, coffee, food, whatever, and you're all set to the rest of the talks and panel discussions lined up for you. So let's just quickly start with a lightning talk after this small break. So we have Parth Mahajan, lead front-end engineer at Tata 1MG, who will talk about native-like experience with React WebView. So over to you, Parth. The stage is all yours.
Hello, everyone. Tanisha, can you hear me? Am I audible? Cool. Great.
Yes, you're audible.
So, hi, everyone. This is Parth Mahajan. I hope you guys are doing great and enjoying React Day Bangalore. So, about me, I am leading front-end engineering at Tata 1MG. Right. So, today I'm going to talk about reactive web views and how we can actually achieve native-like performance with reactive web views. So in this talk, we are going to discuss and rethink the mobile view. So now coming to what reactive web views are exactly. So reactive web views are something which we have been working upon, right? It's a library which is powering our internal web views and is responsible for the amazing performance that currently we are getting on our web views, right? I'm assuming for this talk that most of the people must be aware with the web views. But if I were to explain the web views in a single line, so I would say that web views are nothing but you are opening your web page inside your native application, be it Android or iOS. Right? So with that understanding ahead, we'll need to understand the current scenario and the current demand as well. So currently, companies just not only need a fast running and intuitive application, but at the same time, they need an application which is ubiquitous across all the platforms, be it Android, iOS, mobile web, etc. Right? Now the issue with this is whenever we need multiple platform-based applications, then the cost of development goes high, right? Because we need domain specific teams, domain level engineers to do that, right? So we need a solution which is inexpensive. At the same time, there is a great growth of aggregators. So aggregator platforms or applications like Tata New, wherein we have multiple brands under a single umbrella. For example, we have Tata 1MG, Chroma, Big Basket, so on and so forth. At the same time, we have applications which have multiple verticals. For example, we have Swiggy with its Instamart or Genie, or we have Tata 1MG with diagnostics, health records, e-consults, pharmacies, so on and so forth. Right. So all these aggregator platforms or multi-vertical applications need a solution wherein they can collaborate easily, as well as they can ship their features quicker across multiple platforms. So what if I tell you that there can be a solution which not only caters to all these needs, but at the same time is really very easy for the development as well. It takes almost negligible time to move your current existing web page onto a WebView compatible screen, and it can be easily shipped across all the platforms. At Tata 1MG, we have been working upon a solution which completely delivers all these requirements, at the same time is performant and gives a very seamless experience to the users. But before we hop on to the exact solution and what exactly we have done with the reactive web views, there are certain myths which I would like to burst around the web views, right? So in general, web views, historically have a very negative image related to them. It's due to their performance issues, or the kind of user experience they have to offer, or the limited features on with the web views in terms of native interactivity. But to be honest, web views have existed for a really long while now. And over the years, it have made a lot of improvements in terms of performance, in terms of the user experience as well. But having said that, you can still encounter performance issues if your web also have them too, because your web views all in all can be as fast as your web performance, your web application, right? So we are glad, and luckily at Tata 1MG we have invested a lot of time in making one of the fastest e-commerce out there, and I think it's the right time to leverage it out in the form of web views. Now, we also need to understand why web views. In an era where we have so many different frameworks coming up and offering different hybrid solutions around it. For example, you have WebView based frameworks like Cordova, Ionic, PhoneGap, and many more like that. At the same time, you have something like React Native, or you have Flutter, which offers near to native performance or the native application in itself. But why web views? So the reason is that when you are using all these frameworks, you miss on to some really exciting features with which only WebView, the native API, which OEMs provide, has to offer. For example, one really very important feature which I think companies require at this time is OTA updates, which is over-the-air updates. For example, imagine a scenario wherein you have developed one application, you are shipping your product. Generally, the release cycles of native applications, if there are any native developers listening to this talk, I think they can understand this pain, that the native release cycles are generally, tedious, right, and takes a lot of time. It can go roughly somewhere from a month to 3 months, right? In the worst case scenario, it can take a lot of time, right? At the same time, even if your application gets approved by your App Store or Play Store, and once it's live on your native stores as well, it is not necessary that each and every user upgrades to that latest version of your application. So for example, if you wanted to send some security bug across, or send certain fixes, etc., or do minor tweaks to your product, you would have to really wait a long time. So it hinders your experimentation, it hinders your performance. So I think over the updates is one feature which WebView offers. Even if you have shipped your application across, if you want to play around with features, send across some security fixes, it's all okay. You can do that. At the same time, for the product people who might be listening to this talk, they understand the importance of doing A/B experiments in features. So if you were to do the similar thing in a native application, you will have to do multiple versions of the same product in that particular build, and with no scope of going anything wrong anywhere. At the same time, if you do that, that would increase your application size, because you are keeping multiple version of the same feature. But with web views, it's really easy to do. At the same time, if you are building multiple screens in WebView, it would definitely help you retain smaller application sizes as well, right? These are certain benefits which I do not see in any other framework out there. Even if the frameworks are really evolved, even if there are so many different frameworks to choose from, I still think the core API of which the OEMs provide works the best. And using all these things not just only saves on bandwidth for the engineers, but also save a lot of bandwidth for the product people, for the QA engineers, and at the same time helps the complete development teams. Now we are going to have a quick sneak peek at the results, what we have achieved so far, and then we'll delve into what exactly we have done. So this is a video which on the left side we have the legacy web views that we used to deal with. On the right side, it is using our latest library, which is Reactive Web Views, and you can see the performance difference by yourself. And this is the health records product of Tata 1mg. So let me just quickly start it. So as you could observe, on the left side, it is taking so much time to load, while on the right side, you didn't even realize that you were switching from a native application to a web application, and you could see all the transitions, animations. You couldn't notice any loading time, any lag, etc. So this is something that you can also do with your applications. Now coming to the hurdles. So while exploring and improving, working upon the WebView part, we definitely encountered certain hurdles we had to cross. So first of all, there is no default loading strategy or any communication channel provided by the brand OEMs. For example, there is no documentation by Apple or Google on how exactly the communication should happen between the web views and the native OEMs. Then there is no loading strategy defined by the, again, anywhere there is no strategy around the loading, how the web view should be loaded and further proceeded from there. Also, as we have just seen, that initially the web view takes a lot of time to load. If not tweaked with the loading of the web view, they take somewhere around 1 or 2 seconds. And also the user experience is not native like, unless you really work on it and create a solution around it. Also, even if, let's say, you have worked around all the scenarios, you have and you have loaded your page, you still have to deal with the time to interactivity. So even if your page is loaded, it doesn't actually mean that it will be interactive too. And that's a generic issue with the web performance. But with the help of web views and with the help of native OEMs, I think we can deal with it. And let's jump on to how we have dealt with all these performance issues. So first of all, we have created one communication channel between the web views and the native OEMs, which we call it as an event bus. So event bus is responsible for any sort of communication between any native application and your web views. And also at the same time, you have a lot of different SDKs downloaded on your web, which are generally third-party SDKs. For example, you have several analytics scripts, you have marketing scripts, GA, GTM, so on and so forth. But with the help of event bus, you do not need to load all those scripts. So this definitely improves your time to interactivity by a huge number. right? At the same time, if the SDKs of native application is dealing with all this third-party scripts because they already have them by default, so you do not need to add any weight to it. Second thing that we improved was the loading time. Instead of the native WebView API having to tell the web browser when exactly the page is loaded, we did the vice versa. Now the web application tells the native when exactly the loader can go and when exactly the web page is ready to load. And surprisingly, this also saves a lot of time. And last but not the least, we worked on the user experience and the user delight to add in transitions, animations, and then document it well so that it is really very easy for any developer to use any existing interface and start their work with. So the cost of development has gone really a low. So again, this is a comparison between a native application and the WebView. Again, this is our Tata 1MG product, right? So this is the home page, and this is the latest home that we see. And we have got some surprisingly interesting findings over here. So this is a 2G speed. We are really doing a hard benchmark over here. And as you can see, in some scenarios, WebView not just compares with the native performance, but is also able to beat it. As you can see now, the WebView is just waiting for the page to load, the native page to load, and WebView has already loaded its page. We are able to achieve this because the web performance of our web application is really good at this time. We are doing partial loading of the widgets, we are doing chunking, server-side rendering, etc. And that is resulting in the speed difference that we see here. Unlike the native where we have to load the complete page at once, on the web we get that leverage, right? Next, coming to the chunkiest part, the result summary, right? Now, the WebView is as fast as its native counterpart, if not faster. We also have improved the efficiency of the WebViews, not just by 100% or 200%, but by 400%. Earlier, it used to take somewhere around 2 seconds or more than even more than that to load the complete page, but we have brought it down to somewhere close to 500 milliseconds. Also, the time to interactive is twice as fast because we have offloaded all the third-party activities, and the development time is already negligible. Now the vision, not the right one, but the actual vision. So the vision of developing web views would be taking the web to the next level, wherein we are not just dependent upon any framework to make it cross-platform, but web in itself is capable enough to run all the UI-based screens components on several platforms, right? And what I think personally is that the WebView should, become the next sort of the thing wherein each and every customer, each and every business, no matter what the application is, the customers are able to experience and use the web views without even noticing any difference. Also, at Tata 1MG, we believe in sharing and giving back to the community. So we already have written several articles around how we have made these engineering improvements, and also we'll be coming out with new blogs and articles on the 1MG's publication on the Medium around the implementation part on how to actually implement this further on the code level, right? Also, if we get really good response, we'll be also looking forward to open sourcing our WebView library, on which we have built upon our current WebView pages. And I would really nudge you guys to go and experience it yourself. So in the end, thanks everyone. I hope this would be a lightning talk as expected, and you guys would be really motivated to try something new and have a great day. Also, please feel free to reach out to me at any of these platforms. I'll be more than happy to discuss more technologies, anything and everything around frontend. So, thank you. I'll take a leave.
Thanks, Parth. That was indeed a lightning one. Parth would be hanging around in his Q&A section, so please head towards this session if you have any questions for him. He'll be there for you to answer any questions. So, without wasting any time, let's just move on to the next speaker. We have Taj Singh, founder of Guild, who has over 2 decades of software engineer experience. Interestingly, when he's not behind his camera, he's probably found chasing his cat around the house or being chased around by cars in a racetrack. So he will be up on the stage next with his talk titled React Native Everywhere. Over to you. All the best.
Hey everyone, I guess you can hear me okay? I hope so.
Yes, we can hear you.
Awesome. Perfect, thank you so much. I just want to make sure. Well, hey everyone, I'm Taz Singh, and I'm here to talk about React Native Everywhere. And when I mean everywhere, including down here with these lovely little penguins. For those of you that don't know me, I'm the founder of Guild. It's a new platform currently in beta aimed at elevating communities around the world. Come chat with me if you're curious about the platform. And as I'm sure you might have noticed by now, my accent is certainly not from around here. That's because I'm actually from Toronto, Canada, where back in 2010, I started the Toronto JavaScript community. You see, back in those early days, I was subject to a lot of banter about JavaScript. Oh, you aren't a real developer unless you program in C++ or .NET or Java, they used to say. And I was taken aback because if you've ever built a JavaScript application before, you know how complicated and how diligent you have to be about it. Back around 2010, we were just starting to build applications using Backbone and Underscore, and you remember how complex those beasts were. So I started Toronto.js to get folks together, get them talking, and learn from each other. I thought together as a community, we're able to ask each other questions and kind of elevate our craft as a whole. So a lot of what I did back then with Toronto.js serves as my impetus for building Guild today. What I quickly discovered was that communities are everywhere. We're at a similar community here right now. In fact, a lot of my closest friends are people that I met through the community, some of whom are watching this talk at this very moment. So I packed my bags and moved to London in 2017 to explore those communities across the world. And that's also when I was introduced to React Native on every platform. Here you can see me giving a talk about that back in 2017. This tweet is from Ellie, an organizer of that event, and also a very good friend now as well. You can find that presentation posted on Guild. If you go to beta.guild.host/Taz, you can see my presentations. And if you click on that, you can actually watch the presentation itself. So feel free to go take a look. But to give you a very, very quick rundown of that talk, because it serves as the basis for this talk, basically I talk about what it takes to build using React Native to share common code for every platform. So if this is your common code for every platform, basically you can wrap that with unique code for individual platforms where just about 95% plus of your code is shared across every platform. You can push those unique aspects to the edges, and this is what makes React Native so unique and so great at accommodating every platform by enabling you to focus on common code within the middle. So all of that, like these days, is actually packaged up nicely in Expo. So the talk I gave in 2017 was doing this manually. Expo does a lot of this for you automatically these days. And even their homepage says, make any app, run it everywhere. So feel free to go take a look at the docs on their site for a much more up-to-date version on how to kind of do this today. So that's my journey to date. And so today I'm talking about part 2 of that, which is essentially responsiveness and navigation in a React Native Everywhere application. So let's start with responsiveness. It's no secret that different form factors exist. And so when building an app that works everywhere, we obviously need to take this into account. You'd expect a platform like React Native to do this well, but it really just provides the basic primitives. Critically, there's no CSS. That means that there's no media queries. That means that there's no CSS grid. That means that there's no CSS selectors at all. There's no first child, last child, nth child support. There's none of that. So styling in React Native is inspired by CSS in that they use CSS property names and they have a flexbox implementation. But CSS itself doesn't exist in React Native. And so if you've ever built a responsive web application before, you can likely start to see how challenging it is to build those same UIs without any of those web-based CSS constructs essentially that we're used to. So what do I do? Well, fortunately for me, I went to Bangalore to consult in 2017. And the organizers, well, first of all, I burned it down. But I went to Bangalore to consult in 2017. And the organizers, Kiran, got a hold of me back then and asked me if I wanted to present for the community over there. So I agreed because communities are everywhere after all. And so here I am talking about a Pontiac Aztec at React Bangalore in 2017, a truly magnificent car. I had the pleasure of getting to know the community there, and in fact, sitting next to me here is basically Siddharth, who's now one of the foremost experts in design system space, and then of course next to him is Kiran, a good friend. So basically, around the time that I was looking at the solution to solve my responsiveness problems in React Native, it was around 2020, and Siddharth came out with React UI. Where the website itself says React UI comes with a set of components that are accessible, responsive, and customizable. That sounds like exactly what I want. It also has a list of components that it ships with. Reading from the right, there's element, link, select, text, text area, and so on. And critically at the bottom, there's stack and grid to help you build a layout, like essentially composing those other building blocks essentially into them. So this sounds like exactly what I want. But it's built for web. So maybe I could take this and maybe I could create a React Native design system using this. Maybe those layout constructs would help me with my responsiveness in my React Native application. So I tried doing exactly that. And after a bunch of trial and error, I finally got something working. So I thought to message Sid. I said, hey Sid, how's it going? You enjoying Amsterdam? I wanted to reach out to say that I'm a big fan of React UI. In fact, I'm such a big fan that I ended up implementing large parts of it for my React Native application in a cross-platform manner. It's a shameless rip off of React UI, but of course, React UI is for the web, and what I've done is for React Native. Thus, no emotion, no CSS. I've had to implement stack a bit differently, and so on. Sid very kindly responded, that's really cool. React UI is a rip-off of Theme UI, rip-offs all the way down. And as the great saying goes, good artists copy, great artists steal, or something like that. So looking at the dates on these messages, you can see this was peak lockdown in 2020 that I was working on this. And so here's an example of what I worked on. This is straight production code, straight out of our Guild platform. And so the code is on the left and the rendered UI is on the right. And hopefully just by looking at the code, you can kind of determine what's going on. You can critically see that those stacks have gaps, and those stacks really compose the rest of the design system, like primitives upwards. So we have a link, we have text, and at the bottom there, we have that user item, which is displayed conditionally if we have a presenter. So taking a look at that, so I've highlighted the exact part of that UI on the right with the dotted red line. We can see on the left, it's also just another stack. And that is a horizontal stack that has a primary photo and has a link. And so fundamentally, by composing these stacks upwards, we can start to build a UI that is composable, like essentially in React Native. Okay, but what about that responsiveness that I talked about earlier? Well, here, again, straight production code out of Guild, so apologies for if it's a bit a bit messy and a bit obscure, but I wanted to show you the reality of how we build these UIs. On here, you can see a grid, and you can see columns as well. So a composition of stacks and grids and columns with the presentation card that I showed you earlier ends up building this whole UI that I'm showing you on the right. And again, you can just go to Guild and see this directly for yourself. But fundamentally, by composing stacks and grids and columns, we can start building fully responsive UIs in React Native very easily. So at this point, I was pretty happy with myself. I said, oh, I got a lovely design system here. All of Guild is built in this way. I thought I'd come up with a snazzy name for it. So I came up with the name Mondrian. This was inspired by the famous Dutch design system engineer, Piet Mondrian, who's known for composing stacks into UIs that kind of look a bit like this. So I created an empty repo on GitHub and started preparing for a public release of Mondrian. And that's when I found out about native base. So if you're familiar with native base, it's every platform design system, comparing it to Mondrian's and every platform design system. It's a bit more comprehensive than what we have. We're only at 000 alpha 3. They're at version 3.4.6 at the moment. They spent far more time on accessibility than we have. I don't even know what the accessibility for our stuff looks like. I hope it looks good, but who really knows? They have documentation when good luck trying to figure out what we have. And critically, theirs is built in Bangalore, which is the inspiration for our design system at the end of the day, meeting the community there and learning from them. So fundamentally, I would recommend if you wanted a React Native every platform design system, just go use native base. It's a lovely piece of work, and the folks that have built it have spent a lot of time thinking about it. So go check out native base. Okay, so up next, navigation, the second part of building an every platform application using React Native. So in terms of navigation, there's like two types of navigation as I see it. There's mobile and desktop navigation, where you basically use the UI to kind of navigate around. You tap on a button, you tap on on some sort of UI component, and that's what navigates you onwards. Then there's web-based navigation, where, yeah, you can interact with the UI, but there's also a back button, there's a forward button, there's a refresh button, there's a URL bar, there's tabs, there's a whole browser that kind of surrounds the actual UI that you can interact with. So all these web-based controls don't really exist on mobile and desktop. There's a few exceptions, but for the most part, that's the difference. And critically, there's one UI pattern that I want to focus on. So it's taken here from the Instagram website. This is the Instagram of my cat, Janeway. Isn't she adorable? And so here you can see by clicking on an image of her, it opens in a modal. And that modal opens up because it knows what to place in the background. That modal has a URL essentially in the URL bar, and I can open a new tab, paste that in, and then the image opens as a full page because it doesn't quite know what to put in the background because it's a brand new page. You can land there from anywhere. This type of navigational pattern doesn't really exist on mobile and desktop, but it of course does exist on web. So in building a truly 95+% application shared across every platform, we need to account for differences like this, and our navigational paradigm needs to be able to accommodate it. So how do we do that? Well, there's React Router. And so I'm sure a lot of you are familiar with React Router. They have a React Router native package on there. And critically, what they do really well is state management. Like the back and forward, the refresh, landing on a new page, all of that stuff works really, really well because it's really tailored, essentially for web. The part that I found it doesn't have is that native feel, when you can swipe from the side of a screen essentially on a native mobile app, and it will go back, the animations and all of that. It doesn't have any of that, so it's great for state management, not so good for the native feel. Then we have React Navigation that actually launched web support relatively recently. So they do support web, and they do have a native feeling, implementation as well. They have that kind of slide from the edge of the screen. All of that stuff works. However, in practice, when using this on the web, I found it was quite quirky and quite janky. I found that if you're code splitting your bundle and you're asynchronously loading in pages as you navigate, the URL also asynchronously, essentially resolves as those pages are loaded in, which is a bit odd. Essentially, if you're used to using the web, you're used to just the URL being the URL. You're not used to the URL kind of rewriting itself as asynchronous chunks load. That's a weird UX. I also found that going back and forth frequently would kind of put React navigation into some sort of weird state that it just couldn't recover from. And the user would have to hard refresh and then get that asynchronous resolution of the URL again. So I found it to be just a bit odd. So basically, if we were to look at the two, React Router, again, has excellent state management. React Navigation, it kind of works, but it's kind of janky on web. On native, it's like I find it's pretty good because you don't have that back and forth button. So I find on native, it's actually pretty good. React Router doesn't feel native, while React Navigation feels actually very good on native. And so for these two solutions, React Router and React Navigation, if we were to choose one, because again, we want 95% plus code sharing on every platform, the one I'd probably pick is React Navigation. So that's the one that we went with. And despite its flaws, the UX won't be ideal. The users will just have to live with it because that's the best we have. And I'm sure the team over working at React Navigation is working really hard on it, and I'm sure they'll resolve these issues in time, and we'll just upgrade essentially as they release these features, and then our users can benefit at that time. And so, yeah, that's the current state of every platform navigation. Thanks so much for your time. No, I'm just kidding. Like, that would be a terrible way to end a talk. Are you kidding me? Like, there's no real solution there. What? Like, we can do better than that. Come on. I think I fooled some of you, though. So if you've learned anything by now, you'd know that I solve all of my problems with incessant complaining to folks in the community. So this time I was complaining about essentially every platform navigation to my good friend Lorenzo, pictured here in the only picture that I have with him, taken at my friend Phil and Cindy's wedding. So Lorenzo is a former maintainer of React Navigation and is heavily involved with React Native community efforts. Oftentimes when I don't know of a good way to proceed in the React Native space, I go and look for him for guidance, as he tends to know a lot of the community happenings before others do. And this time, he really came through. He told me about this library called React Native URL Router. That sounds like exactly what I want. I want a React Native router that uses URLs to route. And so I took a look at the documentation, and if you can see the code on the left, it's actually pulling in React Router to handle all the state management, but they have the React Native screens, which allows you to have that native feel of like sliding back and forth from the side of the screen, and everything feels native. So it has the best of both worlds. If you look at the definition there in the code, it's a native router with a stack navigator and a bunch of routes inside of it. If you're used to using React Router, it's basically a browser router with a routes component and then routes inside of that. It's very similar to things that we're used to essentially in the React world. So this looked amazing. I went to go try it, and unfortunately, it just didn't work on web. It's actually built for mobile. It just didn't work on web. So I thought, well, this looks really good. It looks like it can just work on web. It looks like it should be easily adapted. So I thought to get in touch with the maintainer, Alec, from Software Mansion, and just message him to see if he has any thoughts on how it could work on web so that we can actually start working on this thing together. He was very kind. He responded quickly, and we actually set up a call shortly thereafter. And what I received in that call really surprised me. So I was expecting just myself and Alec to sit down and just to talk about, how to make that like essentially the future of web compatibility for React Native URL Router. But then Christoph joined, the director of engineering at Software Mansion. And at this point, I'm thinking like, oh my goodness, this is going to be one of those like sales consultancy calls where like the director of engineering says, well, Taz, we're a consultancy. And if you want some help in this space, you can always just hire our consultancy to help you. And I'm like, oh my goodness, I don't want to deal with this right now. I just want a library that works. But instead, my expectation was completely wrong. Instead, they were so kind and so willing to help that I don't think I've seen this type of support from anywhere else. Essentially what Software Mansion wanted was they wanted a production level application that will use React Native URL Router so that they can test out all the paradigms and make sure it has good support. And what we wanted at Guild was we wanted a fantastic navigational experience such that we can effectively develop and ship to every platform. And so it was really just a really good match. We said like essentially in the call that, hey, doesn't it make sense to partner up? And doesn't it make sense to work on this thing together? We'll be the guinea pig for the new library, and together we can work on shipping something great. Really, Christoph joined the call because he was more curious about Guild as a platform and how it could actually help with Software Mansion's community efforts. And in fact, I'm actually sitting in the Software Mansion office right now because I'm attending App.js Conf at this very moment today and tomorrow, which is, again, one of their community efforts. So I can only speak of Software Mansion in the highest and thank them so much for accommodating me here. So after that talk, I basically went forward and started to rewrite the entire application using React Router as a stepping stone to start using React Native URL Router. You can see the stats of that PR here, where I've deleted more than double the code essentially than I added. The overall app feels so much snappier now. It feels lightweight. It feels like I removed a lot of code. And so I have to ask you, did you even notice? Essentially, if you went to the Guild website or if you've used Guild in the past, did you notice that it's using an experimental homegrown design system? Did you notice that it's using an experimental not yet ready router as well? Did you even notice any of this, or did you just think it's an ordinary web application built in ordinary ways and just works as a web application should? And that's really the beauty of React Native fundamentally, is being able to write common code that essentially for every platform and push the uniqueness out to the boundaries where you're still accommodating the unique aspects of every single platform as well. But fundamentally, that's not the point of my talk. That's not the main takeaway. I'm fortunate and privileged through this journey to have met the people that I've met through the community. Without them and without their support, I would be nowhere at all. And it's not like I'm special. I really just go to events and I talk to people and I learn from them and I introduce them to the people around me. That's exactly why I started Toronto.js back in 2010, and that's exactly why I'm working on Guild now, because we're only as good as a community around us. At the end of the day, communities are everywhere, and now your technology is too. Thank you very much.
Thanks, Taz. That was one hell of an interesting talk. I had my eyes glued on to the screen throughout. And I would really love to go and start Mondrian after that, just as a testament that I attended this one. So really glad. And I think that quote, "We are as good as the communities everywhere," that's just stuck by all of us. So thank you so much for this one. Taz will be hanging around in the session, so you can go back and have any questions for him. So moving on, let's get to the next one, which will probably be the last talk of the day, and then we'll have the panel discussion. So next up, we have Nivedita Singh, mobile engineering intern at Small Case, with her talk React Native ALMY Basics on accessibility fundamentals in React Native. Personally, I've been following the accessibility space very closely, so I'm very excited for it. So all the best, Nivedita, rooting for you.
Okay. Hi everyone. I hope you can see my screen. Right. So I am Nivedita, a mobile engineer intern at Small Case. I work on the cross-platform app and the website. Today I'm going to share with you all what we as a team have learned about accessibility and its implementation in the past few months. This talk will be about the basics of accessibility. Why even care about accessibility? Why waste precious dev hours on accessibility? Some guidelines that were set up by the Web Content Accessibility Guidelines Group to fix accessibility, and how Android and iOS natively support devs to make their apps accessible, and of course React Native. Certain problems that you may face in implementing Ally for your mobile apps, and then of course a brief discussion about Ally tool. So let's get started. What is Ally or A11Y? What's the whole buzz about? Ally is accessibility. It's how usable a website, app, or digital experience is to all users, irrespective of their ability or disability. Why should you care? If you're not disabled, you can let it be, right? No. Over 1 billion people in the world are disabled. People with disabilities have a higher chance of unemployment, and everyone is likely to be disabled at some point in their lives. Some countries legally require websites to be accessible, which is unfortunately not the case for India right now. So if you think about disability, maybe just visual impairment comes to your mind, but there are actually 4 types of disabilities. You have visual impairment that can be due to blindness, low level vision, or color blindness. Such people use screen magnifiers or use their software zoom capabilities to access content. Then you have people who are hearing impaired. They could be deaf or hard of hearing with various levels of hearing loss ranging from mild to profound. Then you could have people with mobility impairments. They will have problems related to movement due to physical or neurological disorders. For them, their mobile devices would be attached to their wheelchairs, let's say, and they would not be able to access the other half of the mobile device, maybe even only from the left-hand side, for example. Then you have cognitive impairment, people with intellectual disabilities or old age. We're all going to grow old. They'll have difficulty in thinking and remembering. So let's talk about an example of how people with disabilities perceive the world and how the world is hindering them. So Wordle is a word game that we play where you have to guess a 5-letter word and you get some clues along the way. So during the lockdown, all of us played it and shared it on our social media like Twitter. It was annoying for those people who access their phones using screen readers, not because they're snobs, but because of the following reason. I will now play a clip of how a screen reader reads out Wordle results on Twitter.
Comma, 3 green square, white large square, white large square, new line, 3 green square, white large square, white large square, new line, 3 green square, white large square, yellow square, new line, 5 green square. This is my latest Wordle.
So as you can see, that part was screen reader users would hear a long indecipherable list of yellow, green, white squares, and they would have no context as to what exactly they're reading. It's inaccessible and confusing. So a dev called Josh Wardle developed a tool called wally.co where you can paste your Wordle results and generate descriptive alt text that lays down all the context of what exactly you're sharing to your social media. This is how it reads.
A grid of colored squares representing letters, which is 5 across and 4 down. The first and second rows both show 3 green and 2 gray squares. The green represents a letter that's in the word and in the right place. Gray represents a letter that's not in the word. The third row shows 3 green squares, 1 gray square and 1 yellow square. The yellow represents a letter that's in the word but in the wrong place. The fourth row shows 5 green squares, which means all the letters are in the right place to make up the word.
Right. So as you can see, the second part of the example gave a lot of context and was easily accessible to someone accessing their content using a screen reader.
Comma.
Right. So why do you need to make your apps accessible? You might be actively discriminating against people who cannot access your app if it doesn't work for them. The social model of disability says that people are disabled by barriers of society, not by their disability themselves. Like, for example, if I need a wheelchair to access a certain building, I am hampered not by the fact that I need the wheelchair, but because the building itself is not accessible to people using a ramp. Also, making your apps accessible can have serious business use cases. People who need to order food through your apps, it'll help them in their lives. And making your apps inaccessible is like using the color throughout your app. When you know some part of your users can't see the color yellow, let's say, can't perceive it. This meme, for example, itself is inaccessible. Just like the Wordle example, where you should paste a descriptive information about your Wordle result, you should also add captions to your videos and images that you upload on LinkedIn and Twitter, let's say. I'll read out the meme. So here Anakin is saying that I've added subtitles to make my content accessible. Padme is saying, but not automatically generated ones, right? So he's looking at her like that, and then she spouts some nonsense, which comes out when the captions are automatically generated. Right. So how do you go about making your apps accessible? Are you supposed to wing it? No. You have something called the Web Content Accessibility Guidelines. They were set up by someone called the World Wide Web Consortium, W3C. They organized all the accessibility rules under 4 principles. Major things that your web app content must be to be considered inaccessible. For each guideline, there are testable, successful criteria, like success criteria at that level. So you have 3 levels which get progressively stricter. For example, for level A, you wouldn't want content in your application to be recognizable only by color. Like you wouldn't want 2 buttons, green and red, and let the users assume that green would mean it's something positive and the red means it's something negative. Level AA would mean text color should meet some particular contrast requirements so that they can be read easily. And level AAA, which is the hardest to follow, is some very dark color on a very light background. So what are these 4 principles that the W3C guidelines are divided under? Your content should be perceivable. Small screen sizes. Wait one sec. Right. Small screen sizes limit the information people can view at a time. So if they have to magnify the screen and see it, they would have to continuously scroll in order to perceive it. So how do we fix that? We provide a reasonable default size for content and touch control so that the users don't have to continue to zoom in and out. You position the form fields below their labels so that instead of like beside their labels, so that similarly the users don't have to scroll horizontally in order to access it. And your app should allow magnification up to by 200%. And there should be some minimum level AA contrast requirement of 4.5:1. Your content should be operable, not just by users who use it through the touch screen itself, also by users who use it through external keyboards. The touch target size and spacing. So touch target should be at least 9x9 mm, and there should be some inactive space around so that they don't click on it by mistake. Touch screen gestures should indicate what happens when you set upon that gesture. And even if you have some fancy device manipulation gestures, you should still give an alternative for people who use your phone using keyboards, let's say. And buttons should be placed in an accessible manner so that they can be used in whichever manner the device is held in. The third principle would be what your content must be understandable. Your screen reader should detect when the orientation changes, like your content's orientation changes, and your screen should support both orientations. Like going back to the previous example where a person with mobility, their mobile device would be attached to their wheelchair, so they would not be able to change its orientation again. Your layout should be consistent. Any navigational mechanisms that are repeated on multiple pages should appear in the same order throughout. Any components that have the same functionality should work the same way everywhere. Like 2 buttons should have the same, with identical functionality, should have the same text. You provide clear information that elements are actionable. They should have some conventional shape, size, positioning. You provide instructions for custom touchscreen and manipulation gestures. Like if you have tooltips or overlays, you should be able to explain to the user what gesture can be used to control it. The final principle would be your apps should be robust. You should set the virtual keyboard to the type of data entry required. This is a no-brainer. Then you provide easy methods for data entry. So text entry can be tedious even for people who are not disabled. So you should provide more radio buttons and cute little checkboxes if possible. And you should support the characteristic properties of the platform. So if your platform allows the users to zoom out, the text should be wrapped and they shouldn't have to scroll horizontally to get that information. So now that we've discussed all those 4 principles, it might seem a little overwhelming to you. God knows it did to me. And for people who are only listening to the talk, this is Jake Verda saying cool, 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 very anxiously. Right. So now we're going to discuss how we can implement Ally on our mobile apps. There are 3 simple things that you can look at when you want to implement accessibility on your Android, iOS, and React Native apps. You design well-defined, clear task flows with minimal navigation steps, especially for major user tasks, and make sure those tasks are navigable by a focus control, external keyboard. You label user interface components that do not have any clear indication of what happens when you interact with them. And you should make sure users can navigate with using using external keyboards and such, or a switch. So natively on Android, this is an example of how you can set Android content description to describe a particular UI element. Similarly, you can set something called screen reader focusable attribute to true for a particular view, so that all of its inner objects the focusable attribute of all its inner objects to false, so that when screen reader goes through this particular view, all the inner objects can be collected together and screen reader would read out all the properties one by one, and users won't have to separately focus on them. Natively, iOS has a comprehensive set of methods provided to the NS object, which is the root class of most Objective-C class hierarchies, and from which the subclasses inherit a basic system to the runtime system. So what does UI accessibility provide? It's a set of methods that provide accessibility information about views and controls in an app's interface. UI accessibility container is used by view subclasses to make the subcomponents accessible as separate elements. UI accessibility action would be a set of methods that tell accessibility elements, these are the specific actions that we support. And UI accessibility focus would determine whether VoiceOver has focus currently on a particular element. So now we come to implementing Ally on React Native. Both, as we just discussed, both Android and iOS provide APIs for integrating apps with assistive tech like screen reader or VoiceOver. React Native has a complementary set of APIs that lets your app accommodate all users. So what are these? First of all, we have something called accessible, which takes a Boolean value. When true, this indicates that the view is an accessibility element, which means that all of its children are grouped together into a single selectable component, and the user won't have to individually focus on each of its children to get the accessibility label. Let's say all touchable elements are accessible by default. Then you have something called accessible role, accessibility role. It communicates the purpose of an element, whether the element is a button, a link, a header. Here, for example, setting the accessibility role heading is useful for navigation throughout the app. The user can go through all the headings in a particular screen and find out where they are, figure out stuff. Then you have something called the accessibility label. It provides a sense of purpose to the current element. So how is it different from role? Role would refer to a button, while label would refer to, let's say, saying that tap on this button to watchlist this particular item. What is accessibility state? It's the current state of a component. The current state can be disabled, selected, expanded, right. And then you have something called accessibility hint. Here you would give a hint to the user how things will turn out if they actually go ahead and click on a particular button. It can tell them that clicking on this particular button will redirect them to the mobile browser instead of opening a new view in the same app. Here's an example of the difference between role and label. You have a button, clicking on it will submit code, and it's currently disabled. Here, had we had, like, instead of submit code, had we had some generic text, like let's say click me or button, you would have had to add a label here to tell users that clicking on this particular button will lead them to submit code. But since that text is already descriptive, we wouldn't need to add extra things. These are the other properties available. Some are a few of them are specific to Android and few are specific to iOS. Here, for example, accessibility live region is a good way on Android to make announcements. When this property is set to true, any changes to this view will be announced automatically. And here you have a property called polite, which means that the current announcement, like this particular announcement, is not going to interrupt whatever screen reader was saying at that particular moment. So now I would like to talk about examples of a few ally problems that a person can face when they're making apps or websites. So this is a tweet someone sent this out recently, that if you put in too many ARIA attributes in your HTML, is that accessibility? This refers to the problem of too much versus too less. Can your application be too accessible? You don't want to go ahead and label everything, right? You don't want to create unnecessary noise when a user goes through your app using a screen reader. At the same time, you don't want to leave out on the important stuff. You don't want to give them radio silence. So adding on to that, let's say you have a text as an image, where if this particular image was a header of a particular carousel on the small case app, referring to small case specials. Since this was an image, it was not accessible to users at all. They had no idea what was up. Both these examples refer to making images accessible. First one being where it's an informative image. The second one being where an image is used as a button, an icon used as a button. Here, voiceover would read out just funds and 10 crore, not telling the user about the icon button, the button there, right? Okay. And then next, we have something called a small case card. This can be about any card displaying information about a particular object. Here, it happens to be a small case. You have a name, a label, you have a name, description, a watch list icon, and the whole card is clickable. Clicking on this particular card will lead the users to the small case profile screen. Let's say we add a label, accessibility label, to this particular watch list icon. VoiceOver is going to read out what's available, visible on the screen. Like it's going to read out all the information, and then it'll say tap to watch list. This information is misleading because tapping on this card is not going to lead them to watch list small case. It's going to lead them to the profile screen. So why did this happen? This happened because touchable elements have accessible true by default, and because of that, all the elements were gathered together into one single focusable element. So it's not possible for us to individually focus on the watch list and tell users, hey, you can click on this instead to watch list. So how do you go about fixing this? First, you can just go ahead and set in accessible to false for this particular card. That will not be the right way to fix this situation. Instead, you should set the header, like only set the header to be clickable. This refers to a particular problem people even face in web accessibility of nested interactive elements, where interactive controls must not have focusable descendants. The next problem would be about discussing accessibility focus order in React Native. Let's say you have a card where information has been divided into two columns. You would want screen reader to read it out like this: stats, slot, head, armor 5, encumbrance 1. But what actually happens is screen reader, particularly on iOS, will read it like stats, when equipped, slot, head, efficiency, armor 5, completely messing up the order. So why does that happen? On the web, screen readers determine the flow in which things are read by looking at the DOM tree, and they go from top to bottom. But you don't have a similar structure on mobile apps. iOS reads elements from left to right, top to bottom. Like it'll read this particular column like 1, 3, 2, 4, which will not work for us in this particular case. To fix this, you can use natively on iOS. You can use should group accessibility children, where 1 and 2 will be grouped together and read out in one way. And a React Native doesn't have a way to fix this. So a quick hack would be to create a wrapper that allows you to adjust the behavior of the native platform and group all the subviews together for accessibility purposes. So now that we've discussed tools, now that we've discussed particular problems in React in implementing accessibility on React Native, I think we can also discuss on how once you've made your accessible, you can go ahead and test it for accessibility. So what are these tools? On the iOS simulator, you have the accessibility inspector, where you can click on the crosshair icon. And first of all, you need to choose the particular app you want to run it on. It has to be your simulator, or else you'll consider your simulator as a desktop app and treat it differently. You can click on the crosshair icon and then inspect a particular element on your app to find out more details like label, value, trait. And you can also get all the actions that can be performed for this particular component. Since you cannot use a voiceover, like iOS simulator does not have an inbuilt voiceover, you can only test voiceover on your physical devices. So here are a few voiceover gestures that you can try out on your iPhones. For Android, you have the accessibility scanner. It's an automated tool which can record workflows, take screenshots of screens, and then audit them for accessibility issues, and propose solutions based on the following: whether the content has labels, whether the touch target size is large enough, whether the items are clickable, and there is some contrast in the text. Here is the image of after we run the accessibility scanner on one screen of the small case app. It goes ahead and audits that particular screen, pointing to us that the item label does not exist for this particular icon and the touch target size is not big enough. Similarly, for physical devices, you have the screen reader called TalkBack. I think you should try it out on your phones and then find out how these gestures work. So I would now like to touch upon how these are like the importance of manual testing in accessibility testing, because these tools may tell you that a particular label does not exist, but they won't be able to tell you whether the particular label makes sense. And similarly, if all you carry out on your apps is manual testing, you may miss out a few edge cases. More so if you're not disabled and you test the app. So in that case, you need to find a healthy mix of manual and automated testing. Here was the end. This is the end of my presentation. Hope you could understand what I was saying. Thank you.
Thanks, Nivedita. That was one amazing talk. Always excited for any accessibility talks that I come across in conferences. With that, that was our probably last talk of the conference. Up next, we have a panel discussion on React Native. And with that, we will conclude this. But it's still left, it's still there. So we'll be having the panel discussion. This panel discussion will be on React Native. Let me just take the moment to introduce the moderator of the panel discussion, who will take forward the panelists. So I want to introduce Ananthu, who works as a software engineer at Smallcase, primarily handles the React Native app. He also loves contributing to open source JavaScript projects like the React Native YouTube iframe package. So over to you, and I hope you enjoy this awesome panel discussion.
Hey, thanks for that intro, Tanisha. Think we'll have to we're waiting for the members to join in. Yep, I think we're all here. Hi guys.
Hey.
So
Hi, Ananthu, how are you doing?
hi everybody. We'll be talking about React Native and topics related to React Native in general. So I think we can start off with introductions. Uh, Peter, can we start with you?
Yeah, sure. Hi everyone, I'm Peter Lasser. I work as a founding engineer at Savage.club, and I primarily basically lead the mobile team here. And you know, I've been working with React Native for around like 4 or 5 years now. Um, yeah, that's pretty much it.
Great. And how do you use React Native like on a day-to-day basis? Like,
So our primary product is a mobile app targeting both Android and iOS, and then that's where I primarily use React Native. We have a web presence, but it's mostly uh, just a small React app right now. Kind of looking into how to move most of our React Native code into the React web app.
great. Muslim, next.
Hey, hi everyone. Thanks, Ananthu. So, hi, my name is Maskeen. I have been working with React Native for about the last 6 years, ever since React Native first came out. I currently work in Microsoft where I don't get a lot of React Native exposure, but I've played with React Native for the last 6 years while I was at Flipkart, and I still do keep working on React Native as a part of my side projects and hobby projects and keep doing development on the side. On a day-to-day basis, I try to keep up with the advancements that are happening in the world, new libraries that are coming up, and seeing what advancements are happening everywhere, like what people like Nishan and Ananthu and Peter are doing with React Native these days. So that's kind of what I do on a daily basis with React Native. Thank you.
Great. Nishan?
Yeah, so my name is Nishan. I'm working at Showtime. So we are working on a like single code base that runs on like Android, iOS, and web. And yeah, currently I'm working on a UI library there that's like called Universal UI. And yeah, and we are sharing code like across all the platforms. And in my like, free time, I love to dig into open source libraries around React Native and also React Native Code.
Great. So you mentioned code sharing, right? So what do you use Expo in your company?
Yeah, so we are actually using Expo and all of its latest features. So Expo has improved like exponentially in the past year, and so yeah, we are using Expo like extensively. Like I mean, yeah, on like Android apps.
I'm guessing that's
Right,
what
right.
the short form for exponentially would be. It's Expo.
Yeah.
Right.
Yeah, it stands for exponent. They used to be called exponent for a while.
Nice.
Then they
Right.
kind of shortened to expo.
Nice.
Yeah.
Right. So what are your guys' thoughts on like using Expo versus using like a bare React Native project?
Yeah, should I go first?
Yeah, Mushan.
Uh, yeah, so I mean, Expo. So when Expo was released, there were some like limitations that if you want to add like new dependency or new native dependencies, then you had to like eject out of Expo, and after that you won't be like yeah. After that, upgrading Expo that would be like a bit difficult. But like with recent release, I don't think that's like a lot of difference with like bare React Native and new Expo because you can essentially eject while like staying under still under Expo using like new updates like Expo Dev Client. So that is just like a bare React Native app, and yeah, you can add like all of your native code. You can add your own library, like yeah, without losing all the Expo updates or Expo future updates.
Right.
Right.
One thing I
And
would like
yeah.
to add to that is like when you use Expo, right? The problem of adding new packages becomes very trivial, right? So let's say you have to add something like React Native Maps. You go into Gradle for which has both native dependencies on iOS and Android as well as JavaScript. You end up going into three different places, making sure the integration is fine at a bare bone level, and then start working on it. Like that's easily like a couple of days, 3 days worth of effort, but Expo, you just add a project and it just works seamlessly out of the box in all platforms. So that reduces the problem by a lot of margins, right? So that's one crazy thing that Expo gives to developers. That's been my experience, more or less.
Yeah, and recently Expo has become much more modular. So even if you're not bought into the full Expo ecosystem, you can still use certain packages,
Right.
uh, and then you can be most like fully certain that those are going to be maintained in the future too. So, for example, we use Expo AV for our video and audio playback capabilities rather than something like React Native Video. I don't know if you guys follow React Native Video because it's kind of been deprecated and kind of
Right.
stagnating for a while. Whereas something like Expo AV has had frequent updates, bug fixes, uh, and almost all their packages are like top quality. So even if you don't want to fully buy into the Expo ecosystem, you still can get take leverage a lot of the modules themselves.
Yeah. Yeah.
Of course, yeah, Expo has contributed a lot back to React Native as well, like in terms of community packages, in terms of ease of development, and also I think they've contributed a lot of code onto the upstream React Native project as well. And I think until recently they were maintaining a fork of React Native, but then recently they have moved back to just maintaining the public React Native listing. So it hints towards like a more stable uh, release of React Native. So yeah, I think Expo has contributed a lot. And Nishan, are you guys using like the cross-platform abilities of Expo by any chance, like web or desktop apps?
So yeah, I mean, currently we are using a regular Next.js app, and yeah, and not like the Expo one. So Expo has like few plugins that we can include in your Next.js app, and that will like so basically those plugins include some configs that are required for React Native Web uh, to work like without like without adding like manually all those configs, because those are like a bit hard to configure like manually, like you have to go into webpack and add some certain configs. So all that is provided by like simple like Expo Next plugin, I think that's what it's called.
Right.
So yeah, we are using that, and yeah, but it's a like plain Next.js application, and but yeah, we are using that plugin, so that handles all the like bundle complexities for us.
Nice. And Peter, Thomaston, like do you guys use any of the other Expo things that come with it?
No, unfortunately, I've not played around with Expo Web. But I guess there is a couple of libraries which makes navigation work well with Expo Web and React Native. I think uh, the name slips my mind right now. Nand Nando Rojas is working on
It's Solito.
yeah, Solito, which is a router that will kind of abstract out the routing logic for your React Native and web apps. So there's some interesting stuff happening in that space.
Right.
Looking forward to it, with- because for us at least, uh, it looks like there's a lot of the code that we write for a React Native app can be like fully shared for the web, and
Yeah.
solving routing would be routing animations etc would be like a good step forward for that.
Yeah. One more thing with Expo that comes out of the box, I mean, it's always it's already priced, but the EAS feature that they came out with, right? Let's say you have to publish your app to an app store or the Play Store, right? You have to go through different licensing, different everything, and different times for reviews and different publishing times as well, right? So all of that gets abstracted out at the EAS level, where they push out updates to the Play Store within a day, within minutes, right? And that from their own console, right, from their own CLI as well. So that is something that is, I mean, abstracts out again the systems that you would have to care about if you're developing two different platforms using one single code base, and that is one interesting thing that Expo came out with. And like we were discussing about Expo being used so very often in all of these scenarios and well tested. I think there's another pain point that we can touch upon when using Expo is how easy it makes React Native upgrades, right? I was talking to Nishan in the afternoon how easy React Native upgrades can become with Expo, right? So that is also something that we can talk about right now.
Yeah. So anyone has any upgrade stories? React Native upgrade?
3 weeks we
I think,
upgraded from, I think 30 to 49, so 19 versions at once, and it took us like a month with no surety that it's going to go well. So that was extremely crazy. But over to you guys. I mean, you guys must have similar story.
yeah. So I went from 0.58 to 0.64, uh, which is where the auto linking support came in,
Oh,
and that
yeah.
was like insane. Like we had a lot of manually linked packages. So in the end, just created a new repo, copied code manually, corrected the diffs. That's just what worked. And our current strategy is to hold off updating until like two releases. So if you're on 0.66, we only go into, or if you're on 0.64, we only go to 0.66. We skip the 0.65 release, so that you don't go through the pain every month.
Right.
But I have to say that it's become much easier over the years with upgrade helper, and if you don't have a lot of native customization, uh, it's definitely become easier over the years. But
That's
yeah, I
true.
mean, with Expo, it's just change the version number and you're done. So
Right.
you can't beat that.
And also Expo provides a nice CLI to tell you if some package is incompatible or maybe you have
Right.
to look into it. So yeah, that made the dev experience very smooth.
Yeah, I mean,
Got it.
recent upgrade from like SDK 44 to I think right now it's 45
45.
of
Yeah.
Expo. Yeah, so it was like seamless upgrade. I mean, we were on 0.64 in that Expo SDK, and now we are on 68. So it was like it was done in like few hours. So that was really cool. And yeah, I mean, so with like this new Expo Dev client, Expo Dev client is basically like, so in earlier versions of Expo, we whenever we build an app on native side, there were some like SDKs, native SDKs, which will go into that build, right? But in new Expo, if you are using just Dev client, then only those native code will go into it that you are using. So that's also really cool and feature of dev client. So
So one interesting workflow with dev client is, uh, since the dev client has all the native code, in it, you could actually now start distributing the dev client to developers. So people can actually, people with a Linux system, for example, they can develop for iOS with all your native code. That you can skip out the compile step completely, uh, or basically or with React, just web developers, right? You can give them an APK or a way to install the IPA through, I don't know, Firebase app distribution or something,
Right.
and then they don't even have to think about the compilation steps anymore. They can just start writing JavaScript. So that's like a killer feature for dev client. I don't know how many people have used it. I've played around with it, but I don't have a use case for it at my workplace because everyone uses a Mac, and that's all native, like a couple of native developers uh, over here. So I think that's really cool. And the same workflow will work for QA testing also. You can give out the built dev client to QA engineers, and if they have signed into their Expo accounts, they can pick release channel, like if you have staging dev or whatever else, and then continue from there. It's like instant deployments for QA. So it's some
Right.
pretty cool stuff. The Expo guys have not, I don't know, at least to me it feels like they have not published or advertised this too much. Uh, in fact, they should. I mean, it's a pretty awesome feature. Dev clients are cool. You guys, all of us, you should really check it out.
Interesting. So does this basically mean JavaScript updates, or does it mean native updates? I mean, just like
No,
how code.
it'll only work for. So think of it like this way. Earlier, you had the Expo Go client.
Hmm.
which is which had all the Expo native packages
All the
installed, the
packages. Right.
animated
Right.
maps, all of it, right? Expo Dev Client is a customized Go client,
Right.
right? Uh, uh, you can only include all the packages that you need, so that the binary size is small, and you can also add third-party native packages, which are not
Right.
first-party, first-class Expo citizens.
Right.
So when there is a native change, of course, you have to now update the dev client.
Hmm.
But for any JS change, it just works like code push.
Right. Right. Right.
It's like just a simple command. We are using this feature for internally distributing the distributing the builds. So it's just like a simple expo es build command. So the
Yes, Bill.
feature is that's a es feature. So the native build will be generated on expose cloud, and you just have to register like which devices you want your app to run. So yeah, it will be just install the app and use it.
Yeah, one full ecosystem coming up together for React Native. That's interesting to
Yeah.
see. Yeah.
And also es submit command, that is just like magical. I mean, if you have like tried distributing application via iOS app store or things, then you know like there's like a lot of things you need to know, like certifications, provisioning profiles and stuff, and all that is like magically handled by es submit command. So I mean it even it locks you on your Apple login, and it does like everything. Yeah, it just keeps on asking you questions, and you just have to accept, and your like build is submitted. So that's like really awesome.
Yeah,
It
it
kind of
works like.
reminds. Sorry, go
No,
ahead.
go ahead,
Go ahead. Go ahead.
Muslim. Go ahead. Yeah, I was
I'm
gonna say
just thinking that it kind of reminds me of how Next.js did it to React, right? How it built up an entire ecosystem. And that's what Expo is doing it to React Native, right? It's building up this entire flow where you can do it from 0 to 1. Like entire company can be set up just using Expo from development up until productionizing things right from 0 to 1. So that's interesting. Sorry, Peter, go ahead. I'm sorry to cut your line of thought.
no, so I was gonna say, Expo Submit is like a very well done Fastlane script on steroids. Like to tweak and get that Fastlane script takes a bit of a time,
Yeah.
but with the Submit, it's just solid. Interestingly, there is this app.js conference happening right now, and Expo guys just announced EAS metadata. So what that does is it allows you to it automates the screenshot capturing and all the other stored metadata submission automated. So that is also becoming like a one-click thing now. I've not seen it in extensive detail yet, but they just announced the new thing like I think a couple of hours back.
Awesome. Awesome. Live updates with Peter.
Very interesting. I mean, it's
Just
refreshing to hear lots of praises to Expo, because usually in conversations that involve React Native devs and native devs, they usually are resistant to using Expo, saying that Expo kind of limits you, things like that. And yeah, I'm happy to see that it's actually making a lot of advances in the React Native world.
Yeah, in fact, like 6 months back, I would have said don't go with Expo. Right now, I would say just start with Expo, then eject
Yeah.
out if you need to. So made a lot of
Right.
tremendous amount of change.
I mean,
Right.
they're also giving back to the community, right? That's
Yeah,
what makes it great. I mean, they're not forking out; they're still giving back to
exactly.
React Native, so it totally makes sense. Yeah.
Cool. So let's move on. Maybe talk about some new and exciting features that React Native. I mean, we can see on the horizon. Like for example, the new architecture like GSI, turbo modules. So, what do you guys have to say about that?
I am damn excited about JSI. To be honest, I was listening to Aditya's talk in the afternoon, and the possibilities of using something like JSI and being able to call our native modules in a synchronous fashion. It's as good as it gets, right? I mean, that's what you do at a native layer, and that's if you're getting the flexibility of doing that from a JavaScript layer, and the internal linkings, which are C++ linkings, are all code generated, it just makes it easy. I'm just skeptical of how fast can this be, because all your libraries would have to go through those upgrades too, like all your dependent ones. So how soon can we make that change and see things in production? But from an architectural point of view, I'm pretty damn excited to see that come out and in the React Native ecosystem.
Yeah, so like here also, I mean, the inspiration for, I mean, like synchronous executing is taken from the browser APIs, right? So if we do like document.create element, append child, like query a node, we get a reference of an object that is inside the browser engine. I mean, we can like directly set its width or like set its color, something like that. So yeah, here also we will be like able to directly create node append child like directly in a synchronous fashion. So that's really cool.
Yeah, I just hope that turbo modules land soon and the JSI process is all abstracted out from you, because I really don't want to dust up my old C++ books and figure out what is going on. And at least that's what my understanding is. You write most of your code in TypeScript or Flow, and it can generate the C bindings for you with the React Native CodeGen tool. So yeah, like hope you don't have to do a lot of custom C++ code like the current JSI libraries. Like I tried reading
Right.
one of them and I was like, what is going on?
I mean, that's kind of like what most people must be feeling with when JSI came out. Okay, now do I have to learn another language now to do
Right.
React Native? I mean, wasn't Java and Swift or Objective C not enough already? Do I have to switch over to C++ as well now? I mean, that's a common question when you hear when somebody talks about JSI, but I'm guessing that all will be abstracted out. But when I look at the advantages, I look like, for example, I was looking at it the other day, like on layout is something that you can call on view and all of these things, right? And that's like a asynchronous process to
Right.
get .x, .y, .h, .w on any element. And then when you look at web, you have something called as get computed style, which just gives you synchronously. I mean, it's expensive. You shouldn't be using it all too often, but still you get it, right? And that's just the power of synchronous, right? Now you can whatever, you can immediately do things that you want with it. Imagine running pan responder animations after you know your sizes beforehand, right? Without having to delay it by a frame or how many ever frames that it returns after. I mean, its possibilities are crazy.
Yeah.
Yeah, I mean, a few new libraries are already using it under the hood, reanimated gesture handler,
Right.
and
Yeah.
MMKV. We all seen the like performance benefits of all of them.
One very interesting library that I'm really bullish on is React Native Vision Camera. It's from Mark, the same guy who's working on MMKV, and he's working on a bunch of awesome stuff like Wishlist. Wishlist is a JSI backed list implementation which will apparently take away the dreaded white space when you scroll while I issue. So yeah, React Native Vision Camera, like it's a camera plugin, of course, but more than that, it allows you to write JSI or JavaScript functions which run on the native thread, which can analyze or process the frames. So, for example, a couple of plugins that already exist are like one which works for a face detection as a face detection plugin. There's another for QR code scanning and OCR scanning, and the whole thing works by bypassing the bridge. So it's like damn fast, and uh, possibly you could build something like Instagram filters in React Native, which was seemed impossible like a while back.
Right. Is this something that how even reanimated is kind of approaching the problem using worklets, that it will then push
Yeah.
over to the UI thread and then that guy will handle all of those things? Is
Yeah,
it similar?
so initially Vision Camera was directly using worklets. I mean, it had reanimated as a dependency.
Right,
I think they've recently moved out of it, but I'm not entirely sure.
right, right.
So it was direct, like in fact, directly using reanimated's worklet capability.
Hmm. That's interesting. Bunch of new things, man. I mean, you mentioned about MMKV as well, right? MMKV async storage has existed as long as React Native has,
Right.
right? And becoming 40 times faster than async storage, and even WatermelonDB by a factor of 4 or 10. I don't remember. I mean, that's insanely fast.
Yeah. So,
Mm.
but that benchmark, you should probably take it with a pinch of salt in the
Pinch of salt,
sense,
yeah, yeah,
yeah, like all benchmarks, of course. Like the async storage versus MMKV one makes sense because they both serve the same purpose. You store key value pairs uh, uh, right, in a DB. Watermelon gives you querying on top of it. It's not some
right.
like it's a full blown SQLite database, right? But yeah, I mean, I've been using MMKV successfully at Savage for persisting any like small bits of data. The biggest change is that now you don't. It's not an async storage layer anymore. It's fully synchronized, and you can write like a couple of listeners on those. So all our auth layer stuff is on MMKV, and it just works really well.
Nice, man. Nice.
Right. And one more thing I think we have to discuss about this GSI and the new architecture is that these concepts will slowly start moving into the base components that React Native itself provides. So, for example, view, text, or the scroll view, flat list. Once the Fabric renderer or the GSI concepts land on these components, the React Native uh, library, the framework as out of the box becomes a lot more performant than what we have right now. So we as users, even if we kind of use slower packages like React Native async storage, it would the major performance gains would be coming out of these the
Right.
base components like view and flatlist. So I'm more excited about these things landing on the core packages like view and text and things like that. Yeah.
Yeah, so one big promise with the Fabric renderer along with turbo modules is that they will get rid of the infamous flickers that we have when certain pages load. That's what I'm really excited about. It's a very minor thing, but it looks bad when your app is loading up. Why is that flickering? Why is this form field flickering?
Right.
Uh, it just doesn't give that. It takes a lot of effort to polish and get it working very well. And I have to say, like Ananthu, like the work you guys do at Small Case is like really awesome. Like I really love the app. I mean, I'm a daily use it every month,
Okay.
for SAPs, but insane stuff from Small Case.
Yeah,
Glad
man.
to hear
So,
that. Thank you.
is it like a pure greenfield app, the small case app?
No, so the small case app is not brownfield at all. It is purely React Native, very low custom native code that we write. So we try to do everything on the React Native layer itself, and then we obviously do care a lot about performance, but then we also don't over optimize. Like we don't prematurely optimize. I think we just care about writing performant and good code, and then that shows up in the app that it generates. So
Nice.
talking about performance, what do you guys, um, any tips that you guys, keep in mind when you're building React Native apps to keep like a base level performance in apps?
So yeah, I mean we are using lists, like a lot of lists, and so yeah, I mean make sure like you are following all the recommendations given in flatlist documentation, that like if possible you implement get item layout, and all your render items are like memoized items, so they are like don't re-render unnecessarily. And yeah, I mean, lists are the like biggest like performance, like they are the ones who that create the biggest performance issues. And we're also using recycler list view in our feeds. Yeah, so that is really cool. And yeah, for benchmarking, mostly we use this the performance monitor in React Native. So you can see your like JS thread FPS and UI thread FPS. So based on that, and like if JS thread is dropping, then we mostly look into like which component is re-rendering. So there are some packages that can help you with that. Mostly we do console log or see like what issues are there. And also there's a cool Flipper plugin now that we can use to monitor those threads. And yeah, and if there's like UI thread performance is dropping, then you can check it in Xcode and just see like if memory consumption is like really high, maybe like you are like creating too many images or video objects. So yeah, I mean, in our app we had like lots of videos and lots of images. So we just noticed that like if you mount more than 4 to 5 video instances, like video instance can be like from React Native video or Expo AV, but if you mount more than that, then app crashes. So yeah, I mean, those are the things. So we after that we started using this on viewable item change from flat list, and only mount video instances if the item is visible. And even if you mount the video instance, it will still crash even if you don't play the video. So yeah, so for that we analyzed the memory consumption from Xcode, and later then we found that okay, so we better we don't mount the video at all. So yeah, we are just mounting it on like when the item is visible. And yeah, and also I mean, the Xcode tools can be really helpful if you want to check out the layout hierarchy, like how many views are mounted and if they are not getting like deallocated and things.
Interesting. I wanted to add a few things like for the list view, again, we use recycler list view, which is sort of an in-house solution that we have. It sort of works out of the box for deterministic, non-deterministic scenarios for us. Um, Image problem is something that I think happens with everyone once they start rendering long lists with images and everything. And one thing that we saw for videos and everything is that you could render just the thumbnail, and once things actually people end up pressing rotate and bring back the video so that you don't really take up the memory of a video in that card, right? Even though you might not be playing it, it gets mounted and gets shown. So that is something you might look at. Nishan, I'm guessing you might already be doing it. But again, image caching on top. Sorry, go ahead.
Yeah, I mean, this was more like a TikTok like interface where users should be able to like swipe and it should play. So like before switching to TikTok like interface, we had like simple scroll feed. So there like yeah, I mean, it's like continuous scrolling and not like swiping. So that time we had like yeah, like see if user is on the screen and then play. So
Right.
yeah, I mean, actually we switched to that solution where you just show the thumbnail first, and as soon as that view is visible, you switch it to video.
Right. I mean, there's a delay to it, but I think that's kind of
So
manageable.
yeah, actually we added a like interesting way for to prevent that delay. So we started using a sort of window like thing. So like you load 3 videos and play the center one and pause to above and below. So you go to like next, you do the same like for like every swipe. Yeah, that
It's like
prevents
a
the delay.
pagination for videos in that case, right?
Yeah.
Right. Right. Nice. Nice, yeah. But to add to that, we also like for performance, I think we also ended up using a lot of native, IDs like Android Studio for a lot of memory profiling. How were our apps doing in terms of when it comes to profiling? It's also end user profiling, like how is our app performing in terms of crashes and errors and all of those things. So we were actively monitoring our ANRs, which were being logged at a Firebase level for Android and similarly for iOS as well. So that also becomes critical. And I think it becomes very critical to see how is your app doing in release modes, right? With all your ProGuard plugins on, all of your bundle sizes as optimized as they can be, right? And then running benchmarks on top of, one is FPS benchmarks, of course, and then between devices, like the range of devices that you end up supporting, right? One is the low end device and one is the absolute high end device, and how does your app end up performing in terms of what are your metrics for, let's say, TTIs, FCP, and whatnot, right? So all of those have to be in a range that you define for your app to be across your devices that you support. So that is also pretty critical for us, right? Because we do support a bunch of devices.
Yeah, at Flipkart scale, it is obviously very critical.
Yeah.
So actually, I think we don't like we just test it like for iOS 13 in simulator, and not below that. But yeah, I mean, yeah, at Flipkart scale, it's very much needed to support like lowest end device. And
Yeah, I mean, it's kind of necessary at this point.
Yeah.
Yeah. Cool. Ananthu, you are on mute, I guess.
Sorry. Yeah. So speaking about performance, what do you guys think about comparison between React Native with other libraries out there like Flutter or Ionic or things like that, where Flutter promises better performance than React Native, and Ionic I think is just ease of development because of that. You guys have any thoughts on that? Why you would choose React Native over there?
Yeah.
so
So I recently came across this podcast from the Infinite Red guys where I think it was Gant Laborde who said, Flutter is better than React Native in all the wrong ways. You know. So I think the underlying thing is, the you have to get developers. Like, let's face it, right? It's not technology for the sake of technology. It's technology to solve problems, and we need people to solve problems, and then we need people who know a particular technology to do it. So it's just easier to hire for React Native developers, or let me put it this way: it's not easier to hire for React Native developers. It's easier to hire for web developers and then train them to be,
Yeah. Yeah.
React Native devs.
Well said.
And yeah, and you know, JavaScript, yes, it gets a bad rap, but the world runs on JavaScript, so there's a lot of people who get into JavaScript as their first programming language. So it's just easier to hire with React Native and React. And like initially for Savage also, I started evaluating Flutter, and then there was just majorly one thing that killed it, which was being able to do code push. Like
Yeah. Yeah.
that's insanely valuable feature. If anyone has worked with App Store, they know that waiting for app reviews the night of your release is a nerve-wracking experience. Um, so yeah, like for those two things alone, like React Native is the winner for me. And then add on top of that, the whole JSI and Fabric renderer coming up. It's just going to get him even more, valuable. And for that matter, React Native Skia is a library, that's coming up, which kind of has similar API to Flutter. So you could potentially write Flutter apps in React Native. So what's the point anymore?
Like JavaScript is here, where are you?
Right, exactly. And they recently demoed React Native Skia running on web too. So it's like a killer package that's gonna kill Flutter, hopefully.
Really?
Not trying to be controversial, but
No, I
React
totally agree. I mean, there is some bias to our decisions, obviously, because we've been using it for a while now. But
Yeah.
all the right points, right? With JSI coming in, all the asynchronous flows go out of the box, like out of the picture, and then you have code push, and you don't have to learn a new language, right? You don't have to learn a new system of how things work, and the ecosystem is by far better than what it is for Flutter, right? So you have a bunch of packages coming out, full-blown companies working on it. Let's say Airbnb did first, and now Shopify doing the same thing, right, with React Native. So that's just, and working not because they're supposed to, working because they like the framework and library as such, right? So that is one great thing that I feel React Native has over Flutter.
Although I have to say one thing, I mean, it might sound a little controversial, but what I found with Flutter was the quality of their native packages or native third-party packages felt better than React Native packages. It could be because, it's mostly JavaScript developers trying to write native code, wherein Flutter, like since it's backed by Google, a lot of native developers have kind of gone into the Flutter route. So that felt like a good place where Flutter was doing really well. But I don't know. I mean, I haven't followed Flutter development for like quite some time now. But initially, at least the native libraries were good quality.
Also, I mean, there are like a lot of widgets and a lot of like component libraries built and shipped by Google in Flutter. So that's like very easy for people to use that.
Yeah.
But I think Flutter gets a bit of I mean, it gets criticism for not maintaining its own widgets. So, like, I've seen on the Reddit Flutter subreddit where, the Flutter team inside Google is not a very large team, but they're a set of small, very passionate engineers for Flutter and Dart. But they have such a huge library of widgets that Flutter natively ships that they find it hard to like maintain all those widgets all the time. So like Android can come up with a new uh, like new component. So the Flutter team has to build that same thing in Flutter, right? So apparently it was taking them time to build their own widget. So uh, unlike the lean core approach that React Native takes, where the core React team just maintains the core functioning of React Native, and then everything else is left to the community.
Right. I mean, that's an interesting point of how are they uh, approaching this whole uh, transformation, right? Of, let's say, people adopting Flutter. Should everything become like a marketplace where everybody comes in and pitches, or should you in-house own the widgets, right? These are two different models of how the components get started in the whole developer world, right? So, yeah, let's see who wins. My money is on React Native as of now.
I mean, yeah, we have Scan also. I don't think I'll be learning Flutter like very soon. No, yeah.
So all
What is
this
one
praise
of
for
the
React Native, what is like one pain point that you guys feel the most when developing in React Native?
Okay. I think for me is that when it becomes to crude problems, when it comes to actual problems that are behind your JavaScript world, you kind of feel a little lost, right? Okay, should I go into native and should I go and fix it? Should I look for a package? Does it solve it all of a sudden? Because it's hard to have expertise in all three domains, right? iOS, Android, and JavaScript, right? You occasionally become a master of one, leave aside becoming a master of three, right? So that is a tricky road to take that path, right? Then you need help of other people who are masters in these two other domains and figure that problem out. So it becomes a problem that you alone can't probably fix it, right? You need a team of who know this better. So that is one problem that I felt is hardcore to React Native developers, that they know one domain very well, but then when the problem goes outside that, what do they do? It becomes hard.
Yeah, I think I mean that's really true. And if developers are coming more from web background, and
Yeah.
but I really think we should like learn at least iOS or Android, like have a little bit idea, of so that it can be easy to debug stuff.
Yep.
Yeah, one pain point that this is a very nitpicky pain point, but working with keyboards on React Native,
Oh yeah.
I don't know. Maybe it's because our app has a lot of like couple of forms in there, and then so like working with the keyboard is one thing, and then working with the keyboard gracefully is a whole like a whole another thing, right? We can get it to so that like the UI jumps around and the keyboard kind of works, but smoothly animating stuff out of the way and things like that is currently a little painful. Then when Hermes came out, the debugging was a little bit of a pain, but it's kind of like stabilized now with Flipper working really well.
Yeah.
Yeah, like I really can't think of much else right now. Like there was a point where like the whole state management thing was a little bit of a pain, but it's kind of as I've gotten used to it, it's become fine. I mean, it works.
Nice.
Cool. I think we are almost out of time. Maybe we can end this discussion with each of you telling us like what you're most excited about with React Native, and yeah, and any final thoughts.
GSI, hands down. I mean, I don't even have to think twice.
Yeah, new architecture and writing universal apps with that.
Nice. Yeah, like I want to see how like Fabric Renderer will make things better for the ecosystem, and I'm also really looking forward to React Native Skia, and I think that will be the key to bringing out a lot of well polished, full of micro animations kind of apps. Even though Reanimated is there, I mean Reanimated and Skia will work together very well to give out like that popping, apps like slick animated, like super cool apps. That's what I'm looking forward.
Great, awesome. So I think with that we can conclude this talk. It was great talking to you guys. Thank you.
Good
Thank you,
talking to you,
everyone.
everyone. Thank you.
Great one, guys. Thank you.
Bye-bye.
Bye.
Hello, everyone. With that, we not almost now, but we've come towards the end of the conference.
Yeah.
And yeah, I guess we had such a wonderful 2-day event, and there's so much that we learned in the process. So much fun that I had emceeing with Megha. So really glad this happened. And over to you, Megha.
Yeah, I'm like genuinely very glad that I got to MC this year. Like, I would like to thank Kiran for this opportunity, and it would feel like my thank you speech now. But yeah, never mind. And yeah, I genuinely had a great time, and I might jump a gun here, but yeah, I feel like it was better than last year, just because like Tanisha was co-MCing on my side. But anyways, like most of the like people we see around, like you know every last year was like just a turning point for me personally, career wise, to like meet all these people in the community. And this year, like there were like a lot more additions, so it's so great to meet a bunch of folks in just 2 days, and like gradually add upon our knowledge. So pretty great, and lot to catch up on. Like I have been like making notes of the talks I like really like. So great time. I think we should invite the man behind all this to the stage now, and like he should like really talk about his own experience. So we would like to
The
bring upon
one-man
Kiran.
army
Yeah,
behind the entire
he
React
has
Day
been like
India
running.
2022 and 2021.
Yeah,
So, Kiran, over to you.
yeah.
Yeah, thanks, Tanish, and thanks, Mega.
I I
Let
can
me.
see the T-shirt, React Day T-shirt on you.
Yeah, I have to wear it, right?
Yeah.
Yeah, yeah. Let me share my screen as well. So yeah, so hi everyone. I hope you enjoyed the conference. Uh, it felt like the 2 days went really fast for me. Yeah, yeah, we have been working for this conference for last 4 months. Yeah, glad that it works out. Hope you enjoyed the conference as well and learned a lot. Yeah, thanks for joining. And big shout out to both the MCs, Mega and Tanisha. They did a really amazing job, and even before the event, they helped me a lot in coordinating and getting everything right. Um, yeah, thanks a lot for Mega and Tanisha for making this conference really great experience for everyone. Um, and huge shout out to Sri Lakshmi Satri as well. Uh, she helped us a lot in running the event for the last 2 days. And thanks Sri Lakshmi for volunteering. Yeah, now that we are at the end of the conference, I want to take this opportunity to thank our partners, Devfolio, Peerlist, Recro, React India for helping us in promoting the conference. Huge, huge shout out to our sponsors, platinum sponsors, Cast24, Mercari, Postman, Storyblock, and our gold sponsors, Grow, Misho, Porter, Koalem, Small Case, exactly, and our silver sponsors, Harness, Razorpay, Turing, and our bronze sponsors, Assembly, Geeky Ants, and Swiggy. Huge shout out to them. Because of their support, we were able to run this conference for free, and we will also be able to give a lot of swag. Yeah, we didn't announce much within the last 2 days, but a lot of attendees will get the swag. Stay tuned for that. Maybe we'll announce next week. Yeah, once again, thanks for all our sponsors for supporting us and for supporting our community. And in general, I want to thank all the community members, for supporting us over the years, and of course, for the last 2 days, and for joining the conference and supporting us on the social media and on the conference itself. Okay, now that we are at the end of the conference, what's next? Uh, Our first order of our business will be to bring back the in-person React Bangalore meetups. It's been a while. We are missing the in-person events a lot. I think we stopped the in-person events in 2020 because of the pandemic, and hopefully, I'm seeing that early signs of we are getting back to normal, and some companies are resuming their coming back to offices and everything. We are hoping that we can also resume our in-person meetups in a month or so, hopefully 2 months. Yeah, but we'll start working towards that, and slowly start bringing the in-person meetups so that we can meet in person and learn more. That's there. And yeah, and we also want to launch a lot more initiatives with React 5. um, so like the way we look at Reactify is kind of uh, we have like bunch of names, right? We have React Bangalore, we have React Day Bangalore, we have Reactify. So we have like different names, but the way we want to project ourselves is we want to have the Reactify as a community organization where Reactify does a lot of initiatives. So far, we are using React. Earlier, we used to do in-person meetups with the name React Bangalore, and once the pandemic hit, we started organizing online meetups. And since we started hosting online meetups, it didn't make sense for us to call it as React Bangalore because it's for everyone, right? It's for all the developers across India. So we want to choose a place neutral name, so we chose Reactify. And for the last 2 years, we have been hosting online meetups, online workshops, and we were using Reactify names, which is working out well for us. But our vision for Reactify is much bigger than meetups, and we want to do a lot more. So we were trying to kind of bring in all our previous work as well into the Reactify. For example, React Bangalore, we treat that as a sub community under Reactify. Even the React Bangalore conference, right? We'll treat that as a sub initiative of Reactify. and our plan is to launch lot more initiatives. We don't want to restrict ourselves to meetups and conferences. We want to do lots more, and our true vision with Reactify is to build a really good community that connects developers across the initiative, and we will do whatever it takes, let it be hosting meetups, let it be hosting conferences, and we will think of lot more things, and whatever it takes, we'll try to implement them and build a very good community, so that all of us can get together, learn from each other, and connect and improve or as a community. uh, so you'll also notice that we want to put this message out. We want to share our vision for Reactify. That's the reason for this edition of the conference, right? We used the Reactify name, a Reactify theme for swag as well. So for this edition of the conference, I'm wearing a React Day t-shirt. But for this edition of the conference, we will be getting Reactify t-shirt and Reactify sticker, because we want to take this opportunity to put out the message or put out the vision of Reactify. Yeah, and you'll hear a lot more about Reactify from us. And as I said, our true vision with Reactify is to connect React developers. We chose React because we want to be focused while implementing that. So for that particular reason, we chose React. At least for now, we'll focus on React and Frontend, so that we have a common theme for community. So that's the reason we are more focused on React. But in general, we want to be a better software developers. But for the community sake and for the focus sake, we chose React. But in general, we want to be connecting developers, React and Frontend developers across India. Of course, React and React Native and Frontend developers across India, to learn from each other. Of course, this year we had to do an virtual conference. Ideally, we would like to do an in-person conference. Because this year, because of the pandemic and other constraints, we chose to do an virtual conference. But early next year, we are planning to do an in-person conference. Hope things will work out. Uh, yeah, looking forward to meeting you in person soon. Yeah, I think that's all I have for today. And I hope you enjoyed both the days and learned a lot. And yeah, looking forward to again meeting you in person, and on of course online as well. Because with Reactify, we'll continue with the online initiatives. Uh, and of course, we will add the in-person events as an addition for the online event, so that we will be doing both in-person plus online activities together, and trying to build a very strong community. Yeah, see you soon again. Bye.